Good morning, ladies and gentlemen, and welcome to the Zak World of Façades Thailand conference. The conference today is the second edition for Thailand and is the 95th edition of conference globally. So first of all, thank you very much, all of you, for being here with us bright and early today. My name is B, and it is my absolute pleasure to be your host for today. ขอสวัสดีนะคะและขอต้อนรับผู้มีเกียรติทุกท่านนะคะที่เข้าร่วมประชุมในวันนี้ค่ะก็สำหรับงาน Zak World of Façades Conference วันนี้นะคะเป็นการจัดการประชุมครั้งที่2ในประเทศไทยแล้วก็เป็นการจัดการประชุมครั้งที่95ทั่วโลกค่ะก่อนอื่นเลยนะคะขอบพระคุณทุกท่านที่เข้าร่วมประชุมในวันนี้นะคะตั้งแต่เช้าเลยสำหรับบางท่านอาจจะรู้สึกว่าวันนี้เดินทางมายากนิดนึงเพราะว่าน้ำท่วมนะคะดิฉันสุภาพิชุมสายณอยุธยาขอรับหน้าที่เป็นผู้ดำเนินรายการในวันนี้ค่ะWe have an exciting lineup of programs coming up today, and before we start, please allow me to give everyone a gentle reminder to keep all your phones on silent mode throughout the entire sessions, all sessions today. ขออนุญาตเรียนเตือนทุกท่านนะคะว่าให้ตั้งโทรศัพท์มือถือเป็นโหมดสั่นนะคะปิดเสียงตลอดเซสชันทุกเซสชันในวันนี้เลยค่ะโอเคและตอนนี้นะคะเดี๋ยวสามารถเริ่มเดี๋ยวจะเรียนเชิญผู้ขึ้นมากล่าวเปิดงานเลยนะคะ And to give today's conference an official kickstart, ladies and gentlemen, please welcome me in inviting to the stage Mr. Ahmed, Director, Zak World of Façades, Trades and Exhibition.
So good morning, everyone. Welcome to this 95th edition of the Zak World of Façades conference. As B mentioned, this is our second edition here in Thailand. We had a fabulous first edition back in March 2018. And we were to repeat this March 2020. This was our first event of 2020 originally planned, and we had to call it off 1 week before the event. It was a tough time for all of us, I'm sure. But slowly with the world coming back to normalcy, we are back to in-person events again, and we are back to Thailand. We've got a fabulous response for this event, over 400 registrations. I hope people are able to make it today and the rain doesn't play spoil sport. Crazy rain last night. I hope the waterlogging is not too much for people to not be able to make it today. Thank you all for being able to be here in present. I'll quickly introduce the event for those who are attending the event for the first time. And I'll just thank our sponsor partners. They've been extremely patient with us. As I told you, this is an event which was planned in 2020, did not happen due to the pandemic. Waited till Thailand opened and then saw the right opportunity to execute the same. Regarding Zak World of Façades, as I mentioned, this is the 95th edition. We are organizing this event in 35 countries around the globe. Literally every corner except South America, we are literally everywhere. It's an event which we originally started in India back in 2012. It's grown from strength to strength. Primarily because facades are getting complex. They are no more your straight glass boxes. They are much more to facades than just straight buildings. So facade engineering as a profession is also being acknowledged and is being growing globally. That has been able to spurt growth for this conference series throughout the globe. Wherever you go, people want to know more on the facade. They want to experiment more with facades, and facade engineering, facade consultants as a profession is also picking up. So there's a lot of excitement in this field, and I'm sure going forward, it's only going to get even more complex. And then events like this, I'm sure, could give you ideas or help you in designing your next project. Of course, this event is not possible without our event partners. I'd like to thank our presenting partner, Schuko, once again with us. So Schuko is a world leader, is a German manufacturer, is a world leader in aluminum door, window, curtain wall systems. They've been a very strong supporter of this conference series globally. They work with us in 30 of the 35 countries we are present in. They've championed this effort and helped us support new initiatives in new markets. So they are our presenting partner for today. We have AGC Glass. So the division presenting today is the active glass division, where they have a BIPV product. So energy generation through the facade is now picking up, and a lot of advancement has happened in building integrated photovoltaics as from when it was launched. So AGC are showcasing their range over here. AkzoNobel are a leading coating manufacturer. They have powder coating and liquid coating solutions. This is the powder coating division of Interpon exhibiting with us today. China Southern Glass is one of the leading glass manufacturers out of China. Dow doesn't need any introduction. It's a global chemical provider. So this is the sealant division which is participating. Originally we knew them as Dow Corning Dowsil. So this is the sealant division ever present with us throughout the globe. Elval Color is a leading manufacturer of non-combustible composite panels. Composite panels are under the spotlight for obvious reasons in the last few years. Elval have a solution which is a non-combustible one, originally from Greece. Florum is an Italian manufacturer of a sintered stone. It's a very unique product, non-combustible cladding material. You'll be hearing from them what it is later in the day. Curare is the parent company of Trocifol and Sentry Glass, which are basically interlayers for making laminated glass, a very strong supporter of ours throughout the globe. Search Ferrari is a French company. They have fabrics which can now be used on the facade also. We obviously use fabrics on tensile structures, but now this is being applied on the facade. You'll be hearing from them on how to design a lightweight facade using fabrics. Siderise is a British manufacturer of cavity barriers and ventilated and fire stop, which is basically a solution for ventilated facades and for curtain wall pacifier protection. Sudal is a Belgian leading sealant manufacturer. They have door, window, facade sealants and PU foams. Techronair is a leading Indian manufacturer of modular railing systems. So freestanding clear view railings are now the preferred choices in high rises and beach facing villas. So they have a lovely modular solution. Vector Foiltech is a German company doing ETFE, which is basically a lightweight roof facade solution. More about them in their presentation. And Orca Data is a software company from Germany. They have interesting software called Logical for estimation of facade and door window elements. In the region, our next event is in Kuala Lumpur a month from now. Of course, originally the Thailand event was planned for March. March is when we do the event, but because of Thailand not opening up in March, we had to postpone the event to July. Malaysia is next. In Asia, we are continuing with Japan, which will be our first edition in Tokyo on the 12th of October. And then we've got our second edition in Vietnam, in Hanoi, end of the year. We had a fabulous event in Ho Chi Minh, August 2019. So these are the events which we've been doing throughout the region, and our main goal is to talk about new technologies, innovations on the facade. I'll just give you a quick overview of what's happening in Europe, in the US compared to Asia. So in Europe, it's all about low carbon facade design. I'm not sure how many of you heard of that, but people are talking of low carbon facade design, you know. So you have two components. You have an operational carbon and you have an embodied carbon. Operational carbon is the carbon the building emits after the building is being built, whereas embodied carbon is the carbon content in the materials, in the processes, in the transportation, in the logistics before a building is being built. In Asia, we are too much concerned about operational carbon, rightly so, because we are yet to reach operational carbon. But in Europe and in America, especially Europe, they are obsessed with embodied carbon. Going forward, this will be a trend in Asia also very soon, where every material manufacturer, every procurement process, every design has to incorporate low carbon design to basically take care of embodied targets. So this is what's happening in Europe. What we see now is real climate change, excessive rains, flash flooding. All these are signs that we need to get our designs right. We need to get our buildings right, and it's not about occupant comfort anymore. You also need to look at Mother Nature around. You know, it's acting wild. The record heat waves in Europe are shocking. They don't even have air conditioning. I mean, 40 degrees in the UK, I get messages, oh, it's so hot and all that stuff. For me, it's common, 44, 45. I come from south of India, Chennai, so for me, it's common, and I laugh. But you have to understand that the buildings over there are not designed to take so much heat. They pack with so much insulation, and during summer, they face overheating issues. We don't face that in Asia, but for them, it's a big challenge. So their homes are basically furnaces, you know. So things like this need to be factored, and going forward, embodied carbon will be the way forward. But the best part for Asia is Europe and America are doing all the research. They are bringing tools, they are bringing softwares out on how to calculate embodied carbon. And by the time this becomes a trend with developers, with investors in Asia, we will have tools and resources from Europe, from other parts of the world to be used in Asia. The challenge they are facing over there is, yes, they know they need to do this, but they don't know the way. So there are different people who are working on ensuring that embodied carbon is easily met through software, through estimation, through tools. Quick housekeeping rules, B would have already mentioned, but if you can put your phones on silent, that would be great. We will not take any questions due to the paucity of time. We started late because we wanted some people to come in. People are stuck outside. So we won't be taking the questions. Our speakers will be around in the networking breaks. Please meet them. Also, I please urge you, don't be shy. Go meet our event sponsors. They've waited for 2.5 years for this event to happen patiently. They've invested heavily with us. Please meet them. Please see the products around. You never know which product might be the best fit for your solution, for your next project. So please meet them. They've been waiting to meet you people in person. And of course, network with your industry colleagues and peers. All the delegates and the speakers have a USB stick, if you notice on your lanyard. So the USB stick has all the brochures of the sponsor companies loaded in that. It's a 16 GB USB stick. We are not giving the bags anymore. Don't need to waste paper when not required. So we've moved to the USB stick. So that has a folder which has all the brochures of all the sponsors. We are recording this event. We are not streaming it live. So post the event, we will share a YouTube link with you so that you guys can view any presentations if we have permission to share them. Some of them are confidential, so if they are public, you can see them on the YouTube link which we will share. That's it from me. I'd like to call B back on stage, and she will take you through today's event, inviting and hosting all our speakers. So thank you very much.
Thank you very much. Thank you very much, Mr. Ahmed, for setting the tone of the day for all of us. ขอบคุณคุณ Ahmed มากนะคะ Ladies and gentlemen, before we begin today's program, I would like to inform you again, as Mr. Ahmed already mentioned, that we will not be taking questions for the speakers during or after their presentations, but all the speakers will be here around with us during the networking sessions and the breaks. So that will be when you have the opportunity to speak with them directly. นะคะก็ขออนุญาตแจ้งนะคะทุกท่านว่าเราของดรับคำถามนะครับสำหรับสปีกเกอร์ทุกท่านระหว่างแล้วก็หลังจากที่สปีกเกอร์มาให้ presentation นะคะแต่ว่าสปีกเกอร์ทุกท่านก็จะยังอยู่กับเราทุกๆ networking session กับเบรกนะคะตอนนั้นก็สามารถเข้าไปพูดคุยกับสปีกเกอร์โดยตรงได้เลยค่ะ All right, I think we are now ready to welcome our first speaker of the day. Please give a big round of applause to welcome to the stage Managing Director HB Design Mr. Hans Brouwerขอเรียนเชิญ Mr. Hans Brouwer ค่ะ
Hi, can you hear me okay? Just want to make sure the mics are working. Fantastic. Thank you very much for the introduction. Thank you for Zak for the invitation, which is 2.5 years old. So the presentation you're seeing today is more or less what I had on ice for the last 2 years, since last March in 2020. Today I'm going to be talking about responsive facade design in the tropics. I've selected 3 of our projects in the last few years to exemplify a way of dealing with the building envelope, which is essentially the act of architecture. The idea that at its very base, architecture is about sheltering us from the elements, and the elements provide us with the backdrop to how we deal with that. Too often, I think, building facades are reduced to a single line, very simple frontier where all elements are held at bay. You'll be seeing 2 mixed-use projects, which are office projects with embedded retail, and then 1 residential project. All 3 are developer projects, which means that they're speculative, driven by cost and efficiency and other metrics. So I'd like to consider these three projects as normal projects and hopefully show that with the right thinking and approach, one can exaggerate or elaborate on a facade design beyond the sort of single line diagram, and it's definitely possible. The budgets for these three projects are what I would call normal. On the office projects, the curtain wall has become a sort of default standard. It's a nice, simple design idea, the sort of idea that it is a single sheet of glass, either for cost-effective reasons, sculptural reasons, or just sort of imageability. We have tried to expand that idea of envelope from being a single diagram or single line to a zone where different things are dealt with over a space from the outside to the inside. And on the residential, of course, the building is predicated on a lot of moving parts. The idea of the habitable facade, where balconies, ledges, yards, outdoor units, all of these have to be incorporated in a meaningful way, but also create a nice piece of architecture. So, without further ado, the first project is in actually Ho Chi Minh City. It's a modest project right in the middle of President Park, which is sort of the middle of Ho Chi Minh City. It's not a very complicated building. It's a small office plate. It's a 13-story building with a ground floor with retail, commerce, etc., and then 12 floors of offices above. The regulations in Vietnam require a setback after the 9th floor. So we created this set terrace on that level and used that to explore the idea of the idea of two kind of forms. So there's basically a lower form which we call the cube, which is the prime office areas that open the park, and then the upper form is what we call the wrap, which is a different part of the office. Okay, so that's better. Okay, so maybe I can walk around a bit. Yeah, correct. So the idea was to try and make a building that had a layered facade, which meant basically trying to reduce the cost of the base building, which is the thermal envelope, and trying to develop an external sort of rain screen that allows the building to be sheltered from harsh daylight and insulation. So the original sections looked something like that. The building itself was a simple RC structure. On the left-hand side, you can see what the wrap would look like with a stand-up upstand panel, a simple window inserted into the window wall, and then an interstitial space for maintenance, and then a screen that would cut out a certain amount of daylight on the outside. On the wrap, on the cube, we tried to go for a curtain wall, as it says here, original facade design. Cost effectiveness pushed us to having to do the same base building, but then with a different kind of facade there, as it had much better views out over the park. So there we ended up with an aerofoil facade with, again, a 45-degree cutoff angle to direct insulation. So that was the basic idea of it. When we looked at it in 3D, we wanted to try and elaborate on the floor-to-floor heights. We looked at different materials for the mesh in here. We looked at developing patterns that were floor height, about 3150, large panels with a varying horizontal width, sort of a randomized panel, and then with a series of elements that would be rotated to create a little bit more texture on the facade. The project design went through a number of phases, obviously mock-up prototyping and sort of special sort of investigations happened. You can see in here the aerofoil design, which was again looked at. We weren't very happy with this fixing method as the support structure was cutting through the aerofoil. On the perforated panel, we had to do quite a lot of experimentation with aluminum thighs thickness because it was a very tall panel, almost 3.2, and some of the panels were 1.5 wide. We wanted to cut out quite a bit of the panel with a free area of up to 60%, which was what was experimented when we looked at it. And so at the end of it, we ended up looking at a quite a thick sheet of 2.3 millimeter aluminum, powder coated, and then perforated. You can see in here early experiments of trying to support this with this unusual sort of bracket system held up by a post. But again, in the end result, we ended up being able to eliminate that, and you'll see that in the final outcome. When it came to the perforation panel, we were experimenting with how much we could cut away before the panel became unstable and buckled and was not able to be supported only on the four sides. So hence the 60% free area and the 2.3 millimeter thickness. We used a random sort of circular pattern which had 3 circle sizes, I think 35 millimeters all the way down to about 15. And then were experimenting with the mock-up to see how one could design this so that the eye would focus on what's beyond and ideally sort of mentally screen out the presence of the screen. So here you can see a few pictures of the actual outcome of the building. The powder coating of the wrap was done in 3 different sort of earth tones, from burnt to brown. The idea was to try and design this as a maintenance-free color. We tried it in silver originally, and then after a few weeks, it very quickly becomes dirty. Dust accumulates, rain comes, it streaks. So we thought, well, since most of the dust is brownish, why don't we make the building actually dust-colored? And it turns out that it's actually a fairly benevolent sort of color that needs a lot less maintenance. It doesn't mean no maintenance. You can see here the panels that are sticking out. They have these uplights on them on occasional times, so that become also highlight patterns as the night comes down. And you can see behind the building is a very simple, very cheap building, which is painted plaster and simple single glazed windows. The idea that, again, the screen was done to reduce insulation, but also cut down glare. When we looked at office buildings, we saw that a lot of the time these curtain wall buildings look fantastic, but as the sun whips around and starts coming in, it may not be so much about heat gain, but it could also just be about glare. Today's work environment is very much screen dominated, and so too much light and glare is a problem. And so blinds come down, and what we noticed was that they never go back up. People just can't be bothered to go and move them again. So they stay down all the time, and you wonder, well, what's the point of having all this glass with these fantastic views if you never get them? So here, you can see the outcome. This is the interface between the wrap and the aerofoil sort of facade. The aerofoils end up being 220 mil standard extrusions with the 220 mil spacing, again the 45-degree cutoff. And here you can see this sort of randomized rain screen pattern that wraps around the building on the upper levels as well. On the 9th floor, the cutback became then a roof terrace, where because of the recess of the facade, didn't need any kind of screening. It also becomes where the cafes and the outdoor terraces and the breakout spaces are, and you get a good sense of sort of the scale and change of things here. That's a detail of the perforated panel, and it was an interesting sort of question about material technology, structural strength, patterns, and obviously the framing sizes. That was a first stepping stone into the rain screen design. You'll see on the next project a very different challenge, which resulted in a very different kind of rain screen. And this is what you see through the aerofoil louver facade on the cube. This is the park opposite. It's roughly south, so the west is over here. We understood that obviously at the later hours of the day, the facade is impossible to deal with very low sunlight, and that's usually not possible unless there's some kind of operational mechanical system. But in this case, it's a very simple fixed design system that stays in place. And that's basically looking through. Unfortunately, a camera never does what the eye does. The human eye is trained to look at things in long distance, especially moving things. As I guess in evolution, we were able to see animals running through trees and whatever else because we could focus on bits of movement and in our minds, obviously, eliminate the sort of screen sort of resistance. And the same thing happens in real life when you look through a screen. Oftentimes, it does cut down the amount of light and the amount of visual information, but your eye can see very clearly what's beyond. So this is a picture of it at night. You can see the stripy, very simple window wall facade behind, painted plaster, simple 1400 high windows, so it's nothing particularly amazing. But the idea that we clad that in a very beautiful dress that then allows the building to be something different. The problem with curtain wall is that it tends to be similar, and so one has to exemplify that with different coatings, different colors, maybe some fins, maybe some horizontals, maybe some verticals. Here, I think the facade response was very much a local one, both in form terms, these two elements, and in terms of design, because of adjacencies. That we feel was a very interesting experiment in trying to take a traditional office building to a different place. This is a LEED Gold certified building. I think it was one of the early ones in Ho Chi Minh City. We started this probably around 2009 or 10. And so it was also trying to achieve at least a somewhat higher standard of operational efficiency. The next office project we got was in Pune, in India. It's called Marvel Edge. Pune is a very unique climate, although it seems to be in the subtropical belt. It's actually more of a desert climate. It sits on the Western Ghats at high level. Has a super dry climate. Has 3 basic seasons. It has a monsoon season, that's probably from about June to 3 months, where it rains a lot, as it does in India. It then has a really hot May. It can go up to 40, 45 degrees like it does in Delhi. Super dry. And then it has really nice sort of 8 months worth of temperatures that range from, 20 in the nighttime, maybe 26 in the day, all the way down to 10 degrees, 15 degrees. So it represented for us a very different kind of climate. Also a different economic climate. It was again a speculative office building. It was a building that was designed for multiple tenancies. So it was not a corporate headquarters. It wasn't some kind of large corporate environment. It was basically supposed to be able to be sold or rented out to small, medium, large size offices. The interesting thing about the project, it was a 220-meter long site, and it had about a 40-meter height limitation, so it became a ground scraper by default. And so the design is, in fact, 8 buildings lined up together. So there are 8 cores here, and each of these cores has an extra staircase in the building down here. So there's basically 8 chunks that allow each sector to be independent, which means that there's a roughly an 8,000 square meter floor plate, roughly 9 floors of that. So the idea that you can have your private lift lobbies, AHU space, and WC and everything else supporting here, and service a roughly 1,000 square meter floor plate, gross. And that would be your smallest tenancy. You could obviously subdivide that into smaller corridor-based subtenancies, or you could take a whole plate of 2,000, or you could take a stack, which is 8,000 this way, or you could take 16,000. So it allows you a lot of configuration because of this 8-core configuration. We sandwich between these 8 cores these 2 galleries, which we call the sort of the museum galleries. They're 40 meters high. They are naturally ventilated. All the cores are naturally ventilated, so the air conditioning is purely along the office spaces. And then we found that we needed to obviously deal with the outside, so we ended up with a rain screen idea, in this case in the model, vertical louvers, which initially performed quite well because we could change the louver orientation according to solar orientation. The inside, through simulations and studies, was highly self-shading, so it didn't require any additional cladding beyond the curtain wall. And a unique requirement, or a unique legislation in India was that if you have a double height terrace, it doesn't count as built-up area, so it became free terrace area. So we use that as a way of introducing as many of these as possible as a way for breakout space for the offices, smoke, go and have your lunch, go have a meeting outside, especially since the weather is really nice, and if you can keep the sun away, it's actually a very clement thing. So as this project developed, we were working with Meinhardt in Melbourne. They have a very good environmental engineering department. A lot of simulations were done. We had a LEED Platinum goal, which was reached. Insulation and light penetration were a key thing. The floor plate depth is only about 20 meters, so it's basically, you're never more than 10 meters away from the facade, and based on, again, a 60% free area specification on the rain screen on the outside and no rain screen, nothing other than the curtain wall on the inside, you can see that the actual light penetration worked out very well and on all of the floor plate. When we looked at the overall energy performance, it was obviously very key. You can see here roughly 20% is HVAC and all the air conditioning stuff, so we had to try and keep our air conditioning loads down as much as possible, also reduce as much as possible where you air condition. So again, the ground floor is naturally ventilated, the rooftop is naturally ventilated, all the cores and all the connections are naturally ventilated, so the actual office spaces are the only places that are really air conditioned, and of course trying to keep heat gain down. So as a result, we ended up again with this 3-layer facade. So the facade gets exploded into these 3 layers. There is a double glazed curtain wall here, which we were surprised about because on President Place we didn't need double glazing because the outside temperature never got too hot. But considering that there were sort of 3 months of 30 plus degrees and 1.5 months of 45 degrees, they said the single glazing would just have too much thermal transfer into the space. So we ended up with a double glazed facade, which came in. But we ended up expanding the space here from what was on President Place, a maintenance space, to an actual habitable space. So it's a 2.4 meter wide balcony with a rain screen on the outside where we cut away a 1 meter opening just for that balcony so that one can sit at the balcony and enjoy the view out. You can see here simulations that were done on the sort of heat transfer and the whole sort of operational side of this facade. So this is what the rendering looked like. You can see here, this is the galleries, 1 and 2, the cores on either side. In India, there's a requirement for a refuge terrace, which is a firefighting strategy, and there's several of these required. So we built these out into what we call urban voids. These are voids that are basically facade differentiators, which means that they become sort of larger scale elements on the facade, but also more importantly, we made them outdoor common areas with planting and water features and the idea that offices could come to these, and the whole idea of the sort of live, work, play environment was very much in place here, so that you could take your laptop and walk from your desk to this outdoor garden, order a coffee or chai, and sit in these gardens. Key facade systems are basically the rain screen, then we have the terrace and the balustrade, and of course we have a curtain wall beyond. One of the challenges here is when we were proposed our initial design, which of course, given the precedent of President Place, we said we'd like to do this in punched aluminium. They came back with saying, we can't afford it. 2.3 millimeter aluminium is far too expensive. And they had a point. If you take a piece of aluminium, 2.3, and it's a square meter of which, and you want 60% free area, you're going to cut out 60%. You bought the whole panel. But the 60% you cut out, you get some scrap metal value for it, but you've effectively bought a square meter for 40% of that being actually used. So we had to go back to the drawing board, and we eventually found a German sheet metal manufacturer who was operational in India, who had some very interesting techniques that they worked with us on, and it was the goal was to reduce the thickness of the sheet, basically that. The actual raw cost of the aluminum was just too high. So what we ended up doing is working with them, and they had a product that was very thin aluminium, 0.8 millimeter, that they would expand in a micro mesh. It was a very fine mesh, and so the expansion makes a 1 square meter panel 1.6, right? So it's pulled. So you end up already increasing the 1 square meter you bought. And then they ended up saying, well, that's a very floppy piece of material, so they flatten it through rollers, and then they put it through a corrugation process. So it ends up being a corrugated, expanded metal sheet that has about a good span of a meter. So you couldn't do large panels. So we needed to have, you can see here, 1 meter supports, and the ribbings run up and down. As a result of going from 2.3 to 0.8, from 1 square meter up to 1.6 versus 1 down to 0.4, we saved about 75% of the aluminium. And presto, we were able to actually afford this kind of elaborate facade, even for this building. Ultimately, it ended up being, again, not even a powder coat, it was zinc aluminum, so it was a sort of zinc-coated aluminium process that ended up being, again, self-oxidizing, and it turns into sort of a light, slightly brownish gray, which again is dirt-colored. So the idea, hopefully you don't have to clean it so often. The building's about 8 years old now, and it's still there and works fairly well. You can see here the interstitial space is quite interesting because we terraced the balconies up, so they were kind of spiraling like this because you had to have double height spaces everywhere. And so we created this space that ended up being a very nice sort of area to go out onto, which changes the nature of an office building from being a kind of curtain wall enclosed box to something which actually has a terrace, which is really nice to see. And you can see in here some of the installation photographs and some of the mock-ups and prototypes. You can see the ribbing going up and down. We were testing the strength. We were testing different orientations of the perforation, the stretch, either upside down or not, seeing how they worked. See in here the terraces being tested as well and looking at these windows, etc. It was an interesting process of evolution of a concept through the kind of hurdles that a normal project goes through. Cost, material, supply, finish, installation, etc. And there it is being installed. Those are the urban windows. So here's some of the final pictures. So the ground floor, very open. It's retail. We have about 8 floors of offices, and then we have a roof terrace, which is full of restaurants, health club, a wellness center, as well as a small boutique hotel. So it was a very kind of dynamic environment. These are these urban windows, which is basically, again, common terraces. That's a detail of the facade, which takes the light beautifully. I like this picture because it kind of shows the idea of this sort of layering of facade. It makes the building much more interesting. It also makes the building activated on the facade. Offices tend to be sort of dead because everything's behind reflective glass. Here, people come out, and you can see them occupying that with planting, desks, tables, and chairs. There's a lady. This is actually a movie but didn't come through. She's walking up and down on her phone and eventually sits down at a table. This is the gallery, which is an interesting space. So at either end are 2 cores, and at the other end 2 cores. There's always a connecting walkway, switching sides. Within that, there are some meeting rooms that are suspended inside the gallery to allow for rented meeting spaces in common areas. But the whole area is naturally ventilated. And in order to keep it dry during the monsoons, because the rains are really intense, we created these monsoon louvers, which are about 1.2 meters deep and 1.2 meters high, because we tested this in a number of physical and also online tests to see that the rain that sort of spatters doesn't end up infiltrating in even a microspray or at the ground level into this area, because it was a very critical connection area. And so you end up with this sort of unusual environment of very deep louvers that stays cool remarkably almost all the time. That's the meeting rooms on one side, so you can see they sort of suspend. They're small. They're probably about 7 or 8 meters long by about 4 meters wide, but enough for 10 to 12 person meeting. They are air conditioned, and they're obviously looking out over this internal courtyard. And you can see in here these monsoon louvers, which are tapered down and supported on these very large sort of portal frames that run up and down the atrium. And that's it looking up, which I always quite like the idea of this sort of veil or screen that changes the nature of inside outside. And I think that's something we're very interested in, trying to expand our understanding of what envelope can be like. And that's the final picture here, looking down on the inside, which is a very different world. It doesn't need the rain screen, it doesn't need to have the sort of cut of the insulation and direct lighting. So you end up with the unadulterated curtain wall system. You can see in here one of these terraces. This is obviously a canteen. You can see in here the rain screen, the meeting rooms, and on the ground floor, these landscape patterns that run through the building out into the nature and the landscape. And there's a park behind and the street in front. So again, we try to break the idea of a sort of walled office building. We had no perimeter wall on the site. The front landscaping comes into the core, into the central courtyard, and out to the back. So it was an interesting experiment, and the client, I think, was extremely courageous to follow us on this journey. It was definitely not an easy one. It's still under construction and completing 10 years later, but it was going on in phases. As I said, there were 8 different parts. So the first 4 parts were done initially, and then another 2, and now the final 2 are being completed as far as facades are going. And here's a picture of the outside. So the last project I'll take you through isn't far from here. If you came on the expressway, you might have seen it on to your left. If you came from town, it's at Punyawiti BTS, which is very close. Again, not a super prime area. It's a residential project called Wisdom Connect, or Wisdom 101. Again, under fairly tight budgetary constraints, compact units. And so even here, we tried very hard to try and elaborate on what a facade can be for a residential building. This was the competition-winning rendering showing that there were 3 towers required. We planned them in such a way, and they were part of a larger complex of an office building, a big retail block, and some other facilities all around this very large piece of land next to the BTS station. So we oriented the buildings north-south. That's the smartest thing you can do. Everything else is sort of secondary. The most important thing, of course, is orientation. If you can keep north-south on a residential, you've got half the battle won. We then tried to fan the buildings out so they weren't 3 parallel buildings to create some dynamic in the skyline. And then we also created a floor plate that allowed us to manipulate a fairly large tower. Each tower has almost 800 units, so it's like 2,400 in this development, into a kind of massing diversity that wasn't quite so cumbersome on the visual skyline. See that the floor plate, a fairly straightforward split block with the central core. That meant the 2 corridors are basically naturally ventilated, again, because they're open on both ends. You come out, you've tried to reduce what is effectively a very long building into 2 shorter ones as an experience goes. So as you come out of the lift lobby, you look left and right, you have light at the end of the corridor, which is always a nice thing, but also ventilation, which allows you also to ventilate through the units. So ventilation hatches were built into the doors, and so the idea of cross ventilation was maintained. You can see in here there were about 20 units per floor. They weren't big, 1 and 2 bedroom units. And we tried to develop the outside of the facade is a series of precast elements. So precasting was basically the headline here. In addition, there was an idea about trying to create a textured facade where you have window walls, you have terraces, you have CDUs. All of those things are unusually usually very difficult to deal with on a residential building, and quite often a residential building ends up being an accumulation of standard floor types. So you end up with 1,000 windows, 1,000 balconies, 1,000 AC enclosures, and it's very difficult to get any kind of larger scale reading. So that was part of our challenge. So we developed actually several systems of precasting together with the contractor. It was tendered as precast, but the actual systems were developed with the contractor in place. Some of the systems are unique to this particular contractor. For some reason, they felt easier to leave parts of the precasting out, bolt it from the outside on this cradle, and then to fill in the holes and then paint over. I think other times you would probably have an internal bracket that allows you to do that. You can see in here, even the end walls were done in precast, and strangely enough, they still wanted to have a solid concrete wall behind it, but felt it was cheaper to do precast here rather than any other kind of cladding system. We wanted to try and get away from the brick or blockwork concrete combination, which always cracks. And so this was the end wall. This is the end wall in construction. And you can see here they've already patched it up. And you can see them here putting them up. And as you see, I like to show these two images because oftentimes renderings can show you anything you want. We have the great power these days with 3D software, et cetera, that can say, hey, here's what it'll look like, and oftentimes the outcome isn't quite as successful. Here, this is the before and after with the rendering and the building, and I'd like to think that we've done a fairly good job at manifesting what we initially thought we wanted to do on both. You can see in here the facade has been broken down into 6 to 8 story villages visually. So there are these larger horizontal ledges that start to break the facade down. In between that, there are some very strong verticals that are based on the plans, and you can see how that comes about. And so overall, the project achieves what I would like to think was a calmness about it. This is, for instance, the window wall, or one of the window walls. There are many different window walls in here. You can see here that the transom panel, the drip detail, the framing itself, all of that was precast brought in, and then, of course, the aluminum glazing to be set into that and done as well. These are floor-to-floor heights. You can see all the details here, from the interlocking joint details to the windows themselves, have all been obviously designed, and these come in and fairly quickly are established on top of the RC framework. You can see during construction, quite a lot of stuff happening. Even the blade walls on either side of the staircase were clad in precast. The window walls are different types. Here you have obviously open corner windows versus small windows for the bathrooms. And here again, I guess the before and after, very similar. What we try to do is try to create a facade here where you would not see a single CDU. It's very hard to hide them sometimes because obviously the louvers are fairly transparent. CDUs come out off-white. Usually they sort of stick out a little bit. Balconies also tend to sort of either stick out or be very clear. We were trying to create an overall color scheme which basically allowed the building to read as a series of horizontals and verticals as a primary reading. And then obviously the actual more specific use of whether it's a habitable balcony, an outdoor unit, a yard, etc., would be a secondary reading behind that. Even the CDU enclosures were done with precast elements. You can see in here, this is a double precast element with larger fins on the outside, 100 by 100 verticals. Which obviously had to be tested by MEP to make sure that the heat rejection didn't create any short circuits, which it didn't, thankfully. Again, bolted up and down on the top and bottom as a very simple panel. You can see it here installed prior to painting, and very simple, floor to floor. And this is a single unit, this one here. And as it came through under construction, you can see here the sort of elegance of that. And thankfully, even in the end result, the CDUs are actually really hard to see. I mean, you can probably spot a few in there. And they breathe in from the sides and breathe out from the front. So we had to leave a gap on the sides. So again, oftentimes to be able to achieve an end, you have to understand all the working parts that go into that. Louis Kahn had a famous saying, which is that he hated services so much that he made his business to understand everything about them so that he could control it. I think that's a good guideline for, I guess, trying to make your architecture lead the role. Oh, that's a really nice end thing. Very close. So there's the before and after. Again, I think, actually, I think the after is better than the before, the rendering. And I'll end with a few pictures of the actual finished project. Here's an aerial view of one of the towers. The second one is actually under construction. You can see here at the very top where the special areas are, the rooftop terrace, we actually replaced the window wall coffered facade with a curtain wall as a kind of top of building headline. Looking up again here at the end walls, which are very strong. All three towers have a slightly different color scheme, so it was taking a page out of the Apple sort of phone book, which was it was a gold, a champagne, and a sort of warm silver, and they sort of were then exposed to that color scheme. You can see in here the podium, which had a perforated metal facade covering some of the parking, but also some of the facilities. This is a green wall that grows up around the parking. That's the day and night of the lower podium. And I think this is the final image showing the three towers. And if you come out at the end of the day and you end up going into town, look out over your right in about 5 minutes when you leave here on the express, you'll see these three towers on the distance. So there's the low, the medium, and the tall tower. And I said, again, the podium and the top are sort of special areas. And in between, we have a very sort of calm facade that's, again, I think, going to prove itself over time. The building is probably 4 years old now. It still looks the same. And I'd like to think that with the precasting and the high quality of paint coatings, it will withstand the test of our climate over time, which is a very tough climate. Thank you very much, everybody. That's it, I think. Yes.
Thank you very much, Mr. Brouwer, for sharing with us your case studies about your projects in various countries. It's very inspiring indeed. ขอบคุณคุณ Hans Brouwer มากนะคะ และลำดับต่อไปดิฉันขอเรียนเชิญสปีกเกอร์ท่านถัดไปเลยนะคะ I would like to invite our next speaker to the stage, Director, Facades Associates, Mr. Andrew Snalune. Ladies and gentlemen.
Hi. Morning, everyone. Thank you for coming out. Nice to see real people face to face and not over a Zoom call. That one, yeah. That's it. Okay, so this morning I'm going to talk about cable net corners and spandrel glass matching and some facade trends, which are mostly my opinion, but I think you'll agree with some of them. Okay, here we go. Okay, so cable net corners. What's the issue with cable net corners? We discussed some early solutions, recent examples, and what to watch out for if you make the terrible decision of actually trying to do a cable net corner. So I think this is the first example of a cable net corner. There's a lot of other famous cable net structures, such as Frei Otto's Munich Olympic Stadium. I think that was polycarbonate, not glass, and it was a roof. So the Kempinski Hotel in Munich is the most famous example. Very, very large, 25 meter high, 40 meters wide, and the key to cable net is that you allow very, very large deflections. So I think this one, although now the spans you allow is the deflection is span over 40 to 60. This one actually deflects nearly a meter, 90 centimeter deflection in a 25 meter span, which is something like span over 30. So very high deflection, but quite small glass pieces. These are 1.5 meter and they're square, very sensible. So what happens when you try and put a corner in an element like that? Obviously, you can't do it in a two-way cable net. So you end up using vertical cables. So this is a great example in Abu Dhabi. I think the contractor was Sealy or Zayla, and they have a huge lobby area with a cable net corner. So we worked on a couple of projects in Bangkok with where the architect had requested cable net corner. So we went into research mode. So this is the Sealy solution where you've got a cable net that's moving a large range of movement, but at a corner, obviously you have to control. You've got two sides moving together. You have to limit the movement at the corner to basically zero. So one way of doing it is that you literally design something so stiff that the corner movement is as close to zero as possible. So the solution presented here is a large bow truss in two directions that effectively reduces the deflection at the corner to zero. And the cables will have different tensions as you move away from the corner to gradually allow more and more deflection as you get into the typical sort of two-way span of the cable net. Then we saw this interesting example in New York, which is actually a refurbishment with a cable net at the lobby. This was Dyrskafidjo Renfro, a well-known U.S. architect, with Enclose was the contractor. So apparently there's nothing at the corner. So there's a couple of examples like this. This is the most prominent one. You get to the corner, there's no cable, no fixings. Apparently nothing in the corner design. And recently, this was completed only a few years ago. This is another cable net in New York by architects KPF, consultant Front and Enclose, and this one even more extreme, a very tall cable net with again apparently nothing at the corner. We examined the requirement at the corner. In fact, you don't need to. You can use the adjacent plane of the glass to. So you've got at a corner. You've got a unique condition. You've got a plane subject to wind load, but then you've got a perpendicular element, which you could say can work as a glass fin and support the edge. So you end up at a corner. You can have if you have a wind load perpendicular to the glass. The other orthogonal perpendicular glass element you can use as a large glass multi-element fin to restrain the corner. So in fact, all you need to do is you need to ensure that the glass at the corner is supported, and that loads can transfer into the perpendicular glass. So you can end up with a design whereby, as long as you bond these, you allow wind load transfer through the silicon in tension into shear in the silicon in the adjacent plane, you can manage the wind loads without having without having wind load cables or fixings at the corner. So the 3D here shows we have a dead load cable that supports the dead load of the glass. So the dead load of the corner pieces is supported on a normal cable, typical tensioned cable with a patch or point fitting. But the other end is simply dead load supported via a clamp onto a dead load cable. An extrusion at the corner that allows this one. Wind load so suction in this direction translates into tension in the silicon here, which translates into a shear in the silicon on the orthogonal piece. Then, of course, the same in the other direction, and of course, your wind load is not conveniently always perpendicular to the glass, so you have both situations. So you need to assess the silicon in shear and tension under both conditions. So the assembly here can be made quite small. We managed to do it within like a 50 mil radius. probably you could probably optimize it down to become a bit smaller. The extrusion extends out to the corner to neaten up the corner. The diameter of the cable at the corner it's only taking wind load, so it's basically hand tensioned or tensioned by the glass only. There's no major tension in the corner cable. So this is Tipco Tower 2, architect Palmer and Turner from Thailand. So this is a 15-meter high cable net. The total linear span is more than 50 meters, including the corners. So you can see on the right here, you can see the dead load cable coming down from the steel support in the ceiling, and the extrusions installed, and the glass ready to be siliconed onto the extrusion. Okay, so this is the reality of construction. So this is the dead load support. So inside the extrusion here is a dead load support going through to the stainless steel cable clamp inside. This is just preparing for siliconing. So you've got the temporary glass clamps while waiting for the structural silicon to be applied into the glazing. Glazing tape here, backer rod. That's the corner. That's the final corner. So what to look for? So you need to use a glass software capable of modeling cables, and from that software you can export the geometry, the deflected geometry of each node. And ideally, we exported it into Rhino and then used that to check the angles between all of the glass planes. So you've got a couple of another unfortunate trend is the wish to use longer non-square glass. So this creates another problem. The glass of the earliest cable nets is square for a good reason, in that the deflection between the angles between each piece need to be well controlled, and if you have a piece that spans multiple support points, you're going to get additional stress on the glass imposed by the cable. So the way you need to find the deflected shape of the nodes and apply loads onto the glass to reproduce that deflected shape, and then you can check the stress in the glass that leads to that particular shape of deflection. Another item that comes up sometimes is the cable angle. So depending on the type of cable you use, there are restrictions on the angular change at each cable clamp point. So the sequence to do a cable net corner, you need a software that can model cables. You need to export the deflected shapes from that into a software where you can easily extract geometry. You need to check that geometry in detail to make sure it doesn't it meets these cable restraint the requirements, and then check for the stress and deformation in the sealant. Next one. Okay, so spandrel vision glass matching. There's a lot of buildings that use. Why would you want to match the vision glass and spandrels? It's generally a value engineering requirement. You have a spandrel and you have a vision glass. You don't necessarily want to use the same vision glass and the spandrel to save cost. Can you use a thinner glass like a laminate? You can, but often you have to use a slightly different coating and then try and match them. So many buildings end up in this situation where you have a vision glass with a low E or high performance solar control coating. You want to save money by having a spandrel panel that's not using the same double glaze unit, but you can't use the same coating. Often the spandrel has to use a hard coat, whereas the vision unit is using an offline coating. Now you can get coatings that can be applied onto laminates, so you can theoretically use the same coating, but that's only in recent years. So this one you'll have to so the graph on this is to explain why there's such an issue with matching the coatings. So on the graph on the left here, the left hand column is the sky dome. So this is a like fisheye view of a hemisphere. So you have a cloudy sky, partially cloudy, overcast, blue and blue and bright. So these different atmospheric conditions have very different color temperatures. So the color of the general color of the light and the brightness. So the second row is the color temperature. So color temperature is going from 5K to 6.5 to 12 to 20K. So these are very different colors that you can experience maybe in the same day at the same location. The luminance, the brightness that you experience can range also widely. Here we have 3,000 lux up to 90,000 lux. This graph is from Seattle, so it's not Bangkok. I couldn't find one for Bangkok, but there's a large range of color temperatures and brightnesses. The middle graph here. This is our human perception of light. These are the receptors we all have in our eyes for different primary colors: blue, green, and red. Bronze is the black and white. These are all different in different people. So no two people are going to agree on the same color. Also, we have to communicate via language. If you've ever tried discussing glass or a color verbally, it's quite different. It's quite difficult. On the right hand side, this one's quite tricky. So this is a color space, which is a 2D space that each point is a different color. So here we have the black dot is a measurement by a measuring device, a probe. So the black is a sort of non-human measuring device. The white is humans' estimate of that machine measured color or that probe measured color, and the grey band is the variation across a number of people. I think it's like 30, 40 people in this case. So we can see here. So we have the black dot here is the machine measurement. The white dot is the average of the human trying to match the color, and the grey band is the range of all the human responses. So you can see, okay, on the blue-yellow axis, we're quite well matched. On the green-red, especially around green, none of the observers got anywhere close to the actual measured value. They couldn't match it. They couldn't match the color. So our perception is different between people and and we have difficulty matching colors. So an example, this is a fluorescent light color. So if you're looking at a glass sample in your office, this is the color of the light that you see reflected in the glass. Or this is the color temperature of the glass. So we go up to daylight, 6K. That one hasn't come out quite so well. And that's outdoor blue sky. So we go, let's see if it's go back. So you can range. So obviously we never recommend you look at glass indoors anyway, and this is one reason, is the color of the light is so different. Okay, another complexity is the makeup of the coatings. So this is, I don't know how much you know about coatings, but this is a build-up of a triple low-E. So this is a kind of worst case. So I use the worst case here. So these are the layers in a triple low-E coating. So you've got 10 plus thin metal layers that make up a coating. Each of these has a different effect on the light passing through it. These are some profiles of coatings. The purple line is your sort of perfect, is your ideal coating that cuts off all non-visible light and evenly cuts off the attenuates light in the visible spectrum. The coatings try and approximate this. Where they fall short from approximating the perfect line is where you get the color differences between coatings. So you can see between, let's say between the blue and the red one cuts much less blue, much less blue light. So this would appear to be more of a blue coating. Right, I better hurry up. So UOB. So our advice is how to get the matching correct. You need performance data reviews first. Then you go into 300 by 300 samples that you get from suppliers. Correct those. Large-scale visual mock-ups. So this was done for UOB Plaza, which is just finished at Prompong. You can go and see that. The glass matching, I think, there is excellent. So for that project, we built a very large mock-up on the site, and we tested various combinations. So in detail, this is a double glazed unit. So you've got the sunlight. Sunlight reflects off the coating, changes color slightly and out. When you have a normal laminate, you have a slightly different coating. So you have a slightly different coating that's your reflects and gives you your main color appearance. And you've also got some light off the back pan. So those are typically different coatings. The color difference. I'm going to get the bell, aren't I? Don't give me the bell. So you can of course use the same coating. You can use the same glass, the same DGU, but that's expensive. So a solution that's tried on many projects locally. I think the first one to do it was Park Venture, and then Novotel Patinam. These were by Viracon. So their trick was to use a reflective coating in the laminate and use the identical coating in the spandrel laminate, and then you have a much clearer solar control coating at the back of the laminate. So you get the identical color reflection back from the outer light, and the reflection of the low-E coating, which because you've got two coatings can be much less reflective, or have a much lower or a higher G value. You can get the same color between the different types of glass. So we did eight combinations here, and it went through multiple viewings. So we viewed at different times of day, different groups of people, and the same group of senior management from UOB viewed the visual mock-up about 3 times on different trips from Singapore. So there's eight combinations in total on this one. Facade trends. So here we go. Increase in opaque areas for offices. So obviously there's a lot of pressure to reduce heat gain in offices. So this is fairly obvious trend. There is before most. I think leases want to give you floor to ceiling glass, but it doesn't necessarily have to be full width glass panoramic. And also, I mean, if you don't have you have a more sheltered ambience. If some of your facade is opaque, and as the previous presenter noted, if you have some sort of screening, you get a more sheltered ambience in the facade. Oversized glass. Obviously, this is a continuing trend. We've got some huge glass at UOB. These are nearly 9 meters high in a single piece and shaped. I think this is the current record. It's about 18 or 20 by 3.6. The width tends to stay the same. I think there are some interesting trends now where the short side tends to be wider. So previous short side used to be 3.2, 3.3, 3.6. Now we're starting to get some glass where the shortest side is increasing over 4 meters. So you've got some glasses here where you can get you're not just having long units around 3 meters. You can get actually bigger square units out of it. Another one, planting. I guess the key point here is so this is a successful one from some time ago in Milan. Sorry, where's that? Anyway, now it works. Here, obviously, you've got maintenance access for rope access technician and a BMU. So this one was you saw the news recently. This is mosquito infested. So this one's not quite so successful. I think only 10 residents have moved in. Became mosquito infested in Qingdao. An excellent example in Singapore. So I think the key thing to say is now many buildings have planting, and usually we get to a stage where the landscaper is asking for a meter of soil depth and he's getting 500, or he's asking for 500 and getting 300. So if you really want successful planting, you need to put the plants first, design for the plants, design for maintenance, make sure you accept the periodic maintenance burdens, don't just leave the plants to overgrow. You have to have a plan for maintaining them and a plan for maintenance. So circadian, this is one. This is one I think is going to come into prominence. I don't know how many of you know this, but most laminated glass cuts most UV. So PVB interlayer cuts about 90-95% of UV. Most low E coatings also cut a lot of UV, but there are interlayers and solar control coatings that allow UV through, and that can entrain your biological clock, which controls your sleep-wake cycle. So early morning sun helps entrain your sleep-wake cycle, and now if you get up, go straight to an office, you're not getting UV, you're not resetting your biological clock on a daily basis, and in addition to that, you're on a blue screen or smartphone. So, and there aren't any green codes that consider this at the moment. So none of the LEED, well, etc. I don't think they acknowledge this fact. So another trend: floor-to-floor spandrel glazing. I think that's obvious. I won't go through that. There's various ways. There's a couple of new buildings. Rasa Tower 2, I think, has one, and we're doing a Dusit office, which also has that particular feature. So I think that's going to be a trend going forward. I'm done. Thank you.
Thank you very much, Mr. Snalune, for sharing with us your presentation. Very in-depth and contains a lot of technical details that I'm sure will be normally not very easy to obtain, and I'm sure a lot of us here can benefit from that today. ขอขอบคุณคุณแอนดรูว์ สนาลูนมากนะคะที่แชร์ presentation ให้พวกเราในวันนี้นะคะก็มีข้อมูลเชิงลึกหรือว่าข้อมูลทางเทคนิคค่อนข้างเยอะนะคะก็หวังว่าหลายๆท่านนะคะก็จะได้นำไปใช้ประโยชน์แน่นอนค่ะ As for our next speaker of today is actually from a company who is our sponsor today, and they have a booth in the networking area as well, and I'm sure that you might have seen it around. And as mentioned before, that we won't be taking questions during or after the presentation, but our next speaker, same as every speaker, will be present in the networking session, so you could be talking to him directly after. So I think สำหรับสปีกเกอร์ท่านถัดไปนะคะก็มาจากบริษัทที่เป็นสปอนเซอร์ใหญ่ของการจัดงานในวันนี้นะคะก็ถ้าสมมติว่าท่านไหนได้ไปดูตรง networking ก็อาจจะได้เห็นบูธแล้วนะคะตอนนี้สปีกเกอร์ก็ใกล้ที่จะพร้อมแล้วค่ะก็โอเคถ้าอย่างนั้นเดี๋ยวจะขอเรียนเชิญเลยนะคะ Now I think our speaker could be ready very soon. Speaking of the break or the networking, I'd like to mention that for those who drove here today and were given parking card, you will need to have the parking card stamped or validated at the reception desk. Otherwise, there will be a parking fee because of the venue's policy. So if you have that validated or stamped, then you can get a free parking for 12 hours today. This is very important. สำหรับท่านที่ขับรถมานะคะเผอิญเมื่อกี้พูดถึงเบรกนะคะท่านที่ขับรถมาเราได้รับบัตรจอดรถสีแดงๆนะคะเดี๋ยวจะต้องอย่าลืมนะคะก่อนกลับต้องนำไปสแตมป์นะคะตรงจุดสแตมป์ก็คือตรงจุด registration table ด้านหน้าค่ะเพราะว่าถ้าไม่สแตมป์ก็จะมีค่าใช้จ่ายนะคะสแตมป์เราก็จะจอดฟรีได้12ชั่วโมงค่ะแต่ว่าก็อีกสักพักหนึ่งเลยนะคะถึงจะถึงเวลากลับบ้านกัน we still have quite a long time to go before we leave so you have time to get that stamped as well. So all our speakers featured for today have expertise in large areas, different areas for the facade. So, I think we're ready now. Okay, so our next speaker of the day is Senior Sales Manager from Vector Foil Tech, Mr. Michael Pei. Let's give him a round of applause.
Good morning, everybody. It's nice to see so many faces in one place. Personally, I think it's just great. Anyway, welcome to our presentation on ETFE Building Envelope Technology. So this presentation focuses on solution, detailing, material properties, projects, and finally a case study. Again, my name is Michael Pei, and I'm from Vector Foil Tech Asia Pacific based in Singapore. ETFE is an abbreviation for ethylene tetrafluoroethylene. ETFE is a fluoropolymer, not a plastic, which is derived from petrochemical. So unlike plastics, fluoropolymers do not have problems with fire, UV, longevity, and sustainability. So here's a timeline of how ETFE came about. It was developed in the 40s and patented by DuPont. And ETFE has excellent resistance against chemical corrosion, weathering, aging, and can withstand high and low temperatures. Now, back in 1982, engineer Stefan Leonard and architect Ben Morris co-founded Vector Foil Tech to use ETFE for building envelopes. ETFE systems typically consist of 2 or 3 layers of ETFE welded together to form a cushion. It is then inflated with normal air to give its shape, strength, and thermal properties, all very lightweight. So from the underside, you can see the ETFE cushion is secured all around into an aluminum perimeter frame, all like mullions. Just like glazing. However, the difference being a small inflation pipe in the corner. And from the top, you can see that the aluminum perimeter secures to cleats that are welded onto the steel frame. We also install anti-butt wires on the extrusions where necessary. Yes, ETFE system is lightweight but very advanced. It is watertight, airtight, accommodates large structural and thermal movements. ETFE is lightweight but strong, so strong that it can bear 400 times its own weight. Also in locations with snow loads. Let's start by seeing some of the world's famous ETFE projects here. Built for the 2008 Summer Olympic Games, the Water Cube is currently the largest ETFE-clad structure in the world, and it has over 100,000 square meters of ETFE cushions, averaging 7 meters in diameter. There are 4,000 ETFE cushions there on the exterior and interior. Eden project opened in 2001 and described by some as the 8th wonder of the world. It consists of a tropical and a Mediterranean biomes, each approximately 55 meters high, 100 meters wide, and 200 meters long. There are over 600 hexagon-shaped ETFE cushions that form the building envelope, each being approximately 8 meters in diameter. Lightweight and flexible, ETFE cladding also means lightweight steel structures. Only 667, I repeat, 667 tons of steelwork were used at Eden. Hudson's Yard project is the largest private real estate development in US history. The shed has a moving outer shell that doubles the building's footprint for large-scale performances. This amazing video shows the dramatic transformation of this building. The world's tallest ETFE structure is in Astana, the capital of Kazakhstan. Now, Astana is the second coldest capital in the world, and ETFE helps create a comfortable environment all year round. The 150-meter-high tent structure is clad with 22,000 square meters of 3 layers ETFE cushions. Here's another picture of one of the structures within that huge tent. Now let's see use of ETFE in main construction sectors. Airports. The Jewel at Changi Airport is a nature-themed entertainment and retail complex linking to the 3 existing terminals, and it costs US 1.25 billion. The centerpiece is the world's tallest indoor waterfall named Rain Vortex, which has a 12-meter diameter ETFE cushion that provides a clear opening of light at the center of the fountain. There is also a 4,000 square meter ETFE drop-off canopy. Despite the large spans and cantilevers as well as minimal columns, the structure is elegant and lightweight. This is Beijing's second international airport, nicknamed Starfish. This time, single-layer ETFE was used to make the striking cantilevered drop-off canopies. Cebu Mactan International Airport was World Architecture Festival winner for transport. Rolling waves inspired the architect to have an undulating, sustainable gulam roof, and is a symbolic gateway to the Philippines. Now, Cebu is subjected to typhoons and would be public shelter during typhoons, so even higher loadings must be applied in structural engineering. Nevertheless, 3-meter wide cushions spanning 20 meters covers the 3,500 square meters drop-off and link bridge canopies. Now, Singapore National Stadium at Singapore Sports Hub has a 20,000 square meter ETFE movable roof that can open in 20 minutes. This was the largest sports infrastructure public-private partnership project in the world. It is also the world's largest free-spanning dome at 310 meters. The ETFE provides shade and cooling and of course shelter from rainfall when necessary. The ETFE has 20,000 LED lights so the roof becomes an event space. The video is of Holland's largest stadium. It was upgraded and it incorporated 2,500 square meters of ETFE cushions. The ETFE and steelwork were all prefabricated, no scaffolding used during installation. The new ETFE facade changed the facade shape to from concave to convex, giving protection as well as city views to the visitors. So this is Hong Kong's newest and first all-weather, all year-round water park. There are 2 large skylights and are covered with 3,000 square meters of ETFE cushions. These skylights had to be designed for almost 5 kPa of wind uplift, and yet we were able to design the steelwork without trusses to keep the resort feel. There are 40 openable smoke vents, and they were also clad with ETFE to integrate with the whole roof design. Transportation. Arctic is designed to connect 8 existing public and private transportation systems within aggressive sustainability targets. With the help of our ETFE, it is the first LEED Platinum Transit Station project in the world. There are almost 6,000 square meters of ETFE cushions, which forms the roof and the facade, and it results in a lightweight diagrid structure. The building has won many awards, including USA Public Building of the Year. What's amazing about ETFE is with simple lights, the building then has a nighttime and a daytime identity. Resorts and leisure. Paradise City was Korea's first integrated resorts. ETFE allowed a beautiful steel solution to complement the overall design and help heat the water and air during cold winters and keep the cool during summers. This center park in France roof spans 35 meters to cover the water attractions, swimming pools, and beaches immersed in dense tropical greenery. Theme parks. Resorts World is a $5 billion integrated resort with over 25,000 square meters of ETFE cushions. Resorts World is also home to Universal Studios Singapore, and our ETFE was incorporated to cover theme zones to add more theatre. American Dream Mega Mall with Nickelodeon Theme Park and DreamWorks Water Park. DreamWorks Water Park is the largest indoor water park in the country and covered with ETFE. The picture on the left is a render, and the picture on the right shows the actual after installation. Education. This is the world's largest early learning village. All outside play areas are covered by ETFE. It protects the children and creates the most comfortable and safe environment possible. The campus capacity of 2,100 children, purpose-built entirely for children aged between 18 months to 6 years. Shopping malls and retail. The Avenues in Kuwait is the destination and a true landmark. Vector Photovoltaic has installed nearly 120,000 square meters of various design in ETFE roofs over 4 phases. The Avenues is a retail concept inspired by great cities of the world. ETFE is not affected by sandstorms and provides natural daylight and thermal protection from the harsh summers. Botany is an amazing 1,300 square meters, 2-layer twisted ETFE cushion, providing climate control and public space with acoustic comfort. The twisting nature forms, the twisting natural form of the ETFE cushions looks amazing day and night. Aspen Vision City was developed with IKEA. There are about 13,000 square meters of two-layer ETFE cushions, and it makes an amazing retail venue which can be used 24/7 by shoppers, visitors, and tenants. Zoos. Elephant Park at Zoo Zurich allows public to see elephants from a completely new perspective. The 80-meter span column-free roof has 271 ETFE skylights. Let's start the technical. At the heart of our pneumatic ETFE system is our intelligent inflation unit. This inflates the ETFE cushion and maintains the appropriate pressure thereafter. It's typical German engineering. There's an onboard computer, and they even design backups for backups within the inflation unit. So it's totally, independent and fault redundant. We make use of frits and prints to mitigate against heat transfer. So by having different densities of print or different print by area, it controls the amount of heat coming into the space beneath. So both photos are of the same ETFE skylight, but one can still see through from beneath and have a very good view to the outside. Plus, we also have a wide range of frit arrangements and different print intensities to ensure that there's always an appropriate solution for every climate in this world. So ETFE cushion system offer equally superior thermal properties as glazing wood. However, its lightweight supporting steelwork means that there are massive cost savings. And you can actually have some visual effects as well. In this instance, this 355 meter long mall in Liège in Belgium is colored with a few ETFE cushions. So longevity. The picture on the left is the first project ever built in the world, and that was about nearly 40 years ago now, built in '83. And the picture on the right shows the same project 35 years after it was built. Now a small sample was taken out and tested, and we found that there's no degradation to the ETFE at all. The surface of ETFE is hydrophobic, which means that it is self-cleaning. And fire, which is important. The behavior of ETFE, basically, fluoropolymers are known for low flammability and resistance to ignition. So we've tested ETFE to many certificates and many standards across the world, and this is just one of them, which is EN 13501. And results show that there are low combustibility, no burning droplets, and no smoke, little to no smoke. And needless to say, we've tested to many different standards around the world as well. ETFE is the most sustainable and environmentally friendly roof and facade material. We have studies and reports to assist with credits for LEED, BREEAM, and the like. So let me get on to the project case study, which is rather interesting. This is Bukit Jalil Mall, and the developer is Pavilions. Pavilions is a leading developer in Malaysia, And this particular mall is just outside of Kuala Lumpur in a place called Bukit Jalil City. Pavilion awarded Vector Faltech the 7,000 square meter mega canopy that is an outdoor facility for any event imaginable, from concerts to fashion shows, and it connects to the mall. So the mega canopy is 125 meters long by 115 meters wide, clad with 34 ETFE cushions, each cushions at about 3.2 meters wide, and the longest being over 120 meters in length. Now that would be the world's longest ETFE cushion. Our scope then not only included ETFE, but also the engineering of steelwork, authority submission, lights, PA systems, winches, fans, aka we were the mini main contractor for that project. So we design and engineer the steelwork and ETFE all according to local design codes. The challenge was super long spans, no trusses, organic shape, minimal columns that have to be pinned at base. The structural solution is a build-up arch beams, diagonal bracings between the beams, perimeter tension ring beam that also acts as a gutter, and tree-like slender columns. The ETFE cushion follows the arch beams across the entire length without joints. Another challenge to resolve at tender was the floor loadings. The pre-tension slab could not take heavy loads, and the entire method statement was based on tower crane installation. The photo on the right shows just how much change in curvature from beam to beam, and the photo on the left shows how light the steel structure was. Installation of ETFE using our safety net system so that works can carry on below safely. All ETFE cushions were prefabricated and only installed at site. Here you can see the world's longest cushion being installed, the one being 120 meters in length. And these are images from below. And lights were part of our works, and they were being tested. The final result is an iconic and amazing public space adaptable to hold every public event imaginable in a controlled environment. These are some recently taken photos. They just look amazing. Thank you very much.
Thank you very much, Mr. Michael Pei, for your presentation. Thank you. As mentioned before, Vector Faltech is one of our sponsors, so please don't forget to visit and check out that booth during the networking session. Now, ladies and gentlemen, we still have one more speaker before our break นะคะตอนนี้เดี๋ยวเราจะมีสปีกเกอร์อีกท่านหนึ่งนะคะก่อนที่เราจะเบรกกันค่ะแต่ว่าสำหรับสปีกเกอร์ท่านถัดไปนะคะไม่สามารถเดินทางมาร่วมงานกับเราได้ในวันนี้เพราะฉะนั้นเดี๋ยวจะมีวิดีโอนะคะที่ได้อัดล่วงหน้าไว้แล้วเปิดให้ทุกท่านได้ดูกันค่ะ Unfortunately, our next speaker cannot make it here today with us, but he has already shared with us a pre-recorded video presentation for all of us here. So if the team is ready, then ladies and gentlemen, please enjoy the video presentation by Mr. Russell Kim, Senior Vice President, Head of Design, Frasers Property Holdings, Thailand.
For not being there in person to present. My name is Russell Kim, Senior Vice President, Head of Design for One Bangkok Project. It is an honor to share One Bangkok project with you today. One Bangkok is Thailand's largest fully integrated district that will transform Bangkok and be a new global landmark. Distinguished by the prime geographical location, One Bangkok will reshape and redefine Bangkok's urban landscape in a positive and lasting way as the largest private sector property development in Thailand and in much of Southeast Asia. We started with this vision by the chairman and I'm confident to say we will deliver on this vision. One Bangkok must be an entirely new experience for the city, and our master plan reflects this ambition. To deliver the district of the future, we work with SOM with support by A49 and looking at global trends for inspiration, as well as to Old Bangkok, the city's past for insights and reflection. The aim is to yield a thriving urban district for Bangkok, a new center of social life in the city. We began this epic journey back in 2016 when the master plan was completed. Working through the COVID, we are targeting to complete our phase 1 by end of 2023, with phase 2 completion to follow in the year 2029. The next few slides will highlight some of the changes that took place from 2016 to present. The project used to be called Snalune Village, a master plan by SOM, and later changed to One Bangkok, making its way to becoming an iconic signature brand. After the readjustment to the master plan, we are committed to build up to 1.83 million square meter. A master plan was set up with subdivided zoning, highlighting the city blocks with internal streets, promoting integrated connectivity with higher degree of cleanliness, safety, and security, on its way to creating an innovative district systems with implementation of smart technologies. Much of the current design is in line with the original master plan, as you can see here. And we began with 7 consultants during the master plan stage, which grew to over 65 consultants being managed by the project development team of 20. For those who may not be familiar with the location of One Bangkok project, we are located at the intersection of Wireless Road, Rama 4 Road, and Saturn Road, east of Lumpini Park. As mentioned before, One Bangkok with its prime geographical location, it is surrounded by 360 degrees of clear view. Lumpini Park to the west, Banchakitikun Park to the east, Chalermpol River to the south, and City View to the north. In One Bangkok, we will have 5 grade A+ office towers with 500,000 square meter of commercial space, 4 differentiated retail precincts with over 450 shops, 5 luxury and lifestyle hotels with over 1,100 rooms in total, superior access and connectivity to the city, 3 luxury residential towers with ultimate views to Lumpini Park and ultimate address. Pedestrian friendly, over 2 kilometers of art loop, which will be inclusive and accessible to all. Over 80,000 square meter of site will be designed to be green and open public space, bringing nature into daily life. In One Bangkok, from the onset of the project, we set out to achieve 3 core development principles that we follow dearly, which are people-centric, putting people first, championing sustainability, and living smart. For people-centric, over 50% of plot areas covered in greens, we plan to plant more than 1,000 trees and create large green open spaces, emphasizing the adjacency to Lumpini Park and to bring nature to daily life at One Bangkok. For championing sustainability, entire district will be covered as LEED and D Platinum, TGBI Platinum. Furthermore, 5 office towers will be WELL Platinum to deliver premium grade A+ commercial spaces. First ultra luxury residential tower as gold, WELL Gold. This achieves our group initiative on sustainability design strategy and the chairman's vision on elevating the local standards to the next level. At One Bangkok, all of our systems ranging from power, district cooling, wastewater, traffic, security of both CCTV and cyber attack, and others will be provided as centralized system, managed and operated in our centralized utility plant, and specifically from District Command Center. From the District Command Center, we will manage to achieve zero wastewater discharge, redundant power supply system from the 2 incoming high voltage power line, smart parking system on mobile to manage over 12,000 car park spaces. Also, there will be over 300,000 sensors installed throughout the district to achieve such operational requirement. Aside from the 3 core development principles, we also have 13 master plan design principles used as a guideline considering any and all design approach. I use these 13 design principles every quarterly to see how One Bangkok design measure up. We have set these guidelines from the beginning of the project, and we are able to see the current design of One Bangkok project achieve all 13. They range from being a green vertical village, a vibrant and well-scaled streets and public spaces, a green edge and blue infrastructure to a smart infrastructure and encourage resiliency. I'm sure everyone may be asking what type of risk exists at One Bangkok project and how did the team de-risk? One Bangkok project is indeed large and complex, but the complexity is not because of the project's design type or constructability of each component. For One Bangkok project, its complexity comes from the fact that we are executing 23 projects simultaneously in one go. You can imagine the coordination and logistics nightmare. If you change one area of the component, they will have direct and indirect impact to 5 other components sitting below and around that particular component. And to de-risk and to help to mitigate and prevent such coordination nightmare, we implemented 4 steps in the process to ease and minimize potential disaster from becoming actual. First, we had to educate all stakeholders, including the owners, internal project development team, and PMCM team to understand the nature of the mixed-use projects and its complexity and differentiation points. To understand the owner's expectations, do's and don'ts, likes and dislikes, which decision will be made by the owner and which can be made by the working team, and align the client to agree on the design brief and criteria, and fully understand the decision-making process. The criteria we receive from the owner is very simple. When considering the design, make sure to address the following in the order of business unit requirements, operational requirements, maintenance-friendly design, aesthetically pleasing design, and on budget. Second, set up a clear communication line between all internal and external parties involved. All decisions will be made by the local team. We have set up the team to be able to inherit all designs from the international consultants to the local counterparts so that we are not delayed in decision-making. Always have decision makers to attend meetings or at least someone that may steer the team to the right direction during each meeting. We had to set up a team with client-led independent facade consultant and local internal facade expert to assist during the design to tender phase. Now, our internal expert has fully taken over the scope to execute during the final stages of facade construction. Fourth and last, we had to build a client-initiated visual mock-up of some of the core components to receive pre-approval on all design matters from the owners, test out all the details and constructability aspect, better understand facade contractors' capability and quality as the 4th step. Furthermore, in our design to installation workflow, we had to include 2 additional steps to fine-tune the overall flow by including client mock-up and contractor survey. In design, we align client expectations, client mock-up for all design pre-approval, contractor survey to understand the capability and capacity, then tender mock-ups and installation to follow. Inviting some of the contractors to participate in client-led VMU, we chose 5 components to build on-site. Inviting all client and international designers to approve on the materials and detailing so that we don't need to go back to them for every decision during construction. Be able to review and fine-tune the detailing before the end of the design phase. Then locking in our design specs prior to proceeding to the next phase. On the sustainability facade design side, in order to fulfill our overall sustainability certification requirements, we also looked at how we can improve on this from the facade design perspective. As a good practitioner, we try to design to reduce energy consumption to help the environment, in turn, lower the operation costs, and most importantly, uphold human health and comfort. We have decided to design to achieve 40% OTTV reduction from the local code requirement for the entire district, reduce heat transfer for human comfort, less cooling demand, and insulating glass and wall insulation for every office, retail, hotel, and residential building. Balanced daylight simulation to boost human circadian rhythm. Perform daylight simulation to select glass to balance lighting and minimize social glare levels. We target to achieve average sound pressure level from outside noise intrusion to less than 50 dBA, which is very quiet, an average home volume, as you can see in the decimal levels to the right. Now, before moving on to describing some of the towers, I would like to highlight our partners working on One Bangkok project currently. These are just a few and many more to come. With the limited time, I've chosen 3 office towers to showcase today: Tower 3, Tower 4, and Tower 5. And we have gone through some of the VMU and for some PMU already. Tower 4 began installing some of the curtain walls on site. For Tower 3, we took the concept of a sail of a ship. As this building is aligned to Chaparria River to the south, we wanted to have a simple and smart like a sail with a gentle profile and a high performance facade system. These added layer of horizontal rods on top of the glass facade would climb up the elevation facing north and south with gentle bent curve at the top of the tower to accentuate the curve of a sail. But at the top of the building, we provide outdoor green amenity spaces with the rods continuing to climb up the facade without glass to provide shading from the sun. There are 2 types of facade system for the building. On north and south, we have the floor to ceiling clear glazing, IGU with low E coating facade with 500 mm low wall at the bottom of each level. There's an outer layer of horizontal rods acting as a sun shading device. Each set has 5 of 80 mm diameter anodized aluminum rods at the upper section of the vision area. Each modular unit will be assembled as a complete unit inclusive of the horizontal rod shading device layer on the most outer layer. On east and west facade, to differentiate from the other 2 elevations, it's a clean facade system with IGU low E coating with bronze ceramic frit on the upper part of the vision in lieu of the outer shading device. Tower 3 has a sky lobby condition on level 4 with a single bay transient lobby entrance on ground level. Main lobby facade will be same glass type, but with 9 meter by 1.8 meter on structural steel mullion system to extend the language of the tower down to the lobby facade. lobby has been designed to be majestic and grand, overlooking the civic plaza. Much of our office lobby actually is designed with a similar trades, and as we try to stay true to the traditional lobby design of being iconic. When we design One Bangkok project, we try to take the best features of the local characteristics and apply only the best qualities that Thailand has to offer to elevate the design to an international setting. For Tower 4, we took the sculptural curvature of the temple roofline with shingle texture effects and applied to Tower 4 design. You can see the curvature in few areas of the building, like the way the building tapers out on 1/3 of the tower, then tapers inwards all the way to the top. This happens only on west and south elevation, following the shape of the core. Corners have terraces with a curvature resembling the ends of the temple roofline. The main canopy at the lobby level also has a curve at the end of the canopy to accentuate the entrance point. You can also see the shingle texture effects in the main facade system as they are designed to be stepped. We start with the efficient core design with the offset, as the zones of the elevators will drop off. West and south facades follow the stepping of the core, maintaining the consistency of the leasing span. Lastly, we have corner terraces carving into the building, referencing the slopes of the traditional Thai architecture. Main system consists of stepped configuration with each unit sized at 1.5 by 4.5 meter to accentuate the verticality of the building. The system is fitted out with laminated IGU low-E vision glass with sun shading device that also act as a light shelf. And these devices are designed to be in a grille profile to lessen the resistance of the uplift of the wind and minimize the size of the bracket back to the mullion. For Tower 4, we are maximizing our view by allowing facade to be full height, glazing wall achieving 3.0 ceiling height without any low wall. The bird's mouth that we call the corners of the building will be fitted out the same glass but with ceramic frit on vision area, surrounded by aluminum fin infill panels to accentuate the corners to stand out and make an impact. Crown at the top of the tower was designed as a beacon for One Bangkok, 4 stories tall of an atrium space with steel encased framing system and structural frame support system to support the vision glass and with frit pattern to minimize the heat gain. This building will have the best view around until our signature tower is built in phase 2. Before getting into Tower 5, I would like to give a bit of a background history of our site. Among the many functions in the past, it was the site where the first radio station was located. We are restoring the original station design and constructing the entire station with portion of the transmission tower in Zone 2. And in its place, we are constructing our Tower 5. For Tower 5, we took the inspiration from the radio station, the radio wavelength, and placed our cantilevered glass boxes, atrium space to resemble the frequency of the wavelength and connect them down to the lobby entrance and further across to our civic plaza. For Tower 5, may be our shortest office tower, but will have the largest floor plate with deepest leasing depth, ranging from 18 to 20 meter deep. It's rich in detail and rationale, like the Thai architecture. It's sympathetic to the surrounding, but modern, blending in very well. The shape of these glass boxes decrease in size as you can see coming down the building. The depth of the fin also reduces with the logic of having the deepest profile at the top of the tower where the sun will be the most intense and get shallower towards the bottom of the tower. The building is framed with charcoal gray colored aluminum frame, subdividing vertically in every 2-unit module and horizontally following the glass box sizing. Each unit consists of laminated IGU low-E glass in 1.6 by 4.4 meter size, again to emphasize the slenderness and to make the building look taller. These glass boxes are designed to provide layout flexibility, stair connection for a single tenant occupying multiple levels, or high double volume atrium space for a meeting room or enlarged boardroom. The fritted glass boxes are designed with steel encased slender rectangular tube. Tower 5 is also designed to have the sky lobby on level 4 with transient lobby at the ground level. Double height atrium space is fitted out as semi-unitized curtain wall system on steel structure with stainless steel mullion, cladding and laminated IGU low-E ceramic frit. Canopy below the frit glass box wraps around the corner with square grid pattern on the canopy, allowing for the light to penetrate through, making the canopy to feel lighter. This is the interior view of the double height transient lobby at the ground level. View of our majestic grand sky lobby on level 4, overlooking the Civic Plaza, which is the heart of One Bangkok, is by far the largest lobby space in all of Phase 1 office tower. Let me share some of the construction photos with you. This is taken in April. Much has advanced since. The view of our 32-meter pedestrian-friendly Grand Boulevard. At the top of the boulevard, looking down towards the Lumpini Park. This concludes our presentation of One Bangkok today. I hope it was informative to all of you and get you excited to see One Bangkok coming to life. Thank you.
Ladies and gentlemen, we hope you enjoyed the presentation by Mr. Russell Kim, and we've extended the thank you to him already. เดี๋ยวต่อไปนะคะเรากำลังจะมีพักเบรกกันประมาณ20นาทีนะคะอย่าลืมสแตมป์บัตรจอดรถกันนะคะแล้วก็อาจจะเน็ตเวิร์กกับทุกคนนะคะแล้วก็รับประทานกาแฟอาหารว่างให้อร่อยนะคะแล้วเดี๋ยวเรากลับมาพบกันประมาณ 11:50 นะคะ We will now head for a 20 minutes break. Just outside here there should be some snacks and refreshments and coffee and tea for you. Please don't forget to get your parking stamped at the registration at the top. And can I request all the speakers from this previous session to come on stage, please? We will be having a photo opportunity as well as giving you a trophy and mementos. Mr. Oliver Baronatis, can you please come on stage and do the honor of giving the mementos to all the speakers, please? Saw some action outside, a lot of networking. I hope that was very fruitful, and very importantly, I hope you have refueled your system with excessive amount of caffeine. We have coffee throughout the day, and I think once in a while it's okay to overload your system with caffeine, so everyone stays alert. ก็ขอหวังว่าทุกท่านนะคะก็ enjoy break นะคะแล้วก็ได้ overload ตัวเราด้วยคาเฟอีนนะคะนานๆทีคงไม่เป็นไรนะคะดื่มกาแฟเยอะๆค่ะ All right, so for now we have quite a few speakers before the lunch break. So I think our first speaker is here. So ladies and gentlemen, I would like to invite you to join me in welcoming to the stage Mr. David Ang, Assistant Manager, Sales and Marketing, AGC Asia Pacific. Mr. David Ang.
Hello, yes. Hi everyone, I'm Sawadee Krap. I'm David Ang. I'm from the Smart Glass Division of AGC. Today, my presentation will be focusing on how BIPV has been leading innovative energy generation facades and how it can be useful for you too. So let me share a little bit about my company. AGC is founded in 1907, and we have been in the glass, chemicals, ceramics, and electronic industries ever since. Currently, we are also known to be a leading float glass producer with 34,000 employees in Asia and 55,000 employees globally. AGC has a strong presence in Thailand. Currently, we are operating in Papadang and we are commonly known as Kerchop Thai Asahi. We have manufacturing facilities across Thailand, such as the AGC Automotive in Chonburi and AGC Industrial Glass in Rayong. At AGC, we strive to promote clean energy towards carbon-neutral cities. In the upcoming slides, we will look into the Thai government policies towards the environment and sustainability in building construction. As Thailand moves towards being carbon neutral by 2050, the Thai government's policies on the new national energy plan to increase capacity of renewable energy to 50%. Future policies such as the Climate Change Act and the LEDS will have direct impact on future projects. In the ASEAN region, Singapore has begun carbon taxation in 2019, and it was reported Thailand will be one of the ASEAN countries to start exploring carbon pricing as an option. In Thailand, the electrical tariff, which is influenced by the LPG cost, has also increased as the Russian-Ukraine war continues. Recently, the Energy Ministry has also announced the mounting debt of the Oil Fuel Fund. With all this mentioned information, we shall look into innovative solutions such as renewable energy. This is a policy from the Board of Investment in Thailand which encourages companies to use renewable energy. The incentive can go up to 50% of the investment amount, which is quite a lot. As we move towards renewable energy, we should also reduce the need to encroach land and waterways for solar farms and transmission grids. As you can see, last night and this morning's floods, we should do something to the environment. We can do this with the introduction of on-site renewable energy, which will be generated within the building itself. With the ability to produce on-site renewable energy, we have increased reliability, stability, and enhanced energy efficiency. On-site renewable energy will also act as an emergency power source in an event of a disaster. In order to produce on-site renewable energy, most of us will think about solar panels on rooftops. But we know that rooftop areas on most high-rise are limited. Therefore, I'm here to propose BIPV, Building Integrated Photovoltaics, a system AGC produced since the year 2000, 22 years ago. With BIPV, we are able to integrate solar cells into architectural applications such as facade, skylight, canopy, and balustrade. The variety of application of BIPV is limitless with our highly customizable units. So, let me share some of the benefits of the BIPV. Unlike conventional solar panels, our BIPV has good transparency and allows visible light transmission into the building. It has improved durability against moisture, and it has properties to have UV reduction of 99.9% and OTTV reduction, which is important to the building envelope. Being able to customize our BIPV, we can assist our clients to maximize energy efficiency. Similar to most double gaze units, BIPV also provide thermal and acoustic insulation. Lastly, our Sun-Watt BIPV will come with our warranty from AGC. As an architectural glass, our BIPV will have considerable impact on the building performance of the building envelope. The thermal performance of an IGU unit with Sun-Watt Vision Square will have considerable impact as compared to a IGU unit with conventional facade glass materials. Our team will also be able to assist in the design of the solar path simulation, energy generation, and sun and glass performance. We will be able to provide the sun path simulation, solar irradiation data based on different applications and elevations. As a BIPV unit, our technical data will include information such as the module efficiency, energy generating properties, and the rated power output. As an architectural glass, we will provide information such as the SC value, U value, and other optical properties. So this slide will show you two variations of our BIPV module. On the left, the laminated BIPV module were made out of an extra clear low iron glass, an interlayer frame with solar cells embedded in between, and another glass panel. On the right, the insulated glass unit with BIPV. It will contain an additional air gap and glass panel. We will also be able to customize the thickness and the configuration of the module based on our client's requirement. If you're interested to find out how it works technically, please feel free to drop by at our booth after the presentation. The Sun Ewart BIPV will consist of two main product range, the transparent range and the opaque range. The transparent range will be made out of the Sun Vision Square and the Vision Stripe. The opaque range, Stock Ray Active, ArcLight Active, and Lacopel T Active. The Vision Square is a good transparency solution which allows visible light transmission with square-shaped solar cells embedded between the interlayer and two layers of glass. Dimension and thickness of the panels can be customized to different designs and shapes. We are also offering options to use bifacial cells, meaning solar cells with two faces, being able to have energy generation based on two elevations. The position of the solar cells can also be customized to make the most out of natural light and create a see-through effect. The Vision Stripe is another good transparency solution we can offer. It consists of many stripes of laser-cut solar cells embedded between the interlayer frame and two layers of glass. It's designed to give the aesthetic look of a Japanese bamboo blind. In Thai, we will call it man mai pai, embedded into the glass. This product can generate solar energy while maintaining high visible light transmission and transparency. Application of it being a vision glass will be most ideal. Stock Ray Active is an opaque solution with embedded solar cells concealed behind a Stock Ray Active coating. Stock Ray Active is designed to blend with our Stock Ray range of low-E coated glass. So as a spandrel, our Stock Ray Active will be able to achieve color harmonization with our Stock Ray range of low-E coated glass. So this is a color rendering of our Stock Ray Active with our Stock Ray Vision 50T. So we are able to produce color rendering images based on different view and weather conditions. So this is another one, Stock Ray Active with our Stock Ray Ace 40T. Both the Stock Ray Vision 50T and Stock Ray Ace 40T are low-E coated glass manufactured in our facilities here in Papadang. The ArcLight Active is another opaque solution with embedded color visual integrated in the panel. It's designed for developers, architects, and consultants who appreciate their freedom of design, as you can fully customize our solutions to suit any visual style. The graphics can visually communicate information with topography, color, and with any forms of design into our BIPV panel. Designs of natural elements such as granite, stones, bricks can all be integrated within. These are some of the designs of our ArcLight Active. The ArcLight Active is also suitable for visuals of company logos, CSR campaigns, and branding visuals. The printing possibilities of ArcLight Actives is endless. This is a blue BIPV panel. Over here, it shows an innovative use of our BIPV as an on-site renewable energy. The Lagobel T-Active is a uniform color glass panel with solar cells embedded within our high-quality light transmissible pane. Our special energy transmitting pane will enable solar energy to be harvested in this opaque glass BIPV. At the moment, we have 7 color choices: black, white, blue, and tones of gray. We are also able to produce this fully customized panel in gloss and matte finish. We do have samples at our booth. Feel free to drop by to take a look. These are some of the innovative solutions and project reference of our BIPV. The Vision Square was selected to be installed as a facade of the Hattari project in France. The designer designed the position of the solar cells to be embedded in the panels to enable visual light transmission on the eye level to the converged points of the horizon. As the occupant, you will have the clear view of the scenery while you are able to harvest solar energy. The Vision Stripe is another one of our products which is suitable as a vision glass. It's designed to have maximum transparency and visible light transmission. From a distance, one will not be able to notice the stripes embedded within the glass. But a close-up view, you will be able to review the stripes embedded within the glass, which will recreate the look of a Japanese bamboo blind. Of course, it still have quite good transparency with that stated. And of course, the solar cells are being visible here on the exterior of the panel. Earlier, I shared about our ability to produce bifacial cells on the Vision Square range of BIPV. Bifacial cells on the BIPV will be used to generate solar energy on 2 elevations. In the morning, on the east elevation, on these sides of the cells, and on the afternoon, the other face. The position of the solar cells can also be customized to enable transparency on the top part of the panel in order not to block the view of the scenery. So all our panels can be fully customizable. The Vision Square can also be used as vertical fins to control the amount of sunlight emitted into the building. It will eliminate glare and excess solar gain by diffusing natural illumination and improve daylighting. The solar energy will be then harvested as a source of renewable energy. When used as a skylight in the Matsumoto City Station, the Vision Square can reduce undesirable solar gains. You will also manage natural light as a design element. Projection of the Vision Square will cast square-shaped shadows on the concourse, which represent square patterns and improve the architectural aesthetic of the concourse. Vision Square can also be applied as a canopy. It's ideal to have the ability to harvest solar energy and, of course, provide shelter against various weather conditions. It will also provide adequate daylighting into this train station. So this is a project in Thailand where the Vision Square was installed as a canopy. It's located in the Lampun province close to Chiang Mai. Vision Square acts as a source of renewable energy. While providing natural light, we also be able to harvest solar energy. The spacing between the cells was customized to enhance visible light transmission. We will be able to customize the location of the cells and the spacing in order to improve the visual light transmission. ASEAN Rainier Boson used the Vision Square BIPV as a canopy of the rooftop of this project in Monaco. The rooftop space was maximized without the installation of conventional solar panels. With Vision Square as a canopy, the designer provided adequate visible light transmission onto the rooftop area while harvesting solar energy as a source of on-site renewable energy. Lagobel T-Active was also installed on the roof of the French Ministry of Defense building. The architect used BIPV to be installed as an origami-like roof with angular sections to generate solar energy. The golden aesthetic on the facade of our Tour Duo in France was achieved with our art light active. So it's basically all these fins will actually be our art light active. It will enable the harvesting of solar energy in this iconic facade design. The project has also been awarded multiple building certificate as a sustainable construction with our art light active. We are offering a one-stop solution to provide services such as the design, energy studies, and installation. During the design stage, we will be able to provide provide simulation, solar studies, and during the energy studies, we also provide information for you to attain performance targets in your various building certificates as a source of renewable energy. I hope that my presentation will inspire you to look into various possibilities of on-site renewable energy into carbon neutral buildings. So with that, I would like to conclude my presentation here. So thank you very much for your attention. Please feel free to drop by our booth after this presentation. Sawadee krap.
Thank you very much, Mr. David Ang. Thank you. For the next presentation, ladies and gentlemen, I would like to invite to the stage Mr. Somkiat Lo-chindapong, Deputy Managing Director of Architects 49. ขอเรียนเชิญค่ะ
สวัสดีครับ Okay, thank you. My topics kind of going backward a bit and probably could give you some thought to move into the future. This is a unit at the Barbican Estate in London. Some of you may know about the building. Yeah. One of the unit, I think one of the larger unit at the moment is put up for sale for like £4.5 million, which is quite impressive. It's built in around 1970, and I believe it's loved by people who are living inside, but also it's being hated so much. It's voted the ugliest building in London in 2003. This is the latest photo of the complex. The original timber frame window, the original drawing, which bring us to the topic we are discussing today about the material used, the material that could age beautifully. For example, like the timber frame window, the bush hammer exposed concrete. That's how the bush hammer, some of you may know, will not survive the LEED or BREEAM certified process nowadays. A lot of dust. The finish of the building is still a topic I discussed with my client in Bangkok positively. Next one, I like to show you this building. It's a research building in Boulder, Colorado, by MP. That's just a photo taken in 2019 when he passed away, almost 60 years after the building finished. The interesting thing about it, and also intrigued me a lot, is the way they, it's built in brutalist period, a lot of exposed concrete and so on, but the pinkish color you see here is actually from the red sandstone from the quarry nearby the site. It's put in the in situ concrete, and they did this kind of thing 60 years ago. And you look at the finish, it's almost like exactly 60 years ago, which is quite interesting. I find it's intriguing because nowadays, you know, the way, I mean, to use the local or regional material in your project is quite fashionable, right? There's a sustainability quality in that kind of thing. And that's when he worked on the mock-up. You can look at the date. This is another building. It's one of the earlier high-rise in Boston, built in 1966. The image on the right-hand side, I took from the website of the current owner of the developer. And I go through the data. It's got LEED Platinum certified for existing building. Also WELL certificate. Quite impressive as well. I came across the building during my trip a month ago, and I took this photo, and you look at all the precast unit here, it still looks really good. And I'm glad for the building because it's not, I mean, it's kind of survived the re-facade concept of what we usually did, yeah? I suppose of course they have to retrofit the MEP, but I'm not so sure about the glazing unit because there's no such thing like double glaze unit at that time. So I kind of Googled further about the architect. His name is Frederick Stahl. And this is also one of his buildings in 1960 as well. And then it's also used this kind of precast concrete facade, waffle slab, yeah? And it still functions perfectly until now. No need to re-facade. And the Seagram building, even, you know, like 1959, finished in 1959. I just learned that all the facade element here is made from brass or metal that kind of similar to brass, copper and zinc. This is also a photo taken a month ago. And at the annex building at the back, I looked closely and really impressed by this sort of immortal quality of the brass material. They are all original, but I believe this spot well here is not original. Maybe they fix it somehow. I mean, even all the granite slab, the travertine panel, everything is there. Is all original. Kind of fast forward to 2012. This is a building by Kenkokuma in Tokyo and used the cedar, the fin made from cedar, the type of wood. And it's not fixed to the mullion as I originally understood. It's just fixed at the top and the bottom. I use this photo intentionally from Google Street View just to show you the current stage, because this one you can see the date here, 2021. All the fins, the finish still looks perfect condition. I did visit the building a few times after 2012, and the cedar turned gray at some point, but I believe they have kind of recorded them from time to time. But I think this just shows that wood is really a sustainable material in terms of both environment. You know, you cut it, you regrow them, you cut it, you regrow them. And also in terms of aesthetic, it's beautiful. This is a building called Nora Tower in Stockholm by OMA, our partner in the Central Park project. They use precast concrete, exposed aggregate, polished, and CNC, you know, like groove them. Really nice. And I believe it will stay there for 100 years. This one is by David Chipperfield. It's a residential tower in Midtown, Manhattan, near Bryant Park. They use the sort of terrazzo, precast terrazzo facade. You look at the detail. What is interesting of the material here is that when they produce the material, they kind of cast it in big block, slide them thinly, slide them, polish and slice, just like how you cut your marble slab from the marble block, and then you just cut and compose it. This is an image, just show you the close-up photo, and then if you look closely, there's a corner piece here that's just explain how they compose the U shape of the facade unit. Back to Bangkok. This project finished like 5-6 years ago, and we use exposed, quite simple, exposed precast concrete panel on the facade. The precast concrete, as you know, we also kind of put some aluminum and anodized finish aluminum trim to give it some different look, yeah. And on the precast concrete facade is quite tricky because you have to get, I mean, in Thailand, of course, you have to get all the sand, cement, all the aggregate from the same source to get to match all the color, you know. And I think it's turned out pretty good. We, of course, have to put some coating on the facade, but you know, rain or shine, it looks like this. And I hope that it will stay like this for a long time, yeah. We also explore other different kind of material that would age nicely, you know, like this facing brick for a training center for one of the biggest insurance company in Thailand, Muang Thai Prakan Chivit. Also in the same project, also like sort of teak, soffit. This is all outside, but it's at the soffit, so you're not worrying too much about the fading and so on. But of course, we hope that it will stay there and patina a little bit, and then still look nice. We also work on the sort of brick. The project used this facing tile and brick because the province they are famous for those ceramic work and the brick work as well. So we try to use this kind of thing in the project. This is basically just to line the mouth in front of the side. The mouth is to protect the highway, the sound from the highway truck into the side. Yeah. I actually kind of sit down with the bricklaying guy to discuss how to put it in step nicely. Yeah. This is another project, the sales gallery for the Central Park project. Some of you may know, is on a super busy intersection in Bangkok, Silom, Saladang. Yeah. And with pollution from heavy traffic in the area, so we thought we just kind of wall the building, kind of cocoon the function inside. Basically, this is the facade of the building. And of course, you have the reception area with skylight and so on. The facade made from precast concrete column with sort of second layer, thin layer of the aggregate white cement. When we work on this, of course, we also have some tight budget to really require. We have to use this, basically it's from a precast concrete pie that probably some of you are quite familiar, the one with the hole inside. But when they cast it, when it's almost set, they put another layer of white cement with aggregate that, of course, we work with them and polish it afterward. And we got the result. Quite interesting. It's a bit ironic to use this sort of long-lasting material with temporary building because the building will be demolished in a few years' time. Yeah, it's just right in front of the project. This is a mixed-use project for the property arm of Chulalongkorn University. It's basically contain a residence for all the faculty and then also the dormitory for the students, retail. In this one, all the elements you see here in the facade of the tower are all in precast concrete. We originally would like to use the white cement technique I mentioned earlier, but there's a lot of it's like I said, it's quite, and then we are also in the early stage of developing this kind of material. First, it's quite difficult when you have to finish the four sides of the fin, for example. It has to be finished four sides, right? Or even the corner piece. The second thing, which is more important, is that the white cement doesn't, when you mix with the mix into concrete, it doesn't have the strength requirement that you want, that you require. For example, when you have a panel and then span floor to floor, and some of our panels also like span double floor or something like that. So in the end, we have to opt for like a just basic monolithic concrete. But of course, we are working on the aggregate, and then the mixture of the cement. And this is an earlier mock-up test on the material. This project is actually from a former colleague of A49, Skan Jayawat. I borrow the project from him. I asked him already, but I'm going to present here. It's quite interesting. It's basically an industrial building under construction. And you can see that he is trying to use the material with longevity, First, you look at how the steel work is all in galvanized steel. So if you turn gray and then just stay like that forever, no need to repaint, right? And on the facade, it's basically the precast concrete with a thin finished layer of the white cement I mentioned earlier. And you look at the size. So in this case, they use hollow core, precast concrete hollow core, but of course not exactly like those for the floor construction, because they have this kind of it will bend a little bit, right? I think they have to work out for this one because you need these straightness. But if you look closely, you will see this sort of a thin layer of the white cement aggregate. And then when they start to settle, they just use the rake to groove it. It's an HO technique you've seen in those building in the past, right? But that is like normal exposed concrete. This one is like you start to work on the aggregate and so on. And I'm sure that it will HO beautifully. Next, I will discuss a bit about what is happening or what could happen. Perhaps we'll give you some thought of the way to move forward in this kind of direction, yeah? of course, we have this exposed aggregate precast concrete, like the one we work on at the moment. You can also pigment them. This is also actual from an actual project in Spain. But I believe if you use the color from natural material, it will stay there forever. Like the research building by IMP. But if it's like a synthetic color, then it could be tricky. Like the darker color will get fade over time. And of course, you can also use some recycled material as an aggregate. Like the recycled glass, like this. Yeah, could be like a Heineken bottle. And another one is quite interesting is the exposed aggregate GRC. You're not painting over the GRC anymore. You just expose, and then you also work out the aggregate of the GRC, and then put it on the facade. This is one of the projects we are working. Actually, I work this project with Kun Andrew of Facade Associate. And this is a mock-up unit. Sorry. The GRC panel here actually was part of the unitized facade. So they will like put in an L shape together and then lift it up. Building that finished a while ago in Sydney by Frank Gehry, but the reason I bring this up is just to show you that for this kind of material, and nowadays you also need a more sophisticated installation detail. Like this is on the left hand side it is a mock-up, and then on the right hand side is a real photo of the site, or the stainless steel fastening. Yeah, and then you can see that it's kind of teal, like Frank Gehry wavy facade. The brick facade at the Tate Modern, and then the switch house building as well. Also quite impressive. And when you look at this detail, like stainless steel rod, rubber pad ring, blocking when you install it. It's really, it tells me that they are actually on the Premier League, not like us, yeah. And I think the architect, Herzog and de Meuron, continue with the type of facade at the RCA in Battersea. And just to show you that, in the past, 100 years ago, you are not putting the brick on the soffit. So this is like a mix of old and new. And the last project I will show is this kind of super thin, super tall. This is actually an actual photo of the building, not a rendering. And from what I read from the architect is that they say that the inspiration is from the terracotta facade of the Art Deco building in New York, like this one. But they, of course, they have to use a new technology and then, a new kind of manufacturing, but it's quite impressive, again, going like 400 meter high. Yeah, and you look at this sort of installation detail and so on, which is, I'm sure it will last a long time, and then it also gives some reference to the local, and it's quite nice, yeah. So I'm gonna end my presentation with, some thought, not yet, not the turtle, by the way. I think it's really like a concept of try to use the building or use things around yourself longer, like it's more sustained, right? Rather than buying every facade, like I always say, refacade every 7-8 years, something like that. So, I try to show you this kind of image, like you know, like camera. I read about celebrity photographer said, you know, it's rubbish that your camera, you know, a good one, always new and then no scratch and this kind of thing. I think and they have to have some story like this. And you know, like the luggage, you know, it could have bump and scratch, but it still looks good. And of course the watch, but maybe not Rolex. Also, it should last generation. You're not buying every 2-3 years, something like that. The leather shoes that, you know, you got crease and wrinkle, but it still look good. You know, this kind of thing, yeah. I also read about a guy inherited a suit from his celebrity dad. Quite interesting. A teak furniture, you know, that could turn gray, and then, you know, you use it like teak is really amazing. I mean, it can stay there, you know, and then once you just sort of recoat them a little bit, it's getting new again, and then you just use it almost forever, yeah. And yeah, men and women, yeah, which I hope can age beautifully as well if you are taking care of your health. And thank you.
Thank you very much, Mr. Somkiat, for sharing with us quite a good variety and good number of previous projects that your company has worked on. And I do believe as well that we all would love to age gracefully. I think that's another another thing we can take back with us today. ก็ขอบพระคุณคุณสมเกียรติมากนะคะ และในโอกาสนี้นะคะดิฉันขอเรียนเชิญสปีกเกอร์ท่านถัดไปขึ้นมาเลยนะคะ And if we are ready, I would like to invite our next speaker on stage, Mr. Nitin Govila, Director, APAC and MEA, Sergi Ferrari. Mr. Nitin, I will hand over the stage to you now. Please.
Thank you. So, good afternoon to all of you. The previous session gives us a good platform for us to talk about some sustainable materials and some unique facade materials. And that's where I'm here from representing Serge Ferrari Group, which is a French company in this business for the last 50 years. So I'll share a bit about our company and what kind of facade materials and what application and advantages you can get out of it. Just to share, so I am based in Singapore. I manage the Asia Pacific, Middle East and Africa business. My colleague David, he's also here, so he manages the Singapore, Thailand, and the Malaysia business. So we're both here, and if you have any questions after this presentation, we are more than happy to help you if you come outside at our table. So my presentation starts with an interesting concept where it's about fabric facades. Basically, it's designed to impress, created to last, starting with the face of the facade, the fashion element of it, and the functional element of it. So I'll try to cover all these three elements, which you can see and get it in the fabric facades. So let's start with a brief video of what Serge Ferrari Group is. For some of you who may know, for others you may not, just to give you a brief background on that. I'll have to play it here, I suppose. Yeah. No sound. Sorry. So sorry for the audio. I can maybe request additional 2 minutes at the end if I pass my time. So you saw that we are in different market segments, ranging from different interior, exterior applications, even technical applications like biogas, marine, furniture. And all those, depending on the application, we have the different kind of materials. And here, obviously, the focus is to talk about facades. So going forward, yes, sorry. It's a French company, as I mentioned, so we manufacture from end-to-end process, even from the time we develop the yarns ourselves to weave, to then coat it, and then finally, obviously, pack it and sell it. So we are a fabric manufacturers. We have manufacturing plants mostly in Europe, which is France, Germany, Italy, and also for a certain kind of product in Taiwan. These are our locations, as I mentioned. So we have manufacturing across the world, depending on the product segment we look at. So most of our facade products are made in Taiwan, France, and Germany. These are our key strategic markets. You saw many of them, but these are our main focus strategic markets. As we say, tensile architecture, which could be big structures, exteriors, stadiums, airports, walkways, shade structures. You have many of those in Thailand. And facades, even acoustic membranes. Then modular structures are basically even tents, small events, small canopies, tents, and lodges. You have solar protection, which we mean as blinds, interior, exteriors, and pergolas, awnings, and then furniture and yachting. So let's come to the facade element of it. So as I mentioned, if you remember, I talked about face, function, and fashion. So let's start with the function, fashion element of it. So what the fabric facades gives you a good chance to have a three-dimensional envelope in terms of, this is a structure done recently this year, where you can play with the shape according with the profiles, and you can design it accordingly, which normally ensures not only you have good thermal protection, but also good visibility from inside and outside. Or it could be a simple flat structure. This is an Airbus restaurant in France, where you could create whatever shapes you want to. And on a closer side, when you look at it, there are some patented profiles which you can use to ensure that those profiles and the structures are hidden behind the fabric. So that enhances the aesthetics of the product and the building. And at the same time, it does not block the view. So this is the view through from the inside in the same building. On the left side is the outside view, and this is the inside if you're sitting inside. So you still feel you're connected to the outside, but you have own privacy and good glare and thermal protection. This is a big tower also, so it's not only smaller buildings. You can even envelop bigger buildings also. This is on Sukhumvit in Thailand, a high-end showroom, which has been enclosed with the fabric facades, with a patented profile of which we have a local supply on that, so that you ensure that you are able to get the profiles even at a very reasonable cost. This is another building. Then when we look at from the element of fashion, then you look at in terms of how do you manage the lighting and the projection. So this is a stadium, which is where you've coated with PTFE membranes, but you can play with the lights. So you can use even use a mesh membrane or like a non-mesh membrane to ensure that you're enveloping a building and playing with the light and the surroundings. This is in a theater in Netherlands. This is at night. You can play around with the lights. You can even print on it. So if you see, so that's where you're able to ensure a good view through. You can also, do projections on that. This is a projection. This is a hotel in India where they made this fish design, and at an event they can project also on the same thing. Then the third part comes is the textile nature and the printing. So this is a library in France where you have printed it, and then you can install. So you can get your brand identity. This is a car park, which in a way as an open car park could have been quite ugly, but when you kind of use the fabric facades and print on it, you can add the value to that. Same thing here. Then the key element comes after looking at the fashion element of it, then the functionality element of it. In functionality in a facades, obviously what you're looking for is visual control and glare control. So this, as I already mentioned about this project, where you're sitting on the inside and then you're able to see the view through also. Same thing, it gives you a good glare control, so you have to manage too many times the light, the sun, the screen, and stress out. So even in an open space or in a walkway. So you have a good element of light coming, but at least it's not too hot. Then you have the element of thermal comfort and control. So the benefits of textile facades runs across 4 categories in a way. So it's the transparency part, which means you have a good view through. The natural light, so you're still feeling that you're not kind of in an enclosed building. You're connected with the surrounding outside. The privacy part, and also the glare control. And more, obviously, last 2 years in COVID, we've spent most of the times inside the building. But at the same time, light is also source of an health. So that's the way you can actually balance the part. Now, the exterior screen, what it also does is, if you see, when you put it outside, you're able to block not only the 85% of the thermal heat, at the same time, you also ensure as a mesh the natural ventilation which comes. We've internally developed a tool, what we call as a solsticism tool, where in fact you can pick up this country and the city, you can pick up the type of the building, what kind of glazing has been done, because the fabric facades generally is second skin unless you are enclosing an open structure. And depending on the type of fabric, you can even do a calculation based on that type of city, how much cooling load, how much solar gain, or how much benefit you can bring in terms of even air conditioning saving. And we have data for nearly now more than 100 cities across the world. And this has been a self-developed tool which is accessible to any designer, consultant, or companies which are in this business. So this is the level of analysis which you can get directly in terms of savings. And you can even do plot graphs by month, by year, or the type of building and glazing. So feel free to contact us if you need more of information on that. And this is the kind of analysis you can get at the end in terms of the type of fabric. So we have different types of fabric. So you can, here we've taken one element, but if you need a higher openness or a lower openness, you can use that also, and that data will come out. So exterior skin, as I mentioned, helps in thermal protection. So when you add, say, a fabric like that, that's the kind of saving you're talking about in terms of over a running period of time. So your ROI also increases. This is just a case study of a building in US, where this was the building before was like that, where they were losing tenants and bigger electricity loads. And within 10 years, they've been able to really get back their investment and the savings of nearly 60,000 a year. This is another project where total saving over the years has been, the same project where it's around 700,000 a year. Then finally, obviously, the question then comes in certain countries where it's much more severe rules compared to others is about fire performance and safety. So most of the fabric materials are kind of either PVC coated, which is with the DIN rating of B2, B1, D0, or the PTFE glass filament based products. So depending on the requirement of those business, of that construction or of that city, you can have the right product available for you. This is just to give you an idea of the airport done in Europe and the kind of fabrics, because it's a second skin. It's also used for aesthetics and functionality, so you can play with the fire rating in the way you want to. Then coming to back, all these elements, when you look at it, it's not only for new buildings. In fact, it gives you a much more opportunity even to renovate the buildings, because the existing structure is also there. It's a very lightweight fabric. You don't put a structural load on the building. And at the same time, you can transform your old buildings to a very new one. And if you look at why, because it's very soft and strong, as I said, around 550 grams a square meter, strong weather resistant. There's no Faraday effect in terms of the communication is smooth, and no whistling sound, and also natural daylighting, which we talked about. So you look at in terms of renovation. This is the old building. If you have to do anything, you have to take down a lot of things. But here, with a simple structure, not too much load on the building, you can transform the building in the way you want to. Same thing here. And the thing is that one difference here you see with fabric facades and the metal one is the perforation is smaller. At the same time, it does not block your view. So you see the difference where you have a better view through from inside. And that's the difference when you see also at the closer level. And then in terms of when you look at different parts of the day. So what kind of fabrics we have for you to propose? So we have a range of solutions both in PVC and PTFE. which have good mechanical resistance. We have a patented technology. When we are doing the coating process, we are already pre-tensioning it. So what it does is that the stability and the flatness remains. And the warranties which we give vary from 10, 15, and 20 years on this product. So in that sense, there's no sagging, there's no curving, there's no curling, which is also very important when you're doing a facade thing. As on the left side are the PVC-based fabrics, and on the right side are the PTFE-based, which is glass yarn-based. So these are the colors available, but we could do much more colors based on certain requirement, and you can print on that. Then you have the PTFE ones, which are based on glass yarns, and again, depending on the city's ruling and everything. And I'll just like to share some of you who might have visited Dubai Expo. A lot of projects have been done using the facade from the group. So this is the bird view where you walked underneath that. This is made of PTFE mesh. And PTFE obviously has a long durability in that sense. This is also a facade project, not a mesh, but a membrane. You might have seen this. I mean, it defines the Dubai skyline. It's been there for the last 25 years, and I don't know many of you know that or not. This is the PTFE membrane, which has been used and still working well and as clean and white as you can imagine. And even in the dust and everything, so that's why we still say it's still young at 25 years. So in terms of durability and longevity, it's not that it's a fabric facade, so the life is smaller or lesser, but you can get a much longer design life even in that. This is a new product which we've developed, a structural fluorinated membrane envelope, which is with 50% transparency and a type 2 material. So it also gives you good view through, also gives you better thermal protection, and if you want to have a bigger transparency. But it's not a mesh, so it's obviously rain protected. It's also with a 10 years warranty and with a nice natural light and light transmission in terms of easy to create shapes. So this is a project just done recently in Istanbul at the airport. So then the question comes is obviously how do you fit it? What kind of tensioning systems you use? There are many options. Either it's free form, depending on the structure you use, so depending on the design. So a lot of manufacturers are there, I mean, very specific manufacturers are there in different countries who have the necessary software and technology to design it as per your need. The standard ones, then are the frame ones or the monolithic ones, which are definitely patented ones, and we have one partner in Thailand as FTI we can support you with that. And then you can also, some of the manufacturers can help you design yourself those systems. So this is the company I mentioned about FTI, where they have 4 different kinds of systems, depending on your structure, the flexibility you need. The key element is the fabric tensions very easily, and it also hides all these profiles behind the fabric. So it does not damage the view. This solar skin is the one which has been developed for PTFE also, because PTFE is more sensitive material. You have to be more careful about that. So that's also done there. This is just more details, but we can give you more details if you wish to know more. Then I'll just, before ending, take you through some of the reference projects which have been done in the last few years, depending on the design, the flatness, depending on the building. You could just do like this also, just on an aesthetic basis or on a certain design basis. This is a car park we talked about. This is a stadium or a building. This is a stadium recently for the World Cup. So in Qatar World Cup, out of 7 stadiums, 5 are with membranes and fabrics, and all 5 have been done by our group. This Al Bayt Stadium is very unique in that sense that it uses PTFE mesh and a PTFE membrane of different colors. And inside, if you see, it's like a Bedouin tent where the acoustics membrane have been used. So it gives you that effect, which has been printed from the yarns, so it's not been colored or printed. The yarns have been used and woven in the design of a Bedouin tent. So the whole idea of this stadium was to give a feel that you're in a Middle East Bedouin tent, and you get that feel. So outside is a PTFE membrane, and inside was the fabric, acoustic fabric. So this is a stadium again in Qatar. As I said, we've done 5 stadiums. So if anyone, I'm sure some of you would be planning to go there, you'll have a view of all those stadiums, you'll see that. So this again, same thing. This is also Qatar World Cup Stadium. This also. Then if you go further, some other Dubai Expo projects, 19 of the pavilions were done by Search Ferrari Group products, both for facades or for membranes. You see that. depending on the different kind of application and designs of that country's pavilion. This is arena in Brazil, which was done few years back. This is Cape Town Stadium, done again for South Africa World Cup. This is again a stadium where, this is a perfect example of an old building where the fabric facade was put on the outside to renovate it and give a different look. This is double skin facades. This is a building in Jakarta. This is in Saudi Arabia. And you can even, this is again in Saudi Arabia, one of the most dusty countries. This is in India. This hotel I talked about already. This is in, at night you can play around with the lighting. Again, a flat structure. This is at the metro station. And then this is a cloud structure created in India also using these facade fabrics. So there are many applications. Obviously, then the question people ask is, what can we do about maintenance? So you can do an easy cleaning as you would maintain any kind of facade, whether it's glass or concrete or anything. So it's easy to maintain, does not change anything. And then we also have warranty reports and everything, plus the EPD declaration, which can help you with today's needs of the market rewards sustainability and green products. So all this is available. We are more than happy to answer all your questions if you have any, and we can meet you at our table there and take you through this. So that's the end of my presentation with face, fashion, and function. So thanks a lot. Thank you for your patient listening, and I hope to see you later at our table. Thank you. Kapan kap. Maybe we'll just take you through the video with the sound now. Yeah, it's the third one, slide 3. Yeah, slide 3 actually. You'll have to, I don't know, 3. Yeah, so maybe we close, yeah. We can go up, yes. This one. Sorry, slide 5. Yes. No. It's okay, I think let it be. I think let's not. Yeah, just try. No. We go behind the slide 5. Yeah, just let's try. Sorry. Thank you again, Kapin Kap.
Thank you very much, Mr. Govila. Thank you. I would like to invite our next speaker on stage now, Mr. Joerg Schleusener, Project Director, Chuko Southeast Asia. ขอเรียนเชิญค่ะ
Hello, everyone. Sawadee krab. And welcome back. My name is Joerg Schleusener. I'm the project director here for Chuko here in Southeast Asia, based in Singapore. Great to have you back, all of you, after 2 long years of COVID and travel restrictions. It's good to be back. Thank you very much, Ahmed and your team. Very well done, as well as Oliver and the Chuko team in Thailand. Unfortunately, I cannot be there. I would love to, but I have some other priorities here in Singapore I need to attend to. So let's get right to it. I would love to show you something of not the typical perspective of Chuko. So, of course, everybody knows Chuko for windows and doors and sliding doors and everything. So I would like to have another look on the other part, which is, I think, more where I come from is more important, is the facade systems, and then having a look on iconic looking facades and everything. So, of course, everybody knows the Swiss Re in London, which was kind of a milestone in facade design with a 3D shape. Although it's quite simple to some other projects, it was really one of its kind at this time, 20 years ago. Schmidlin was the Swiss fabricator, and they really developed the whole thing using new 3D softwares and everything. The same goes for the GLA building in London. All the elements are more or less different shape, different angles, different way of assembling it. More recent, the Morpheus in Macau, Zaha Hadid project. The same goes here for the inner part, which is really quite complex and complicated 3D system. We also have a 3D shaped project, which was the Port Authority in Antwerp. Also a Zaha Hadid project with these triangular shaped elements, more looking like a uncut diamond. Because Antwerp is famous for the diamonds and everything. So we had a flame towers in Baku, Azerbaijan. It was also kind of flaming shape. We had same goes with the PBD2 in Baku, same 3-dimensional shape. So basically, we have to ask our question, and I hope I answer this today, saying how can we get to this look? So first of all, it's a timing factor. So involve a facade specialist as early as possible on the project during the schematic design or design development to really have a look at these 3D shaped a facade system, the architect proposing and 3D modelings and everything to say, yeah, what can we change and what is optimizing the facade? Because, I mean, everybody knows that if you change the design in the late project, it's really difficult, has a huge impact on cost. So there's a little bit of a diagram showing the effect and then the timeline. So different stages of the design from pre-design to the handover, the ability to impact the cost or to minimize the cost and everything. So the red one is if you are changing it early, no impact, can be really, it's just a design phase. Some drawing needs to be changed. So this is really easy. If you go into the construction phase or a bidding phase, that's already a big impact. So traditional design is somewhere in the middle. Reality, unfortunately, is a lot of things happening during the construction, and that's a huge impact. And if you do this with an integrated design, well coordinated at the beginning with some 3D files and include this already in the tender stage, everybody's aware of the design and the complexity. So this is really helping a lot to run the project more smooth. We had an example on this early coordination for a project in Jakarta, the ICANN project, fortunately not realized, but We really coordinated with the developer, Duta Angada, with the consultant, Meinhard, for the possible design, which is not really complex or complicated. It was just complex, a lot of different materials. We had a recess of a glass within the facade system. It has to be very narrow. The glass pane is a total height, including the spandrel. So there's a lot of internal things to be combined. Also, the fabricator was already on board, which had also a positive impact on, because we can also always look at the costs and provide it to the developer, everything. So at this time, we even made a little movie and animation showing the building, how it looked to be for the assembly, and also later for the construction and installation. So we had a look at the installation, the assembly, and how to machine the profiles and everything, how to seal it off, and then also look at the installation and how to lift it up to the place and lift it then into the place of the designated location with all the measurements in terms of drainage and sealing off and everything. So that was pretty cool. It helped a lot for every parties to be there, and everything is good. So the other part from coordinating and everything is really regarding the specification and to write a really detailed as possible specification, specifying all the material, including the facade system, but also the other materials like glass, structure materials and everything, just to have, avoiding any mistakes and wrong expectations about what you might expect, and at the end you can get only a Lada and expecting a Ferrari. So really looking at each trade and each component and material in the facade, just to avoid these kind of things happening later. Talking about the facade system, what is the best facade system for kind of 3D shaped building? It's difficult to say. I mean, we have two facade systems. One is the American, coming from the original, or they call it American, it's a square cut. We call it male-female, where the interlock is done by the aluminium profile, and between the aluminium profile, there's just the gaskets and guaranteeing the water tightness. On the other side, we have the European system, which is, we call it the female-female system, where the interlock of the aluminium extrusion is basically done by a gasket, which is inserted in both profiles. Horizontally, it's running continuously all over the floor. Vertically, it's overlapping the horizontal gasket to guarantee a proper water tightness. So that's the blue area I just described. Then we have the connection of the elements is done with corner cleats because it's a mitre cut. So it's also a proper connection where you can really then have the corner cleat and fixing it to the thing. So I would like to have a little bit of a longer discussion or a presentation regarding the project called Vakif Bank Tower in Istanbul, which was done with a local fabricator. Consultant was Werner Sobeck from Germany. Is really a traditional experience office for all these 3D. I think they were also involved at the Swiss Re Tower. So basically, the challenge was having a different kind of shapes, floor plans layout at the ground floor or the lower floors, and it changing completely into another shape at the higher floors. So the whole thing is tapering, twisting, which of course is done with the triangular shaped elements, which were then also included into a diamond shaped, which has basically one surface, and the angle, the changes of the angle is then in these joints between these diamonds at the corners and also inside the facade with the bigger ones. So this is allowing them to have this different kind of shape coming from a square shape on the lower floors into a kind of star shaped profile on the higher floors, which makes the whole project kind of twisting. But then also you have these tapering, which is then having different shapes and different modulation or different sizes of the triangle, and also different quantity of triangles within the diamond shape. So this was pretty complex and complicated, but with the help of our engineering and 3D team in Germany, which we supported the fabricator with all the design, we basically came up with an inventor model, an improvement or a fine-tuning of an inventor model, where we can allocate then the triangular shape within these diamond shape, defining the sizes, and basically this inventor model then transfer the whole information into bar drawings, assembly drawings, virtually in 3D. It's like a BIM model kind of, which allows then the fabricator to machine the profiles and then guarantee or make sure that the assembly is also within the quality criteria and everything. The system basically was done with a female-female system, which allows all these different angles taken, being accommodated with the gasket inside the joint, which can be then in a different angle, which then also allows to minimize the different extrusions and the less quantity of extrusions. So, like I said, it was really on 3D. We had only a standardized assembly drawing with different angles, different materials for different areas to go through. And this is basically the team at the installation of the last element. Unfortunately, the weather was not so nice to look around, but this is really a impressive building, I would say. Nice done with the nice teamwork between the Schüco engineering and the fabricator. We also had one in our region here in Southeast Asia, Surabaya. It was the Avian Tower. It was basically a similar design. These twisting but it was not much that tapering what on the previous job in the Yakif Bank Tower. It was at the beginning proposed with a male-female system, but we quickly realized with all these different angles and the warp within the element, we had to introduce these diagonal transom or mullion to allow us in different angles to follow the whole design. And we then decided to go for a female system. And what we also invented is kind of a custom hinged cleat, which allows then different angles from the mullion to the transom easily to go through, and it was really a success with the partner in Surabaya or in Jakarta. Another one was also a similar one in Dubai with our Middle East team. Not so complicated as before, but the original design intent was to use a stick system, which was very hard to accommodate the high building movements from these mid-size or high-rise building. So we then also quickly said we have to go through a unitized system. We had a look at the female-male system, but we then quickly realized whenever the surface is changing, the mullions are not meeting properly. We had an offset of really high twist and turn, so it was not also possible with a male-female. So we then also switched to a female-female system, and then it was pretty easy to go through the different angles on the surface and everything. So we even could integrate the lighting, LED lighting. So this was really, a very good success and a very good solution. On the facades, the complexity, yes, choose wisely, I would say. For example, we have our parametric standard system, which consists of two components to frames, let's say, the inner frame with a traditional mullion and transom, and also the interlock with guaranteeing the water and air tightness. And then on the outside, there's a kind of three-dimensional a frame, a second frame, where you can then have a different dimension, different shape, different materials, glass and everything. So we built a project in Copenhagen and also tested it here. So you can really have different angles, different lengths of the glass and everything. So that's also quite flexible. So the yellow one is the outer frame or the main frame, let's say, with all the gaskets and water tightness fit and features. And then the outer frame is the blue part, where you can then change the glass, the infill, and all these kind of things. So pretty impressive. Very easy installation, like a normal unitized system, and it looks really impressive. You can also use it as a highlighting selected parts of the building, like the main entrance, or you just go the other way around, and the principle is the same, to deduct, basically, not protruding out, but going inside, and then the whole building becomes a different shape and a different impression for these kind of systems. You can also have these kind of different stepping in, the stepping out, floor to floor. Then we chose for a window wall, which we are currently developing as a standard system, which can be then also, of course, every time customized. We have a current project, the Scope Length 1 in Bangkok, which is the same thing, where I have these kind of different angle layouts. We call it zigzag, and then with different inlays, windows on this side. So this was also very, very impressive. Of course, I mean, with the iconic buildings, a kind of innovation comes along. So one of our recent one is the Internet of Facade, which is basically a barcode, a QR code, having all the information of the element. Basically, that's for after the handover, for the maintenance, for the end user. But we are also currently developing the whole thing during the assembly and the installation, to have all the relevant information in the QR code. We have another system at the moment, which is called Grid to Shell, GTS. That's allowing all these three-dimensional freeform surfaces and buildings, vertically, horizontally as a roof, vertically as a facade, but without having another supporting steel behind. So basically, the nodding point, the green part in the middle, is customized for each project with the different shapes, but all the other components, like the mullions profiles, standard system, and pretty impressive, strong. The good thing is also that our daughter company, who's taking care of the system, is developing most of the things in 3D model, which then can provide the fabrication drawings, the bar drawings for the knots, and then also the cutting list for the glass and everything. So this is also a very good example for having a 3D form easily kind of standardized, less customized, so pretty good. Excuse me. Sorry. So just to conclude and summarize it, involve the facade specialist as early as possible, really sit together with all the experts, architects, developers, fabricators, what is possible, and what is a suitable system, what we need to optimize. Write a very good and detailed specification for all the materials, also including the facade systems. And if it's a 3D system, you really have to allow for more descriptions of the facade, and then also for the budgeting, it's a bit higher pricing and everything. So it can't be done with a normal local system. Use the right facade system, really suitable. Have studies at the beginning and see if all the different surfaces come together. There's no gaps and everything. So yeah, like I said, really select wisely the complexity on the facade and look at it. And then also with some more innovations and little features and tools really can help to have a smooth progress on the project from the beginning until the end. So to round up as well, and also for Schüco, challenge us. I mean, we can do it. It's we have a strong engineering team in Singapore, John built up, and also with the help of our really stronger engineering system in Germany, we can. I'm pretty sure we can come up with a very good solution where everybody only can win, and we'll bring the project to a certain success. Yeah, please contact me, drop me an email. Also, Oliver's team in Bangkok, please try us and contact us. Yeah, thank you very much for your attention, and take care, stay safe. Thank you very much for your attention, and hope to see you all soon. Bye. See you.
Ladies and gentlemen, we hope you enjoy the presentation by Mr. Schleusener, and we have extended thank you to him already. หวังว่าทุกท่านนะคะก็ได้ประโยชน์อย่างมากนะคะจาก presentation ที่ผ่านมาค่ะสำหรับ speaker คนถัดไปนะคะถือว่าเป็นท่านที่พิเศษมากเพราะว่าเดินทางมาจากกรุงลอนดอนมาที่นี่เพื่อเป็น keynote speaker ของเราโดยเฉพาะเลยค่ะ Coming up next is someone very special. So it is our keynote speaker who has traveled all the way from London to here today just for our conference. So ladies and gentlemen, let's give a very warm welcome to Senior Partner, Foster and Partners, Mr. Toby Blunt.
Thank you. Good afternoon. I'm an architect, and I've worked in this region for quite a number of years, and what really interests me is how to design climate responsive buildings. And I think today what I'd like to share with you is the work we did for a building in in Ho Chi Minh City in Vietnam, which we call the self-shaded workplace. And I'd like to just take you through the design process and hopefully share some of the thinking that went on there. You get to see the Swiss Re Tower again. But our client, we worked with the client on their headquarters building. It's a bank headquarters building in Hanoi. I always get the two muddled up. And then they wanted us to, once the success of that building, they wanted us then to lead the design for their new headquarters in Ho Chi Minh City in the south. And the reason the Swiss Re Tower is up there is because they wanted the building to be iconic. They wanted it to stand out, and they wanted it to be special. And that was one very good reason for using us. But I think the second reason really was how could we create something that would be iconic, but it would also work as a building and would create a better environment for those people who would be working within the building. And I think really this is where the facade system and the ideas we had for the facade became critical in the look and feel of the building and also how it worked internally. The site sits in the sort of heart of District 1 in Ho Chi Minh City, a very nice district, next to an existing building, the Sofitel Hotel. And this was the site we first went to see in 2018, before the work started. What we tend to do is it's a very much a design, an integrated design process that we try and do. Some of the speakers earlier were speaking about integrated design, and we work very much in that way in London within our own team, but also very importantly working with the client through a process of workshops and presentations and discussions, a very close relationship. And as I said, we already were working with them, so we knew them very well, and we kind of understood them, and we also understood the operation of the bank, which was also very, very important. So through that process, we kind of deliberated, we discussed, we talked about the form and the mass of the building, how in this particular instance the bank were going to use the lower section of the building, which is here, and then they were going to sublease the upper section to another tenant. And so the ideas about how we could create the split between the two tenancies and also where we'd put the amenity spaces, breakout spaces, very important I think for the modern workplace. there's a lot of discussions about hybrid working and so on, but before all that, there was a big discussion about creating a flexible workspace, making sure people aren't just locked into their desks, they've got opportunities to work in different environments and different places. I went through a process of different options, design options, different massing studies. You can see here a number of options. I think ultimately this tower was the one that we eventually went on to develop the design for. But these were presentations with the client, just showing them how we'd analyze different types of options. It's an 18-story tower, so it's not that big, and actually sits very comfortably in the scale of the street that we were in, adjacent to the hotel building on the side there. So this was really the form of the building, and I show you this now because what I want to do is kind of say, this is a very interesting, unusual shaped building, but a lot of what it drives it is the facade system, and as I said at the outset, the idea that the building is self-shading, and I just want to show you how we've used the facade to really deliver on that promise of providing a self-shaded building. So the first thing we do is really think about engineering and science. We're architects, but we aren't engineers, so we need to talk to people who understand a little bit more about the science of buildings. And in this climate, in this place, obviously solar gain, heat, sun is really a big factor in any building. And obviously being sustainable, we want to think about how can we reduce the impact of that heat on the building and reduce the amount of energy that building needs to keep the occupants cool. So these are studies that were done looking at sun exposure. So this is looking at the southern facades and the northern facades and looking at the amount of sun hours they get throughout a given year. And you can see it's quite extensive. So we're up in the kind of 4 to 5 hour range, getting up to about 8 hours in some parts of the year. The bottom left here, the only facade that really doesn't suffer so much from that is the facade closest to the adjacent hotel buildings. And actually very early on in the process, because of that adjacency, we'd actually made a very early decision to locate the core of the building on the side. And that was, again, a unique thing because a lot of buildings take a central core with the accommodation around that. Here, strategically, we wanted to push the core to the side of the adjacent building to limit the amount of overlooking that one would have. And also, we'll talk about it a little bit later, we wanted to introduce atria spaces within the building to give a very open and sort of inclusive workspace, creating sort of innovation opportunities within the workspace. The second thing we wanted to study really was the solar radiation and the amount of heat that actually hits the building facade. Again, studied that through any given year throughout the different points through the year, so winter through mid-year through to the summer months. Again, you can see here, this is global radiation, so that takes on every form of radiation, whether it's reflected radiation, whether it's coming from a diffuse sky. And if you split that out, direct radiation is obviously direct sun heat that comes onto the building, and then the diffuse radiation. And I think from this, you can see from the colors that actually the diffuse radiation, which is not unexpected in this climate, where you may have a lot of periods of time where it's not just clear blue skies, but there's quite a lot of light because of the overcast sky and the nature of the climate here. So we weren't surprised to see that the biggest challenge for the facade would how do we deal with the diffuse radiation, reduce that glare that comes into the building. The orientation of the site, it's sort of angled, so it's sort of northeast, southwest, and so therefore when the sun passes over the building, it has pretty much an impact on, throughout the year. Pretty much all of the facades will have an impact from that solar exposure. And these little videos really are quite interesting. So this, if you imagine you're the sun, so you're a ray of light coming from the sun, and this is what you see as you pass over the top of the building. And what we were trying to do here is reduce the amount of the blue areas of the glazing and truly using a facade system that would restrict the sun from actually hitting the glass itself. And we did that by introducing this sawtooth facade edge. And you saw that probably on the image earlier on. So it's a sort of angled facade. One element is the shading device, and the other element is a glass device. Now, both those sawtooths, as you'll see in a minute, have glass in them, but one has the shading and one is clear. And what that actually did, by limiting the amount of direct solar onto the glass, we're actually able to reduce the performance capabilities of that clear piece of glass. So, for example, traditionally in a glass facade, you would have high performance glass in this climate. You'd have to deal with glare. You'd have to deal with heat gain. So by turning that piece of glass away from any direct sun, we can actually just use a pretty straightforward, simple piece of glass. So that was kind of interesting. You get a very clear piece of glass as well. So I'll take you through, there's 4 different facade systems in the building. The one I'm sort of most going to talk about is obviously the sawtooth, because that's the one that really drives the principle of the self-shaded facade. So if I go through, you can see here on the plan here, you can see this sawtooth that I was talking about. So this is the element that gets shaded, and this is the clear glass. The other important factor was that we have to introduce a horizontal shading element as well. So it's a combination of angled shading in this direction, which deals with the angled sun coming in, and then the horizontal shading, which will deal with the direct sunlight coming from above. And it was really a combination of those factors. So it's not actually very straightforward. It might look straightforward. It's actually quite a complex number of elements that come together to create this effect. Again, here you start to see the complexity of the system that we were developing. The other thing that really interested us was tradition and being in this place, being in this culture in Vietnam. We're very interested in looking back and understanding a little bit about the sort of handcrafts that you find there. And could we somehow be inspired by that and do something that was interesting that related to that? And so some of these images are some of the research that we did, just looking at the sort of weave patterns and so on, and thinking about, could we get sort of more of a crafted feel into the building? So in terms of the shading element itself, we wanted to go for, we sort of ended up deciding that a mesh system, a metal mesh system, would be probably the most appropriate way to go. And it had those references to those weaving patterns that we just saw. The real challenge then was, how dense do we make that mesh? So we tested a kind of a system of sorry, if I can go back one. Yeah, so we tested a system of a single mesh. The feeling was we wanted to get, and I think through some more in-depth analysis, we wanted to get about 49 to 53% light transmission through the mesh. And the reason we wanted that was because we wanted people to be able to see out, so it wasn't obstructing the view. And I think one of the earlier speakers was talking about how your eye reacts to a screen in front of it, and actually it's relatively straightforward to look through that. And also to get some light in. Well, we didn't want to restrict absolute light into the workplace. We wanted to make sure that we achieved a good quality of light within the floor plate, so people can work in there very comfortably. They don't have to use artificial light. So we started with a single mesh idea, but we found that trying to get to those limitations that we'd set ourselves, it became a very dense mesh. And I'll show you in a minute how we tested that to demonstrate why that didn't work. And ultimately you ended up in a two-mesh scenario. So we had a much more open mesh in a double configuration. And this is a very simple assessment of what we did, but actually it was an awful lot of testing and study that we did until we got to the point where we kind of knew what the mesh configuration and the density of those meshes were. So really this 3D just sort of explains the key principles. So we have the clear glass in this location with good views out towards the city, so people can look out very clearly. We have the slightly more shaded elements here with the double skin that allows, cuts out a lot of the glare, but also allows daylight in, and then allows the people inside the building also to be able to look out. And as I said earlier, also the introduction of that horizontal fin that gives us that additional shading. So as I said, we'll talk a little bit about the sort of the science behind how we managed to get to that mesh solution. And really this was testing the radiation onto, so it's a modeled study that was done. So it's a theoretical study to a certain extent, but using the parameters and the data that we had available to us. And we wanted to test the different systems. So the benchmark, if you like, was to create a solid shading element. So that we knew if you put a solid, absolutely nothing, no light could come through it, that would be an ideal scenario. But that would give you this cold blue color. In these models, we don't have the horizontal, so please don't ask me why all the glass is brightly colored. It's just because we don't have that horizontal in there. So then we wanted to test the first one, which was actually the M33, which is the much more denser mesh. And I think, again, these are sort of, that's an annual assessment of the exposure. Then it's broken down into those 3 key points throughout the year. And you can see on this lower one, it really felt that it was too dense. It was not enough light was getting through it for what we were trying to achieve. So the double mesh system that we were testing up here, you can start to see some light does pass through, and ultimately at the bottom down there, and that was the one that we ultimately went for. We felt it was a good balance between allowing light in and keeping some of that bad light out. Again, this is a number of meshes that we pulled together. We spoke to suppliers. We looked at what was available. We looked at particularly at what was available in Vietnam. Believe it or not, there's quite a lot of these metal meshes made there, so, and quite a range of different styles and patterns. The other key consideration for us was performance of the mesh, making sure that it actually withstood the wind pressures that we would get on the building. And ultimately, we didn't want movement or anything like that. We wanted it to be a rigid mesh system. And ultimately, we ended up looking at the sort of mesh systems with a reinforcement type rod that was actually within the mesh itself. So it was more on the meshes on the right-hand side that we ultimately ended up with. So once those sort of key decisions had been made, what we wanted to do was test them and make sure that we were all very comfortable with them. And we went through the typical process of mock-ups and prototypes. And actually the first mock-up was something we built ourselves in the studio in London with the mesh. We just sort of took that outside. We started to look at it just to get a feel and felt, is it is it working? Is it doing what we wanted it to do? And then we moved on to actually in Vietnam with our client looking at a much larger scale mock-up or prototype where we could, and this was a very early sort of study where we could start to understand the complexities that we were dealing with, the numbers of issues that you have to think about. And this isn't how it's going to be in the final configuration, but we were just testing different things and looking at different ideas with our client as well, just to make sure they understood what we were doing, because it's quite unique in a sense, and we want to make sure they were comfortable with the ideas that we were producing. And here you can see sort of from the inside looking out, and then again just a little bit more of a close-up detail. A lot of work done in the locking system, in the hinges. These are sort of videos that you'll start to see, which we were testing. You know, this is the view looking from the inside. This is the clear glass panel. So again, I think the camera's slightly misleading when you're actually there looking through it. It's less obtrusive. And then we have the different panels, the flat panel and the curved panels, and we need to think about access and maintenance and cleaning and how these panels will be hinged and dealt with. So jumping on to sort of, I think this was about last year, of course, everybody was interrupted with the pandemic, and so we didn't actually see the building on site until this was the first time we went, sometime during, just after the pandemic, and we were allowed to go in. And it was great to see, and you can see here the sawtooth edges of the facade, and it's really quite an interesting looking building in the way in which that articulation really adds something quite interesting to it. And it was really great just to suddenly see, some of the facade glass actually going on the building. And on the right here, you'll see in a minute, I'll talk about these spaces, which are really part of the interior coming out, and the reason we didn't put the self-shading elements on that atria. And again, just in a little bit more detail, this is a more recent photograph showing the actual installation now starting of the shading elements, and with the total facade system, well, not all of it, but the majority of that glaze system already in place. Still covered with protection at the moment. Hopefully when that protection comes off, it will look a lot neater than it does. So as I say, I just wanted to touch a little bit on the second facade system, which is the element in the atria here. And you can see that this is quite a recent photograph. This is unclad at the moment, but a really dramatic sort of form on this edge here, which opens the building out. and I'll show you in a minute what that means. So I said at the beginning, one of the things the client was very interested in, and we were interested in, was how do we create the best workplace for their staff. And the building on the left is some of you may know, is the Hong Kong Shanghai Bank in Hong Kong, which was done, late 80s, but actually inspired our client a lot because it's about the workplace, about visibility across the floor plate, seeing other people work, creativity. So we really find that works very well. A number of our buildings we've done, and that really works well. And so we wanted to introduce the atria into this building. So we were able to produce these areas here that you can see, and also for the tenanted spaces on the very top, which creates a U-formed floor plate. So that you can see on this image where the window wall is with the shading elements in, and then this opens out, so it becomes much more about the atria spaces as opposed to the direct working places. This is the building a couple of weeks ago where you can start to see that space and that U-form. If you turn behind you, you would see the circulation space. Again, that was something we're very keen on, creating very obvious visual connections between the floors so people aren't always going in and using lifts. If they want to go up one floor, they don't go and wait for a lift. They just get onto this staircase and walk up, and that's the reason why it was brought out into the atria to create that dynamic circulation space. This is predominantly a steel welded bolted steel frame that supports the facade system. Obviously it has to do quite a lot of work. It's a big sheet of glass. And then it just gets a cladding system, so it's an aluminium profiled cladding system, relatively straightforward, but just a very dynamic and interesting shape. The core then, as I said, the core is pushed up against the hotel, and again another unique feature of the core, and I'll talk about that separately, is this glazed element here, which is actually the lift core. So in these cores, we have your typical escape stairs, you have MEP rooms, your toilet facilities tucked into these areas at the back here. And then I'll talk about this separately, where you've got the lift shut, the main circulation lifts that come up and down the building in more detail there. But you can see from this diagram, and actually slightly misleading because in fact we would get a better quality of light through here. This diagram doesn't take into consideration that we've got a glazed line through there. But you can see from this analysis we're getting a very good quality of daylight, even with the shading elements in place. And we have good views out as well. So in terms of the working environment, it was a great working environment. With the core cladding, although it's solid, there are some spaces within that, particularly the toilet facilities which need natural light, or we felt needed natural light, which was why they were pushed to the outside. Again, we wanted to take some of the lessons we'd learned in terms of patterning, those mesh patterns. We wanted to carry that theme through, even with the solid core cladding. So this is embossed onto aluminium sheet. So if you look at it very closely, it has a texture to it. And we've been testing this recently, and it's coming out very nicely it's just not a flat panel. It's got some catches the light and is really quite interesting. And then you can see where we then introduce these slot lights. So these are the windows, and this is actually a view from inside the building, inside those toilet facilities, where you can get this slots of light that come in there. That you still retain the privacy, but you do have connection to outside and daylight. And I think that worked really well when that was delivered. So the other key factor is what we call the panoramic wall. So this is where, as I say, where we've positioned all the lifts, that the vertical transportation. And we've done that behind, so the access ways are, the lift lobby is in this point here. So this is outside the building here. And then this is inside the building into the atria. The reason we did that was to maintain as much daylight as we possibly could from the outside to the inside on that, typically on your core wall, and limit the amount of solid you've got. So we're almost trying to get as much daylight completely around the building as we possibly could. We learned some lessons from a building we did in Sydney in Australia a few years ago, where we had a side core configuration with glazed lifts, and it was a very similar approach to that. And this is it on site again. This is an image you've seen already, but you can now see through there daylight. So that's our core behind there, and those where all the lifts will be running up and down in this space here, which I think again is unique. So you can see it here. And what that means is that when you stand on this floor plate, the glazing system's not in yet, but you just feel there's plenty of daylight around you. You just feel it's a good environment. It's not a murky sort of submarine environment where the further you move away from the edge of the wall, the deeper the plan, the darker it gets. So actually a very, very good quality working environment with plenty of daylight, but as I've said, it's all very controlled within the floor. And then moving up to the top of the building, this is the tenanted area. So the atria here is slightly smaller than below. But interestingly enough, we've introduced a roof garden at the very top, and that was part of the amenity strategy for the client, making sure that there was enough people who could use different spaces within the building. And so we just coming back to this image here. Sorry, I've done it again. Here, again, we wanted to use this is obviously directly on top of the building, so it will get a lot of sunlight coming down. So we also wanted to use a shading material to protect that. But because it's very much about sun coming right the way down, in this particular instance, the mesh system is on the inside, and we use a much more performance glass on the top there. But it gives a very interesting sort of textured light that comes down through that and floods this atria. Very, very nice, calm light, but also just creates something really interesting. And then that's the external space, which has a restaurant and bar facilities for evening time. And we've introduced the idea of these sliding shading devices. One of the things we've learned working in this climate is also that if you use sort of like a louver system for shading, it really doesn't work as well as a solid piece of shading. So rather than introducing a kind of louvered slots in here, which are permanent, we felt it was probably more appropriate to have a solid system that provides proper shade. It can be translucent to a certain extent. And we wanted it to open and close because I think in the evening time, it's really nice to be outside. However, of course, you have problems with rain and so on, so you have to sometimes close it down so that the space can be used in all sorts of climates. So that was the reason for introducing those elements there. And then that's the building. So hopefully I've given you some insight into how we created this self-shaded workplace. And it's been a really interesting project for me to work on. So thank you for letting me share it with you today. Thank you.
Thank you very much, Mr. Toby Blunt. And I earlier mentioned your name incorrectly. As you might have heard, I said Tony instead of Toby, so please accept my apology for that. So thank you once again for giving your keynote speaker session for us. Ladies and gentlemen, we're about to have a lunch break, but can I request all the speakers from this previous session to stay back first before joining the lunch break? So Mr. David Ang, Mr. Somkiat, Mr. Govila, and Mr. Blunt, please stay back to receive the mementos later, which will be presented later by Mr. Oliver Bernadis. เดี๋ยวอีกสักพักหนึ่งตอนนี้นะคะเราจะมีการเบรกลันช์แล้วนะคะทานอาหารกลางวันกัน35 นาทีนะคะ We're going to have a 35 minutes lunch break. It's shortened just a little bit because we are running a bit behind today. We will see you back here 35 minutes away from now. I'm very bad at math. I think that would be about 2:25 if I calculate that correctly. So ladies and gentlemen, please enjoy your lunch break. Also, please don't forget to network with each other. Get your parking stamped as well. And we will see you back here at 2:25. ขอเรียนเชิญทุกท่านรับประทานอาหารกลางวันนะคะอย่าลืมสแตมป์บัตรจอดรถนะคะแล้วก็เน็ตเวิร์กนะคะพูดคุยกันด้วยค่ะขอบคุณค่ะ As for the parking tickets, only the red parking tickets can be stamped, not the blue ones. บัตรจอดรถนะคะสีแดงเท่านั้นที่สแตมป์ได้นะคะสีฟ้าสแตมป์ไม่ได้ค่ะ Alright, I would like to invite the speakers from the previous sessions to come and receive mementos on stage one by one. and also join us for the photo opportunity as well. Thank you. Sawadee. Hello again, ladies and gentlemen, and welcome back to our afternoon session. So I hope that everyone had a very enjoyable lunch where you taste some authentic Thai food and you got a chance to visit the sponsor booth and network with each other, stretch your legs and get some fresh air. So let's start right away with our next speaker. เดี๋ยวเรามาเริ่มกันต่อเลยนะคะหวังว่าทุกท่านนะคะก็รับประทานอาหารกันอิ่มแล้วนะคะแล้วก็พร้อมที่จะนั่งร่วมประชุมต่อในบ่ายนี้ค่ะ All right, ladies and gentlemen, please join me in welcoming to the stage our speaker for this session, Mr. Phaithaya Banchakitikun, founder Atom Design.
Okay. Good afternoon, everybody. My session seemed to be the most difficult for today because it's after lunch. So every time it's after lunch, everybody mostly sleepy, right? Thank you for the team for having me today, and thank you for all sponsors today. I have another meeting at 3 p.m., so I need to start quickly. So maybe I just move further on. Okay, my name is Phaithaya Banchakitikun. I have 22 years in the design industry. Start working as any other architect student. I have a chance to having some experience in US for quite a short period of times, doing some lighting design because after graduate is the Asian economic crisis for 1997. So I have to work in another relevant career instead of being an architect at that time. And then I will join, I have a chance to join with Architect 49, one of the most biggest firm and longest firm in Thailand as well for 18 years. After I resigned from A49, my last position is a partner in A49. And I found my company since 2011. So I have a short period of time that working for two companies overlapping with each other separately for the client account, definitely. For right now, for the years of 22 to 24, I have a chance to be in the position of the Vice President of ASAR, which is the Association of Siamese Architects of Thailand. And for the Thai BIM Association, try to develop the way to implement BIM technologies to the industry as much as possible. So please allow me for a first few minutes to give you some background of what I have done. Oh, the clicker doesn't work. I think I pressed the right button. Which one? Nope. Okay, please help. Okay, I can just place this myself. Nope, nothing happened. All right. So as any other architect, since at the beginning, we need to start working in small scale projects, start from house. Oh, is it not mine? Okay, start from house design, some bigger development from time to time until the, okay, very good, thank you so much. All right, so these are some of the houses that I have worked with. Some master planning that we need to study together with the team as well. Office building, some residential condominiums. Residential development would be one of the most construction area for the past 8 years before COVID. And most of the project will be high-rise in Bangkok. Some of this building you might pass along when you drive the cars in the cities. Okay, this. Then as being an architect, so we try the best, and our top priority in the criteria for all the project that we try to develop is try to make the sustainability concern and the well-being for all project that we have developed so far. One thing that we maybe need to frankly speak is about the limitation of the construction, especially for the budget in Thailand industry. So we need to work with all those limitations, the regulation that as any country, and the practicality into the construction because of the construction development in Thailand business is not that advanced as what we expect in and what we see in many other countries. So, okay, some housings. And we also doing some charity work. For example, that may be the for the communities. And this one is the lately for the past 3 years, some project that we work with some, maybe I cannot say client, maybe just the owner or developers, because we don't receive any design fee at all for some community housing for some doesn't have for some people who doesn't have the quite a good opportunity in developing their own housing or their own house. So we help some organization that helping them in developing their housing. I will have some project for you today as well. And this one lately not only doesn't have the design fee, sometimes we need to pay for the construction as well. So this one is one of them that we designed, and we pay for the construction and donate for some communities. So if some of you in this hall having this kind of project, please feel free to contact me, because I can serve with you for free. And definitely for the owner or developer who have the project with the design fee, I would be more loving you so much to contact me. All right. So sustainability and the well-being. Before I get into the project that I try to explain more in detail today, I will give you some background what we have developed so far. As being an architect, I think it seemed to me like our duties to develop the built environment for a better well-being and also the more sustainable for the global concerns. And UN SDG always the thing that we try to refer to as much as possible as we can, with all limitation of the construction. And well and lead. I would say that maybe 90% of my project that I have the opportunity to work with the client, firstly, I try to propose them somehow, try to make the project more sustainable as what we can do. And lead and well, I would say that 90% of what we propose is cannot be able to apply this list and well certification because of the cost limitation. But we try the best to follow some principle of the sustainability and well-being issues. All this. I think all this diagram, I think you know it very well. And also some of the standard that we also try to refer to as well. This one is gross national happiness initiated by Bhutan and recognized by UN and all countries as well. How to develop the city to be to make the people more happy. So this kind of thing, basically, if we just need to say one word, what it needs to be done in the project to give better happiness for the cities, I would say that maybe part of it would be the green area. And for the past 10 years that we have developed so far, we try the best to improve and increase the area for the green area, because I think the benefit of the green area, everybody in this hall would be knowing it very well, how it benefits to the people life and also the natures. And our Bangkok cities, because I mostly work in Bangkok cities, our green area per capita is about only 6.4 square meter per person. And the international standard by WHO is about 9 square meter per person. So it's just a little bit less than what we should have. And apart from the areas, there are also the issues about the distance between the place or the district or the residential or any building or any part of the cities. There will be some issue about the distance from the green area or the public park to the area that the people live. And in Thailand, it's quite a little bit, in Bangkok, it's quite a little bit far from what we expect. If we're talking about the 15-minute walk communities, 4.5 kilometers would be too long, because it takes about 1 hour for walking to the cities, to the public green area. So what we have tried the best, we try to increase what we develop in all the project, try to increase the number of the green area for some sample that we show here. We have the EIA, the environmental impact assessment that we need to comply. So what we try to use it as a benchmark, we not only to comply the green area that is required by the project and the number of the citizens or the resident in the project, we try the best to maximize the green area more than what is required in the regulation. So what we have here for this sample is about 300% more than what it required in the regulation. And we developed the communities because we believe that having the quality green area in all the residential space, it would be the most appropriate and suitable and comfortable for the people to live in. And this kind of thing, this kind of facility helped a lot during the pandemic period of times because we cannot use the indoor facilities. So outdoor facility would be more safe in terms of the pandemic and some of this project. So even not only the luxury project qualities, some of the affordable housing with the affordable price, we also try to improve the quality of the green space for all the projects that we have developed so far. And some that we have very limited area, about maybe 1,600 square meter footprint of the land area, we try to use and place the tree vertically on all the balconies. So each unit would have their own green space. And this came out really well. This is one of the projects that we have developed as well. We have the high-rise building, and normally we would have the parking podium. So how could we make the solid parking podium to be more lively for the cities and make the city more clean? Because we have the really limited pedestrian area for all the road in Bangkok. So what we can do, we can somehow, working together with the client, try to open the fence, not to have the blocking fence to the public space, and allow the people who walking around or driving around can be able to see the tree or the parking or the park space inside the properties. And this one we developed the parking podium, which is about 6-story height, to be the clean area. And it come out very well, and it would be one of the very nice view for the Lama 4 road when you drive by Samyan area to Snalune area. And we have tried to develop how could we implement the green space in the building quite a lot. And we would say that we fail a lot as well. So this project is one of the first that we start to have quite a proper soil volume for growing the tree on the buildings, which is basically about deeper than 2 meters. And with the soil volume of deeper than 2 meters, all the trees can be growing very well, and with the proper maintenance to the green area as well. So this is one of the projects that even the project that we do for the some lower income communities, we try the best to maximize the green space for them as well. And we're working very closely with the communities to find a way to make all the people having the same house area for their own and manage the space that can be left empty for the open space and the green area. So, and during the pandemic and the concern about the COVID-19 solution, we have worked together with some developers, try the best to implement what we call is COVID-19 solution for all the building that we have. Because during the year of 2020, my team have more than 20 projects that need to be transferred at that years. So it's the most critical period of time to try to make the building feel safer for the people who going to adopt the unit or transfer the unit to live in. So this kind of thing we have developed together with the developer as well. So come to what we talk today, the air qualities. We will say that indoor air quality is the most one of the most crucial issue for the built environment, because sometimes because people normally take about 90% of their time indoors, and for the air qualities, indoor pollution can be somehow twice or 5 times higher than the outside of the building. So how could we improve the air quality in the building while try to comply all the limitation of the project context as well, the regulation, the practicality of construction, and also the budget. So good ventilation is one of the key issues to make the building having the natural ventilation or some mechanical ventilation system to flow the air inside to outside and also outside to inside. So this is a project that we will talk more today. Its name is IDOQ Victories, located very close to the Victory Monument. For this project, we have, for the Victory Monument, we have the regulation restriction area that we cannot build the high-rise building for the private properties in 300 meters radius from the monument. So our site located just right there.
the closest and at the 300-meter line like that. So we developed this building, and we would say that developing the residential project in Bangkok and in Thailand, the view to outside is the most the top priorities for the people who buy the unit. So in this particular location, we consider that the Victory Monument would be the most preferable view of the project. So the way that we have developed the building, we definitely do some study, and it's come up with quite an interesting shape of the building plan. This is the line that we have for the 300 meters, that we cannot build anything further from that line. So we have the limit to that line. So we try to maximize the building perimeters, try to maximize the building perimeter that facing to the Victory Monument as much as possible. And on the right-hand side of this slide is the 50-meter height building, which is the shopping mall solid building block about 50 meter high. So we locate the core of the building at that location, and we try to maximize the rest of the area to be the unit as much as possible. So we maximize the perimeter on the Victory Monument site. And with the setback issues that we happen to comply all the project with that. Some influence in terms of the organic line. Maybe I will have some video clip a little bit. Maybe if possible, could you reduce the sound a little bit? Thank you so much. So when we start the project, what I personally worry quite a lot is about how could we place this building in the skyline, in the same skyline with the Victory Monument, and try not to make this area unpreferable into the city views. So we come up with the solution of having the building and try to clean up all the decoration outside the buildings, okay, to simplify the building itself. And we use the darker tone color to the building to make it as simple as possible for the view that we would see this building together with the Victory Monument, and allow just only having the building mass carving from what it had been limited, something like the regulation, the way that we maximize the view outside. All this come up with this quite an interesting shape building mass. Okay, further for that. And this is the overall pictures of the buildings. So the building is quite simple. It's about 30,000 square meters GFA. And we have the 100% automatic parking system, which is one of the first buildings that apply the automatic parking system for full 100% into the project. And it is about 40-story height, and it's a podium block. So the podium area is, in fact, is the block for the automatic parking system. We try to carve the building somehow to create some interesting skyline at the lower part of the pedestrian. And this is located really closely to the BTS station. So the ground floor level will be so limited. We have the really limited area for the lobby, but it's just only it would be serving as the arrival space and the area for some reception stuff. And this is the entrance of the buildings. We try to hide the entry area behind this wall. And this is the entry space, the entry design. That also having the same design language as the buildings. Okay, let's come to one of the key features of this building that also helping the air quality of the building. It's about to have the atrium, because during the development of the building plan, when we try to maximize the building perimeter, what we end up with, we will have the empty space at the center of the buildings. So we cannot utilize them for any other function. So we maintain it empty and create the atrium for making it to be the features and also helping the air quality of the buildings. We'll quickly run through a little bit. So this section diagram of the buildings. So we have about 24 floor height atrium entirely. We split them into two portions. One is the lower atrium, another one is the higher atrium. And each atrium would work separately.
And when we have this kind of the atrium space, what we need to provide in terms of safety, we need to provide the smoke exhaust fan. So the smoke exhaust fan located at the top of each atrium. And this smoke exhaust fan would be the area that we keep it as a void. So we consider that we have the two side void in the buildings. One on the southern side, sorry for that. Okay, I'm not going back. Okay, this is some calculation a little bit. Okay, one on another side, one on the northern side here, another one on the western side there. So with the wind flow direction of the cities, somehow it could create also the stack ventilation that we normally know it really well about. The heat air would flow upward to the higher zone and taking inside the outside air into the buildings. So this kind of the system work better than the general double load corridor buildings, because when we have the double load corridor buildings, the ventilation would come only from the window at the both end of the corridors. So when we have this kind of atrium, it could maximize the flow of the ventilation naturally from outside to inside the buildings. And we have the smoke fan located at the top void, which is the area that would outtake the air or sometimes intake the air and downward to outtake at the lower part of the atrium. And this is the interior view of the atrium. When we look upward to the sky roof there, this is the picture taken from the lower atrium, and that glass floor is the glass floor which separate lower atrium and the higher atrium from each other. And we allow for have some natural light coming down from the top floor of the buildings. And this is the atrium space. And with having the void for getting the natural light at the top part of the building, somehow it could create some dramatic lighting effect into the atrium space itself as well. And this is the section I will get you into detail a little bit here. This area that we consider as the one of the intake air void here. So what we have to concern as well, because as the storm lane as last night, right? Storm lane in Bangkok is so strong. So when we allow to have the intake ventilation into the high-rise building, what we need to control carefully is about how to prevent the rain not to flooding inside the buildings. So we create the vertical facade right there, and we have the operable louver up there. So the air would come here and taking up a little bit and get into the buildings. So this is how we prevent the rain not to flood inside the buildings. So we have done some simulation, and it should be workable in this way. And at the end, when the building start for operation, we have this building complete about 2 years already and pass about 2 rainy seasons. So it's still working very well. Okay. So this is the top part of the atrium. And this is the smoke exhaust fan that sometimes during the time that we have without having the wind outside, we can also using this exhaust fan to operate and take the air inside and outside as well. Okay, and the system of the facade construction in this project, and I think in most of the residential project in Bangkok and in Thailand, we have quite a limit budget in developing the facade design. We are talking about maybe somewhere around less than $200 US per facade square meters, not square feet, square meters. So it's really, really low. So the material that we normally use is about precast concrete and working with the stick wall system. This is how the building built. And this building is the fully precast system. It means that all the structure, column and core produced in the manufacturing factories and then moving it into the site and compose them like a Lego, going up to be the 40-story high building. This is the second tallest fully precast construction high-rise building in Thailand. Another one is my another project of mine as well in the Sukhumvit 36. And the windows that we have located, what we have done in this project, we try to stick out the extrusion details from the solid wall surface. This is to create the depth into the buildings and try to prevent the leakage issue differently. Okay, and this is the view from inside. Quickly run through a little bit. So we have the low wall 60 cm height and the window area up there. And this is the overall of the buildings. Okay, just quickly onto all this. You can see that the difference between floor to another floor at the higher zone, and during the time with the light, the building would express itself differently. And this is the top part of the building. We have the double layers glazing floor here. This is to prevent the heat as well. We collect the heat up there, not allow the heat to coming down to the lower atrium like that. And you will view from down there, looking up. And the top floor is the most preferable location for the facility of all the residential buildings. We have located that as well. The swimming pool is over there, and the facility on the top part. Okay, and this is the exercise room that using the unitized system facade. And this view from the amenity area, the swimming pool areas. Some green space on the top part of the building, swimming pool area. Okay, I think that's all. Hope it's useful for you somehow, and thank you so much.
Thank you very much คุณไพทยาขอขอบคุณคุณไพทยามากนะคะสำหรับ presentation ต่อไปนะคะถ้าดูในโปรแกรมจริงๆแล้วจะต้องถูก present โดย2ท่านนะคะคือคุณโรเบิร์ต เฮมเลอร์แล้วก็คุณโทมัส ฟริตเชอร์นะคะแต่ว่าทั้ง2ท่านวันนี้ไม่สามารถเดินทางมาร่วมงานกับเราที่นี่ได้นะคะแต่ว่าทางเรามีวิดีโอ presentation นะคะโดยคุณโทมัส ฟริตเชอร์เดี๋ยวให้ชมกันค่ะ Ladies and gentlemen, as stated in our program booklet as you have, the next presentation is supposed to be presented by Mr. Robert Himmler, founder and managing director, EGS Plan Bangkok, and also by Mr. Thomas Fritzsche, founder and head of design, TFA, Thomas Fritzsche Architects. Unfortunately, today Mr. Himmler is a little unwell and Mr. Fritzsche is in Shanghai, unable to join due to the current travel restrictions. However, we do have a pre-recorded video for you all. It's going to be a 20 minutes video presentation on the Sustainable Office Tower SOT. So ladies and gentlemen, please enjoy.
Good afternoon, ladies and gentlemen. It is a pleasure for me to have the opportunity to introduce our project, A Sustainable Office Tower, to you today. Unfortunately, I cannot be in Bangkok, so we are using this recorded presentation instead. My name is Thomas Fritzsche. I am the founder and head of design of TFA, Thomas Fritzsche Architects. Sustainability is a matter of course for us. When we look at the global situation, we have climate change, we have a global warming, we have more and more natural disasters. And we have a growing population and increasing urbanization. At the same time, we have lesser resources and higher standards. In Germany, for example, the building industry is responsible for 36% of the energy consumption, for 35% of the CO2 emission, and for 55% of the waste volume. So what we need now is better cities, better buildings, better interior spaces, and better outdoor spaces. We have to apply sustainable guidelines and certification systems. With a certification system, we can raise the value of a building up to 7%, we can raise the rental revenue up to 12%, and the user satisfaction up to 40%. We as architects, we have been working for 34 years. We have designed 185 projects and realized 92 buildings. But we always had problems to convince our clients to do a building in a more sustainable way. So finally, we decided to do a research project And in this research project, we wanted to show what would be possible if you would do a more sustainable office building. Our design was driven by two ideas. We wanted to create an office building of a different typology. We wanted to reflect the contemporary workplace design. And we wanted to create a high-rise building that was sustainable with a healthy and attractive interior. And the project should be ready for the DGNB Platinum certification. So we imagined a plot in Bangkok and designed an office tower of 130-meter height. This office tower consisted of two office parts on the outside of the building and a huge atrium in the middle of the building. And in this atrium, you can see a lot of platforms, a lot of areas where people could come together and could communicate. And you can also see on the left side of the picture a lot of roof gardens that we would create in these office areas. When you come into the building, you have a stunning view into a 130-meter high atrium, which is only 9 meters wide. And from top of the building down to the entrance area, you can see all the platforms with these plants and meeting areas where people of both office parts can come together to meet, to discuss, and so on. And this would be a typical office, an office area over 2 floors with a lot of plants, a lot of natural materials. Our design approach was highly rational. We used form follows function, less is more, or more with less as our guidelines. We wanted to create a building that not only has an outside and an inside. We wanted to create a building with more spatial sensations and relations, a building with more identification, a building that would foster communication among the users, and a building that would connect the green outside with the green inside of the building. So we took an ordinary office block and we cut it into 2 parts. We moved the parts away from each other and created a green atrium. And in this atrium, we arranged a lot of platforms with plants to connect both tower parts. We wanted also to create a building that explains itself. So we placed every function at the best place that it could have. We put the office areas outside. We put the cores, here the yellow areas, next to them, and we put the atrium into the middle. We wanted to create a building that could also adapt to future developments. A building that could be used by a whole company with 57,000 square meters. It could be used by many different companies where each floor has 850 square meters. And it could be used by many small companies with single units of just 90 square meters. An important factor in this project, of course, was natural light and the views. So we wanted to create a building with stunning views from the inside to the outside, and a building where you have natural daylight in any area of the building. And most importantly, we wanted to enable all users of this building to see the atrium and to use the atrium at any given time. To protect our building against overheating, we installed a fixed shading system outside of the building. This shading system is like a curtain in front of the building, and it helps us to keep the building cooler. On the shorter sides of the elevations or of the building, we installed a lot of plants. These plants also help to reduce the heat gain from the sun, but also it helps to increase, to develop or a better microclimate around the building, and it offers, of course, beautiful views from inside of the building. When it's about workplace design, workplace quality, we wanted to create a building with many, many different workplaces. So we created areas of concentration, areas of office work. We created meeting areas in corridors and small areas in between the core. And of course, we created these huge platforms with cafes, with plants and everything to bring people together. So for any kind of work, you would find your specific area to work. And in this way, we believe the building optimizes the workflow, optimizes communication between each other, and also helps workers in this building to relax and to identify with the building. Our green concept should support work, communication, and recreation. It should, of course, influence the microclimate inside and outside the building. So we created a building that has more green space, more green area than the plot itself had before we started our design. We wanted a building with biodiversity. We wanted to use local plants, trees, brushes, and shrubs, and we even wanted to install urban farming on the roof of this building. We also wanted our building to be a part of the city. We wanted to connect our building with the urban fabric and the social surrounding of a building. So our building was planned as an open building. People would be able to go through the first floor of the building and to use all the cafes and little shops which are in this area. We would install photovoltaic systems or elements on the roof of the building and outside the atrium as a shading system and to generate electricity. Our mobility concept would support electric cars, electric bikes. We would offer a lot of bicycle parking lots, and we would offer a shuttle service to the next public transportation hub. As this building is designed in a very simple form, in a very rational way, it is of course a building that could use prefabrication to shorten the construction time, to reach a higher quality, and to lower the costs of construction. We would use as much as possible healthy and certified materials, and we would also try to use reused materials, recycled materials as much as possible. And we would try to use smart technology to optimize the operation of this building, to have lower consumption in this building, to have more efficient audits, and to have the possibility of predictive maintenance in this building. And as mentioned before, the whole concept is ready for a DGNB Platinum or Diamond certification, and our building could be a role model for future developments in Southeast Asia. Our ventilation concept would only work with fresh air and not reuse indoor air. we believe, the best way to avoid the spread of viruses and to guarantee a healthy work environment. We have an energy-efficient, water-based cooling system with chilled ceilings in the offices and floor cooling in the atrium. In this way, we create the highest thermal comfort with reasonable temperatures and humidity and without draft. The temperatures and ventilation could be controlled individually in each room. Our system would be highly cost efficient because we reduce the size of the ducts and shafts, and we could reduce the floor heights. And it would create a significant cut in energy costs because we have an external shading system. Before I introduce the technical aspects of our building in detail, let me introduce EGS Plan, our planning partner in Bangkok, a little bit more to you. EGS Plan is doing energy and sustainability concepts. It is doing building simulation, building commissioning according to LEED, DGNB, and trees. EGS is doing energy audits in existing buildings and green building certifications, also according to LEED, DGNB, and trees. The aim in this project for EGS and for our team was to develop the most sustainable office tower in Southeast Asia by creating a balance between environmental quality, economical quality, and human quality. We developed a climate concept with efficiency in mind. We have a radiant cooling system which is perfect for the comfort of a workplace, with pleasant temperatures, clean air, no draft, no noise, and perfect acoustics. And here you can see how our radiant cooling system looks like. It is very close to the ceiling. It is an open system. It is also helping to reduce the noise in the building. So altogether with this system, we can reduce the floor height of these office spaces. And our system is perfect for a flexible floor plan. We can change office configurations with a minimum effort because we can use this system for open offices, for single offices, and for any kind of office use you can imagine. Compared to an average office tower, our building is using much less energy. Our building is much more energy efficient and much more cost saving. The radiant cooling system helps us to reduce the floor height. So we have a much lesser area for elevation. We have a much more efficient layout of floor plans or a much more efficient building section. We can save up to 570 millimeter compared to an average office high-rise building in floor height. And our radiant cooling system does not require air handling unit rooms, so we could use much more area for offices, and we could have a much higher return because we are not wasting space for these air handling units rooms. Finally, we can deliver a building with a much higher comfort, with a higher revenue, and at the same time with the same building costs as a conventional office building. And this is basically because our concept offers a shading system for the facade, and because we have a highly developed cooling system in our building. At the end, I quickly go through the renderings again, so you finally have an impression of this building again. So I have to thank you very much for your attention. And now Robert will continue and explain the technical aspects of this building. Thank you very much. Goodbye.
Thank you, ladies and gentlemen, for your attention for the presentation. ขอบคุณทุกท่านนะคะที่เข้าร่วมชม presentation ค่ะสำหรับการโปรแกรมต่อไปนะคะก็จะมี speaker 2 ท่านขึ้นมา present พร้อมกันนะคะ For the next presentation, it will be presented to you by 2 speakers altogether. So I'd like to invite onto the stage Mr. David T, Regional Key Account Manager at Zonobel Powder Coatings, and Mr. Chalermpol Jainak, Sales Manager, Architectural Segment at Zonobel Powder Coatings. Ladies and gentlemen, a big round of applause, please. Thank you.
Hi, good afternoon. I would like to say good afternoon to all of you. I'm David T here, and with my colleague, CJ, Thailand Powder Coating Sales Manager. I know after lunch, there's quite difficult for you all to doze off. So I would like to start by telling a story about Nick and Bo. Okay? Nick and Bo enjoy spending time outdoors. They like to go to parks for a walk or riding. Since the ban by the Thailand government on single-use plastic in nature parks, they are made even more aware about the big environmental impact they had made before. The ban was implemented because the bad impact on the wildlife in the nature park. Since then, they are more aware. They are trying to figure out what is the best alternative for the single-use plastic water bottles. Is it the hard plastic bottles, bamboo bottles, or element bottles? At least one thing is very clear. They fully support the ban on single-use plastics because ultimately, the single use of anything is the worst choice you can make. But to understand the real impact, environmental impact, they need to consider the full life cycle of the bottle they use. What are the materials they use to create the bottles? How many times the bottle can be used? Once broken, is it repairable or disposed? How to dispose when the bottle is not in use anymore? You can find the answer to this question by conducting a life cycle analysis. An analysis of life cycle of anything, whether it's a drinking water bottle, shopping bag, a pair of shoes, is very hard. It's very, very hard. But what they are not afraid of challenging it. So, how we do that? We start by understanding and learning. Then we create a transparency, followed by taking action to continuously improve our footprint. Now let's have a look how we do that at AkzoNobel with our Interpon powder coatings. We start with learning and understanding. When looking at the full life cycle, we can split our emission into 3 scopes as defined by the General Reporting Protocol Scope 1 and 2, the emission from our own operations. How much energy we consume and how much emission we emit during the operation. The Scope 3, the emission from our customer and suppliers' operation. When looking at our powder coatings, it is the footprint of our raw material we purchase, such as transportation, as well as the application with our applicators. Recently, ExxonMobil, as a first paint and coating company across the world, has received approval on our science-based target initiative to support Paris Agreement to keep climate rise below the 2.7 Fahrenheit degree pathway of global warming. This means we are committed to reduce our carbon emission across all our full value chain by 50% by 2030. Now that we understand the Scope 1, 2, and 3, let's have a look at how we show this transparency to our customer. We show our transparency on carbon emission with our Environmental Product Declaration, EPD. EPD is independently created and recognized. EPD is valid for all our Interpon D products for our architectural segments and show the environmental impact of our powder coating throughout the life cycle Scope 1, 2, and 3. So it looks from the raw material use till the application and curing. EPD can contribute to achieve points for green buildings, certificates such as LEEDs. We are continuously improve and try to reduce the impact of our operations. How we do that? How we help to reduce carbon footprint? In today, in Thailand market, we have powder ready with no VOC. That means it's solvent-free powder. No waste powder. Powder can be reclaimed due to 100% at overspray. With our new technology, low cure powder, reduction in energy consumption, and increased output. Of course, with the thin film technology, we try to reduce the consumption of per meter square. We also look into the product selection, epoxy polyester, or polyester. In our innovation pipeline for tomorrow, we have next generation of low cure powders to reduce even more energy consumption. We have bio-based and recycled materials to reduce the waste. And of course, we will support customers on their circular transition journey. But the most sustainable thing is keep using it. Therefore, Interpon D offer the best class warranties in the industry to ensure the longevity of the product. Now, I will hand over to my colleague CJ to share with you our some exclusive super and hyper durable collection, so you can design building that lasts. And thank you.
สวัสดีครับก็ผมเฉลิมพลใจนันท์นะครับเป็นเซลล์แมเนเจอร์ของ Interpon Powder Coating Thailand นะครับก็วันนี้จะมาแนะนำตัว collection 10 ของสี Powder Coating นะครับที่กำลัง famous อยู่ในปัจจุบันนะครับก็ขออนุญาตพรีเซนต์เป็นภาษาไทยแล้วกันนะครับก็ขออนุญาตจะก่อนเริ่มต้นขออนุญาตรีแคปจากสิ่งที่ทางคุณเดวิดพูดนะครับก็AkzoNobelเราเนี่ยเรามีสีสำหรับงานฟาซาดงานอาร์คิเทคเนี่ยอยู่3คลาสนะครับก็คลาสแรกก็จะเป็นInterpon D 1036นะครับคลาสที่2ก็จะเป็นInterpon D 2525 2525นะครับส่วนคลาสที่3เนี่ยก็จะเป็นInterpon D 3020นะครับซึ่ง3คลาสเนี่ยตัวInterpon D 1036เนี่ยก็จะ comply กับตัว AMA 26003 หรือ AMA 203นะครับส่วนInterpon D 2525เนี่ยก็จะ comply กับตัว AMA 2004นะครับส่วนตัวInterpon D 3020เนี่ยก็จะ comply กับตัว AMA 2605นะครับก็จะให้วารันตีที่แตกต่างกันนะครับก็แล้วแต่ว่าทางดีไซเนอร์เนี่ยต้องการ performance ของตัว coating สำหรับงานฟาสาดแล้วก็ Window and Door เนี่ยระดับไหนนะครับก็ส่วนตัวคอลเลกชันที่ผมจะมาแนะนำในวันนี้นะครับก็ตัวคอลเลกชันแรกเนี่ยก็คือตัว Futuraคอลเลกชันนะครับตัว Futuraคอลเลกชันเนี่ยก็จะเป็นคอลเลกชันที่มีประวัติค่อนข้างยาวนานนะครับในอักโซโนเบลเราเริ่มคอลเลกชันนี้ตั้งแต่ปี 1991 นะครับแล้วก็เรามีการรีวิวทุกๆ 4 ปีโดยที่เราจะมีตัวรีเสิร์ชนะครับตัวรีเสิร์ชตัวทีมนักวิจัยนะครับที่ก็จะศึกษาเทรนด์ของโลกในเวลานั้นๆนะครับว่าโลกในเวลานั้นเนี่ยเทรนด์เนี่ยมันเป็นแบบไหนแล้วก็มันมีอิทธิพลต่อการออกแบบสีของผู้ออกแบบยังไงนะครับแล้วก็จะมารวบรวมข้อมูลก็จะมีการกำหนดเฉดสีว่าเฉดสีไหนเนี่ยเราจะเอาเข้ามาอยู่ในแคตตาล็อกแล้วก็เฉดสีไหนเนี่ยเราจะมูฟออกไปจากคัลเลอร์การ์ดนะครับสำหรับตัวคอลเลคชันปัจจุบันนะครับก็เป็นเจเนอเรชันที่8นะครับก็มีทั้งหมดด้วยกันเนี่ยอยู่3ธีมเฉดสีนะครับธีมแรกเนี่ยก็จะเป็นธีมที่ชื่อว่า Merging World นะครับก็จะเป็นธีมที่ลักษณะของเฉดสีเนี่ยให้เฉดสีที่มีความรู้สึกเป็นการคอนเนคกันระหว่างเจเนอเรชันนะครับหรือคอนเนคกันระหว่างโลก2โลกนะครับก็จะให้เฉดสีก็จะเหมาะกับอาคารประเภทอาจจะเป็นประเภทพวกงานสถานศึกษาหรือว่าเป็นอะไรที่เกี่ยวกับการคอนเนคกันระหว่างคน2เจเนอเรชันนะครับส่วนตัวธีมที่2เนี่ยก็จะชื่อว่า Soft Abstraction นะครับก็จะเป็นสีอ่อนหน่อยที่จะให้ Mood and Tone แล้วก็จะสามารถเล่นกับแสงได้ดีนะครับส่วนธีมสุดท้ายเนี่ยก็จะเป็นธีมHealing Nature นะครับก็จากชื่อเนี่ยก็จะเป็นธีมที่จะใช้เหมาะสำหรับการที่ถ้าเราต้องการออกแบบตึกที่ต้องการผสมผสานกันระหว่างตัวธรรมชาติกับตัวโครงสร้างอาคารหรือตัวฟาสาดนะครับก็จะเหมาะสมนะครับส่วนหน้าตาของสีเนี่ยหรือว่าธีมเฉดสีเนี่ยก็อาจจะดูได้จากสแตนหรือจากบูธเราด้านนอกนะครับก็ตัวนี้เป็นแท็กเรคคอร์ดนะครับเป็นตึกตัวอย่างที่มีการเลือกใช้มีการสเปคสีจากคอลเลคชันแรกครับคือฟูท่าคอลเลคชันนะครับสำหรับโปรเจกต์ในประเทศไทยเนี่ยก็มีตัวสีลมสแควร์นะครับที่ใช้สีจากคอลเลคชันนี้นะครับแล้วก็มีตัวสโคปหลังสวนที่ตอนนี้กำลังดำเนินงานก่อสร้างอยู่นะครับส่วนคอลเลคชันถัดไปนะครับก็จะเป็นคอลเลคชันที่เราชื่อว่า Flat Matte นะครับ Interpon D Flat Matte ตัวนี้ก็จะเป็นในโลกยุคปัจจุบันเนี่ยผู้ออกแบบเนี่ยก็มีความต้องการสีที่มีระดับความเงาครับค่อนข้างด้านต่ำมากๆครับก็ทางทีมวิจัยของโซโนเบลเนี่ยก็เลยมีการวิจัยและพัฒนาเนี่ยเพื่อที่จะตอบโจทย์ตรงนั้นนะครับก็ได้มีการออกลอนช์ตัว Product เนี่ยก็ที่ชื่อว่า Flat Matte นะครับก็จะเป็นเฉดสีที่ให้ความเงาเนี่ยค่อนข้างต่ำโดยปกติเนี่ยสีด้านของ powder coating เนี่ยปัจจุบันมันจะอยู่ที่ประมาณ 25-35% นะครับส่วนตัวนี้เราจะ gloss เนี่ยจะอยู่ที่ประมาณ 5-10% นะครับก็จะให้ความด้านแล้วให้ดูความ luxury นะครับก็ตัวนี้เป็นเทคโนโลยีที่เรา transfer มาจากตัวทางออสเตรเลียแล้วก็ทางยุโรปนะครับก็เราก็กำลังอยู่ในขั้นตอนการ trial ของ production นะครับเพื่อที่จะผลิตในโรงงานเราที่สมุทรสาครนะครับก็ตอนนี้เราก็เริ่มที่จะมีการสื่อสารกับทาง architect ถึงตัวซีรีส์นี้นะครับแต่ว่าเราก็ยังไม่มีโปรเจกต์ที่เป็น track record ในเมืองไทยนะครับก็ตัวโปรเจกต์ที่เคยใช้งานแล้วก็เคยแอพพลายในเมืองไทยเนี่ยก็จะเป็น Escala กับตัว Sky City นะครับของออสเตรเลียนะครับส่วนคอลเลคชันที่3นะครับเรามีชื่อว่า Anodic Collection นี้ก็จะเป็นทางเลือกของผู้ออกแบบนะครับในกรณีที่ต้องการเฉดสีเนี่ยที่มีลักษณะเหมือนกับAnodize นะครับแต่ว่าอาจจะมีข้อจำกัดในการใช้งานหรือในการใช้ตัว Anodize จริงๆนะครับก็จะเป็นเฉดสีที่ให้ความใกล้ความรู้สึกใกล้เคียงกับตัว Anodize ครับซึ่งในตัวแคตตาล็อกเนี่ยซึ่งข้อดีของคอลเลคชันเนี้ย เนื่องจากถ้าเกิดงานฟาสาดหรืองานที่เราออกแบบเนี่ยมันมีการใช้วัสดุหลายๆประเภทนะครับเพราะว่าถ้าเป็นโนไดส์เนี่ยโดยส่วนใหญ่มันก็จะสามารถทำได้กับแค่พื้นผิวอลูมิเนียมครับแต่ถ้าเราต้องการงานของเราเนี่ยมันมีวัสดุหลากหลายประเภทอย่างเช่นมีงานเหล็กมีงานอลูมิเนียมมีงานที่เป็นสแตนเลสสตีลเนี่ยอยู่ด้วยแล้วต้องการให้เฉดสีที่มันใกล้เคียงกันเนี่ยก็ถือว่าตัวคอลเลคชันนี้ก็เป็นทางเลือกนะครับก็ในคอลเลคชันนี้ก็จะประกอบด้วย3กลุ่มเฉดสีนะครับก็ที่เราแมทช์มากับตัวโนไดส์ครับก็จะเป็นตัว NA นะครับ Natural Anodized แล้วก็จะมีตัวที่เป็นบรอนซ์มีตัวที่เป็นโกลด์โนไดส์แล้วก็มีตัวที่เป็นแบล็กอโนไดส์ครับซึ่งในแต่ละกลุ่มเฉดสีเนี่ยเราก็จะมีให้เลือกอยู่3ระดับซึ่งมันเกิดจากมุมมองของตัวโนไดส์เนี่ยเพราะว่าการที่ตัวที่เป็นเรียวโนไดส์เนี่ยเวลาเรามองจากมุมต่างๆกันเนี่ยเราก็จะเห็นเฉดสีที่มันต่างกันเพราะฉะนั้นเราก็จะมีการออกแบบใน1เฉดสีเนี่ยจะมีการออกแบบอยู่3ระดับเฉดสีเพื่อให้ทางพวกแบบเนี่ยได้เลือกว่าต้องการเฉดสีในลักษณะไหนในลักษณะเข้มหรือในลักษณะอ่อนนะครับก็รวมทั้งหมดเนี่ยก็จะเป็น12เฉดสีที่อยู่ในคอลเลคชันนี้นะครับก็ส่วนตัวแท็กเรคคอร์ดนะครับตัวที่โปรเจกต์ที่ใช้งานใช้ตัวที่เลือกใช้ตัวสีจากคอลเลคชันโนไดส์เนี่ยก็สำหรับประเทศไทยเนี่ยก็จะมีในเมืองไทยเนี่ยก็จะมีตัว Forestier นะครับในส่วนของ Six Sense Resident นะครับที่เลือกใช้ตัว Steel Bond 2เป็นสีเฉดสีออกสีบรอนซ์นะครับส่วนอีก2โปรเจกต์ก็จะเป็นโปรเจกต์จากอินเดียแล้วก็ออสเตรเลียนะครับที่ใช้ตัวอโนไดส์ให้ลักษณะมันก็จะมีลักษณะความรู้สึกคล้ายๆอโนไดส์ครับแต่เป็น powder coating ครับส่วนคอลเลคชันสุดท้ายนะครับจริงๆก็เราเรียกว่าเป็นตัวเป็นคลาสของสีดีกว่าก็จะเป็นอินเตอร์พร D3020เนี่ยก็ซึ่งมันก็ค่อนข้างจะตอบโจทย์ในเรื่องของ sustainability นะครับเพราะว่ามันให้เซอร์วิสเยียร์ที่ค่อนข้างนานนะครับเราวารันตีให้เนี่ยในเรื่องของฟิล์มเนี่ย30 ปีแล้วก็ในวารันตีในเรื่องของเฉดสีเนี่ย gloss retention เนี่ยอยู่20 ปีนะครับเพราะฉะนั้นมันก็จะเหมาะสำหรับการออกแบบอาคารหรือออกแบบสถานที่ที่เป็นที่ลักษณะที่เป็นแลนด์มาร์คลักษณะที่เป็นโมนูเมนต์ที่เราต้องการให้มันคงสภาพหรือต้องการให้มันลุกมันยังคงสวยงามในระยะเวลาค่อนข้างยาวนานนะครับแล้วก็มันก็จะเป็นตัวเลือกที่ค่อนข้างดีนะครับสำหรับการทดแทนตัว Liquid PVDF ถ้าสมมุติว่าทางผู้ออกแบบอาจจะมีปัญหาเรื่อง sustainability แล้วก็อาจจะต้องการตัว product ที่ทดแทนตัว Liquid PVDF นะครับเพราะว่าด้วยเบสของเรซินที่ใช้ผลิตเนี่ยมันเป็นฟูโรคาร์บอนเหมือนกันแต่มันอาจจะเป็นคนละไทป์นะครับซึ่งมันให้ตัวประสิทธิภาพตัว performance เนี่ยที่ใกล้ที่เทียบเท่ากันเลยระหว่างตัว powder coating กับตัว liquid PVDF นะครับแต่ในส่วนของตัว powder coating เนี่ยมันจะค่อนข้างง่ายต่อการใช้งานนะครับเพราะว่ามันเป็น powder coating สามารถใช้งานเนี่ยเปิดถุงแล้วก็สามารถใช้งานได้เลยครับไม่ต้องมีการ mix ระหว่างพาร์ท A พาร์ท B เพราะมันก็จะค่อนข้างสะดวกต่อการใช้งานก็จะช่วยเพิ่มประสิทธิภาพของลูกค้าครับในการใช้งานเพิ่มประสิทธิภาพเพิ่ม capability ของโรงงานนะครับของรายการผลิตแล้วก็ในส่วนของ waste เนี่ยซึ่งเป็น powder coating เนี่ย waste เนี่ยมันก็ค่อนข้างลิมิตแล้วค่อนข้างจัดการได้ง่ายนะครับสำหรับตึกนี้ก็อันนี้ก็เป็นเราสีตัวนี้เราลอนช์ครั้งแรกเนี่ยเมื่อปี 2004 นะครับตัวนี้ก็เป็นตึกแรกที่เราใช้สีซีรีส์ D3020 นะครับซีรีส์ D3000 ก็จะเป็นตึกRichmond City Hall นะครับอยู่ในเวอร์จิเนียที่ US นะครับก็เราแอพพลายเมื่อปี 2004 ตอนปีนี้ 2022 ก็ผ่านมา18 ปีนะครับก็มันกับโครงสร้างก็ยังคงให้ความสวยงามแล้วก็reflective ของตัว metallic powder coat เนี่ยก็ยังคงสวยงามอยู่นะครับส่วนโปรเจกต์ในเมืองไทยครับที่ใช้สีในซีรีส์ของ D3000 นะครับก็จะมีอยู่นะปัจจุบันก็จะมีอยู่2โปรเจกต์นะครับโปรเจกต์แรกก็จะเป็นตัว M Tower นะครับที่ตั้งอยู่ที่โทษทีนะครับข้อมูลอาจจะผิดพลาดตั้งโปรเจกต์ M Tower ก็จะตั้งอยู่ที่สุขุมวิท 64 นะครับอยู่ปากซอยสุขุมวิท 64ตัวนี้ก็แอพพลายตั้งแต่ปี 2016 นะครับส่วนโปรเจกต์ที่ 2 ที่กำลังดำเนินการก่อสร้างอยู่เนี่ยก็จะเป็นตัว Head Office ของ AOT นะครับตั้งอยู่ที่ดอนเมืองนะครับก็อย่างที่คุณดีวิดพรีเซนต์ไปนะครับก็การเลือกใช้ผลิตภัณฑ์ที่มันสามารถมีอายุการใช้งานที่ยาวนานเนี่ยผมว่ามันก็น่าจะตอบโจทย์เรื่องตัว sustainability นะครับแล้วก็ถ้าเกิดเรามีความจำเป็นต้องใช้ผลิตภัณฑ์อะไรที่มันอาจจะส่งผลกระทบต่อสิ่งแวดล้อมครับเราก็ต้องมั่นใจว่าเราจัดการมันได้ดีนะครับจัดการ waste จัดการมีการ manage มันได้ดีนะครับก็ผมก็ขอจบ presentation แต่เพียงเท่านี้นะครับขอบคุณมากครับ
A big thank you to both Mr. David T. and Mr. Chalermpol Jainak. Next, ladies and gentlemen, I would like to welcome to the stage Senior Technical Engineer Side Rise Installation, Mr. Donel Dippi.
Thank you. Just to understand. Thank you. Hello, everyone. Good afternoon. I know it's after lunch and probably everyone's half asleep, but let's try to stay awake. Quite literally, welcome to the hot topic of today, fire stops for external facades. Side rise, a little bit about side rise before I get into the meat and chunk of the presentation. So we've been in the industry for over 50 years now. We're celebrating our golden jubilee anniversary, actually. And well, we entered the fire stopping industry in 1991. We were the pioneers of cavity barriers, and well, we're still striving to innovate. Facade fire stopping is our bread and butter. That's where most of our, well, industry is in. But we also have some acoustics and thermals products, which I won't be talking about today. So we're not just a product supplier or a system supplier. We also add value to the systems that we supply by providing services free of charge, like installation support, technical support, etc. Well, we started off with just basically UK-centric, and now we are expanding, and we are catering to over 25 countries currently, and we're still growing globally. Okay, so now into the meat of the presentation, where I will talk a little bit about the fundamentals of fire performance. So first, there are two types of fire protection that you need to understand. The first one is active fire protection, which is mostly your detectors, your sprinklers, extinguishers, etc. So these are reactive systems. And aside from this, you also have passive fire protection, which is basically anything that compartmentalizes fire in a room. This could be anything, to be honest, from walls, doors, ceilings, anything that stops fire within a zone. Now, it is important to understand that active and passive fire stops should function together as a system. Yeah? It is not that one is exclusive of the other. What we commonly see is that passive fire protection is ignored or not looked at as much as it should be, as much as active fire systems, for example. And well, this is because some building codes allow exemptions based on active fire systems being present for passive fire stops. This is not how it should be. We are only provided with one opportunity to get passive fire systems right, and that is in the design stage. And if it is not done right, then we are losing out on doing it correctly. Reaction to fire and resistance to fire. So these are the fundamentals that you're going to be hearing a lot about in passive fire protection. And both are important for a performance of any fire stop. So reaction to fire is the natural intrinsic characteristic of a product. Yeah? So it is how it will react when a product is ignited or put into a fire. 13501-1 in EN standard, it's a classification standard which comprises of multiple test standards. It's the primary classification standard present in the world globally at the moment. And the classification ranges from A1, which is non-combustible, all the way down to F, which doesn't have a criteria or classification at all. Sorry, apologies. Yeah. So moving to fire resistance. which is broadly categorized in 13501 Part 2, but there are individual test standards within that for each building type or product type. So this provides classification and integrity and insulation, which is the two main key criteria, which I will talk about in the next coming slides. So like I said, multiple test standards are there for fire classification for one reaction to fire. 13501-1 is the most popular. You also have a couple of other standards like ASTM E84, which is the American standard, which gives flame spread and smoke. AS 1530.1 is the Australian standard for non-combustibility. In resistance to fire, there are multiple test standards. I will talk about a few of them during the course of my presentation, but it's important to know that they're classified in integrity and insulation. So what is integrity and insulation? So the resistance of a product to spread fire from one zone to the other through the system, through joints in the system, or around the system. That is called as integrity, and it's classified as E. The ability of a product to not have the temperature rise on its unexposed surface for more than 180 degrees Celsius plus the ambient is termed as I, or insulation. So there is an additional parameter called structural integrity, which is not important for cavity barriers, so I will not go into that. So what you need to keep in mind is integrity and insulation, and both are important for a system to perform. Stone mineral wool or rock wool. So this is a common component that you see in all types of fire stopping. And this is because, well, this graph that you see in front of you, this is a common temperature curve of a fire resistance test. So in this, I've mentioned a few areas where different building products will melt. For example, at 6 minutes in a fully developed flashover fire, glass fiber or fiberglass will melt. 9 minutes, aluminium, where most of our non-fire rated curtain walling is made out of aluminium structural members of mullions and transoms, will melt. Plate glass melts at 25 minutes. And then fast forward to even 5 hours, and still stone mineral wool is intact. It doesn't melt. Aside from its fire performance, it's also got good dimensional stability, water permeability, repellency, and also long-term thermal resistance properties. So we can also, play around with it, and this is just showing the dimensional stability. This is the flag of Wales, basically, where our company's headquarters is located. So different external types of walls. So the first one that we'll be talking about is curtain walls. And then we'll go into ventilated and non-ventilated facades, which I will cover together. So the first one, for curtain walls, we're going to be talking about glazed facades, where we're going to be talking about the perimeter edge of the floor slab. So the CWFS, or the curtain wall fire stop, is the primary product that side-rise offer as compartmentation between the floor slab and the rear of a facade. So what is important is, it is important to extend the fire performance of the floor slab to the rear of the facade. And that is what we offer as a system. And we've tested it to all the international standards, which I will get into as well. There are obviously other areas in a building where cavity barriers are required, like ceiling voids, raised floor voids. I won't be getting into that today. The types of fire spread in a curtain wall construction. The first one is an internal fire spread, where fire on one floor will spread from the perimeter void to the floor above. Yeah. The second one is called as leapfrog effect, where fire on one floor breaks the window open, spreads through the exterior of the curtain wall, and jumps to the floor above. Two international test standards to test perimeter barriers. EN 1364 Part 4 is the European one, and ASTM E2307 is the American one. Anyone that's familiar with NFPA 285, well, it's the same test trick that is used for an ASTM E2307 test. It's an open chambered furnace where, well, you don't have a pressure that is induced on the specimen. You have two fires, one inside the furnace and one outside, where it simulates a fire breaking out of a window. So the second burner is ignited, if you want to call it, after 5 minutes of the fire commencing. EN 1364 Part 4, it's, I would say, a more stringent test, because it's a closed furnace test where you have a positive pressure of 20 pascals induced at this specific location. So we have done both tests. This is an image of our ASTM E2307 test. So the one on the far right is an image before the test. The center and the left is after the fire test was done. And well, you can see that the curtain wall aluminium has melted away. but the fire stop is still intact. Well, forget the fire stop. Even the paper that is stuck on our curtain wall insulation is still intact. An image of a EN1364 Part 4. So as mentioned, it's a closed furnace pressurized test chamber. And because of the pressurized test, the curtain wall will deflect in and out. The flow slab will also deflect downwards because of the fire and the 3D movement that the aluminium framing will encounter. In a building, it's not necessary that a fire will occur in the first 2 years of the building being constructed. It could be after 10 years, it could be after 15 years. So it is important for whatever is installed between the flow slab and the facade, or the perimeter joint specifically, to take all the building movement and still function in a fire. So that is why we have done a pre-cyclic testing prior to the fire test being commenced. Yeah? So this specific test was done at 500 cycles, where it was moved for 500 cycles at 30 cycles per minute in and out for 10% of the movement. And once this movement cycling is done, the same product and same system is then moved to the furnace and then burnt. So, and this is just to show that, well, we comply with the international regulations. So this is actually an optional test within the standard. It's not a mandatory test, but we want to ensure that we're providing the right system for the application, and that's why SideRise have gone ahead and done it. 3 common systems that are currently present globally for perimeter fire stops. So the first one is an obsolete, and we call it the Generation 1 system. It's the steel plate plus infill system, where you have a steel plate on top with some stone wool that is just packed inside. The next one is the 2-part sealant plus safing system, where we have, well, some sealant on top and, well, some stone wool that is, again, packed below that. Before going into SideRise, I'll talk a little bit more about these two. So when talking about the steel plate plus infill system, this is not a tested solution. Okay? There is absolutely no way that this is going to perform in a fire, because steel is a very good conductor of heat, and it will never pass the insulation criteria. There is also obviously no movement that the curtain wall can induce in this system, because the steel is going to bend. When talking about the 2-part sealant plus safing system, yes, it is a tested solution, but however, the workmanship involved is more, and it is prone to error. The SideRise is a 1-part system, and we have tested it for cyclic movement and for the international test standards. And our orientation of the fibers are already pre-rotated in our factory, so you do not have any human error involved in the installation. Just a comparison between the conventional 2-part or Generation 2 and our SideRise installation. So this is how the 2-part, So this is how the 2-part sealant plus safing system is installed, where you cut stone wool, you rotate the fibers by 90 degrees, you pre-compress them, and then you install them and have sealant applied on top. But even with this system, most of the people change the insulation that it was tested with. All the manufacturers have tested with stone wool from either from Canada or US or Malaysia. But when it comes to the actual project site, they just use any normal rock wool or stone wool, which is there from their local country. Just having the same density of stone wool doesn't ensure that you get the right performance, because it is manufactured to perform for the application. So with SideRise, all those multiple steps are avoided, because for us, our product is already factory controlled, rotated in our factory. So the fibers are already in the vertical orientation, and that's why it can take the movement of the curtain wall. All we have is we have to insert a bracket, take an extra 10% for compression, and fix it with any non-combustible fixing suitable for the substrate. So we comply with all the legal requirements. We have tested to the international standards, are certified through, well, the major certification bodies. I will come to that as well, and have a certification of compliance that is required for a perimeter barrier. Moving on to wall types 2 and 3, which is cavity barriers for external facades. Just some building fires around the world. So the first one on the left is from tower in Istanbul in Poland, where the cladding had entirely burnt off. And, well, 2 and 3, 2 is a fire that happened in Asia Pacific, and 3 is the infamous Address Hotel, which burnt in Dubai in 2015 for the New Year's. So over here you can see that because there was absolutely nothing behind the cladding panel, and the cladding also contributed to the fire just sped up the entire elevation. Right next to the cladding assembly was a curtain wall, which had absolutely no impact of the fire. In the center, you have a fire that started on the ground floor, and you will see how quickly it spreads through the chimney that is behind the cladding, and then the cladding itself eventually, right to the top of the building. It's less than a minute. And on the right is the address hotel again, which the cladding ignited. So locations for cavity barriers in a cladding assembly. So this is documented within approved document B, which is the fire code, which is present in UK. But however, this is not guided by regulations in other countries. That is what we have seen commonly, and it is up to the architect and facade consultant to detail it correctly. So usually the horizontal cavity barriers are on every floor, and verticals are there usually at every 6 meters or 20 meters, depending upon the elevation or the length of the building, and at corners so that fire doesn't spread from one elevation to the next. Cladding assemblies are generally the same type of construction, where you have an external type of cladding, usually ACP, solid aluminium, GRC, precast, etc. And then you have a cavity in which you have, well, depends again, this is based on the regional requirements. You may or may not have thermal insulation for thermal performance like R value, U value requirements. You may or may not have a vapor barrier as well. And finally, but you do need a base wall onto which the cladding assembly is fixed to. You have different test standards for system and also different test standards for the product assemblies as well. So I will get to that in the next few slides. So you have two types of cladding assemblies. One is where the joints are sealed and it's a non-ventilated assembly. And this is where our non-ventilated cavity barriers are used. Basically where the cavity barriers are compressed against the ACP panel or whatever cladding type it is used against. For a ventilated type of cavity barrier, then we have an intumescent strip that is there on the leading edge that is facing the ACP itself. And in a fire scenario, this will expand and close off the gap. So when talking about ventilated cavity barriers, in the dry state, it will allow ventilation, it will allow circulation of air, the moisture and water can all drain out. But in a fire scenario, this intumescent graphite will expand and it will close off the void. So we have tested this system for multiple different types of integrity and insulation performances, because this is not the same as a perimeter barrier where you require the same performance as the flow slab. This varies from regulatory region to regulatory region, and we have different integrity insulation performances. SideRise have done over 250 system tests. We have a large bank of test data where we have done different NFP 825s, 8414s. We have done the Australian ones of AS5113. We have also done the French Lepaire test. And we have a huge test bank. A lot of it is already present on our website. If you do not find any specific information that you're looking for, feel free to contact us and we can assist you with that. So we've got a large test bank, and we feel free to contact us if you require further information. So when a manufacturer decides to manufacture a product or produce a product, so they contact a certification body. So this can be any of the major ones, Intertek, Warrington Fire, UL, anyone you want. And they will guide the manufacturing company on how this product should be tested. They will come and analyze or sample the manufacturing, how it is done. And then they will send this to the test lab for testing. Once the product is tested and the test report is issued, they will provide a certificate of compliance, which states the field of application of the product. And then they do a repeat factory audits to ensure that the same process is recycled and, well, that you're manufacturing the same product. So we have certification with all the major certification bodies. Intertek, UL, Warrington Fire, and IFC are the ones who we have it with currently. This is our UL certificate. As SideRise, we aim to join a project at the very concept stage where, well, like I said, passive fire protection is done in the initial design phases itself. If it is not incorporated, then, well, the project is not done right. And we assist in detailed designing. We ensure that we analyze the project, we understand the scope, and according to the consultant's requirements, we will detail the locations of cavity barriers, where it is required, and provide bespoke solutions. We also have a site services teams that will do a toolkit training for you. We also offer installation support. We have an inspection app through which inspections can be logged on. It's free of charge. It can be downloaded through any Android or Apple Play Store. And finally, we sign off the project with a warranty. So this is basically how our inspection app functions. through which we have a set of questions that are asked. And once this is done, which is answered, well, it's not just enough to answer a set of questions. You have to upload media, and we review. A team from the SideRise technical staff will review the images and the questions that you've answered and approve or not approve the inspection report based on it. This is a view from our office in Dubai, actually, just to show you the projects that we have done just from outside our window. And yeah, so we've done a large part of projects in UAE. This is just in Dubai, where I would say in UAE itself we have a market share of over 70%. Just a project overview where this is a project called Dubai Uptown Tower, which is based in, by DMCC it was developed, where the contractor was from Germany, and we had a facade consultant also from Germany, and the architect was based in US. So the specification for this started in 2015-16, and well, the project is just nearing completion now. So it is important for us to get into the project in the early stages itself to ensure that the project is detailed right. Even though we are focusing only on facade fire stopping, we have a large bank of test information. So this is just, well, all the tests that we have done. We have a lot of experience in the industry, and well, we're growing constantly. And just in time, thank you so much. We are represented in Thailand with our sole distributor G-Cons, who are present locally, and they can help you with any local information. Thank you so much.
Mr. Dippi, thank you very much. I think we can all agree that safety is one of the most important factors when it comes to construction. So thank you very much for your information and presentation. ก็ขอขอบคุณคุณดิปปี้นะคะก็ทุกท่านก็คงจะเห็นด้วยนะคะว่าความปลอดภัยแล้วก็การป้องกันการเกิดอัคคีภัยเนี่ยถือว่าเป็นสิ่งที่สำคัญมากๆเลยนะคะในการก่อสร้างต่างๆเพราะฉะนั้นก็หวังว่าทุกท่านก็ได้ข้อมูลนะคะที่มีประโยชน์ไปค่ะเดี๋ยวเรามี presentation อีก2 presentation ก่อนที่จะเข้าเบรก networking break ช่วงต่อไปนะคะอีกสักครู่ค่ะ Ladies and gentlemen, we have 2 more sessions before we start our next Tea and Coffee Network break. And the next one, the coming up next, is going to be presented by Mr. Jayrold Bautista, Associate Tech Services and Development Scientist, Dow Asia Pacific. Handing over to you.
Hello. There we go. I'm just trying to check if our audio system works. First of all, good afternoon to everyone. Good day. I'm very happy to see familiar faces. I think the pandemic has paused our lives a bit, but now we're going back slowly, and now we have Zak again. I think the last time I was in Bangkok was actually the last edition of Zak, and we were also participated in that, and we're very happy to be a part of today's the Thailand edition again. And today I'll be talking about carbon neutral facades and or carbon neutral silicones for facade specifically. And this is a new concept. I think if I may just ask for some help on the presentation. It's weird. Yeah. I think you can probably use, I have a backup here. I don't know if it's just, yeah, yes. Sorry. Can you try it? It's not. Okay. All right. Perfect. All right. Sorry about that. A little bit of technical difficulties. Probably just close it. No problem. No problem. All right, perfect. It does work this time. All right, thank you very much. Sorry about that. Yeah, so I'll be talking about designing less with a carbon neutral silicone for facades. Now, you know, we in the building industry plays a very big role when it comes to the push for net zero. Buildings consume 40% of the energy. That results to 39% of the global CO2 emissions. Now, if we further break down the 39%, 28% of that comes from operational CO2. Now, there's been a lot of push to reduce the operational CO2. That's why standards, green building rating systems for the past few years, even decades, have all concentrated or at least have focused on how to reduce the operational CO2 of buildings. Better energy efficient HVAC systems and the likes of those kind of initiatives. However, if we really want to push for a true net zero building, we cannot ignore the 11% embodied carbon coming from the materials and process that we do for building construction. Having said that, as Ahmed has stated in the introduction of this presentation, we can see the trends, especially in Europe and in North America, wherein there's a lot of push to reduce embodied carbon. That 11% cannot be ignored. Once you have that in your building, that is locked in. And therefore, this is the efforts that Dow has been doing to contribute to that. That 11% embodied carbon silicones are typically used for buildings in facades, for weather sealing, for insulated glazing, and for structural glazing. These are the processes involved in making silicone sealants or producing silicones in general. So you have extraction of natural resources, of course, and then you have silicon metal production, you have siloxane sites, you have silicone finishing sites as well. Dow is in a unique position as a silicone supplier just because we are backward integrated. We own all of this process. While some silicone suppliers have only finishing sites, some may have included siloxane sites, but we are the only silicone manufacturer that owns all of these processes in terms of the silicone products that we produce. Now, what's the advantage of that? If you look at the graph here, this is the CO2 emissions coming from silicone production. 2/3 of that comes from the silicon metal production. We have that. That means we can control what we can do on that silicon metal production site so that we reduce the embodied carbon of the products that we are using. And that's what we did. We have sites that use 100% hydroelectric power. We have sites in Brazil, 2 big sites that use audited quartz, audited wood chips, and FSC certified charcoal for the production of silicone metals. Now, right now, it's not technically feasible to 100% reduce your embodied carbon from producing silicone metal. So what do you do with the remaining carbon from your product that you cannot reduce through the use of all of these other processes? You offset them. Now, we have some offset. We do have offsets on some of our products to make sure that we are a carbon neutral product. But one thing about our offsets, we call them more of an inset versus an offset because these are things that we do as a company so that we can reduce our CO2 emissions to zero. Meaning we have our own investment, critical investment on social capital and educational to improve the lives of people around our plants. We also have reforestation efforts wherein for every 1 eucalyptus tree that we cut, we reforest the forest with 7 equivalent eucalyptus tree. Aside from that, we have around 40,000 hectares of protected area in the Amazon forest that will be equivalent to a 60,000 carbon credits annually. So 10 years, that's around 600,000 tons of carbon credits potential. Now, I can say whatever I can say here, right? We as a company can just say whatever we want, but to make it more credible, we want to make sure that there's someone that can audit our processes, that can audit what we say, and that we make ourselves more credible in the market. That's where PAS 2060 comes in. PAS 2060 is a framework for carbon neutrality claims. There are 4 major processes in that. Number 1, carbon accounting. Basically, you understand how much embodied carbon, how much CO2 emissions you have in your processes. Number 2, reduction. Reduce as much CO2 you can for your processes. Number 3, offsetting. If just in case you can't reduce anymore, you offset. And then number 4, validation and documentation. That's what that first 4 steps there talks about. Now, that PS 2060 is done and audited by a third-party company, and eventually we get a certificate for our CO2 emissions for our carbon-neutral facades. This process, by the way, is not one-stop, and this is the commitment for doing PAS 2060. These first 4 steps here continues as we commit to continually reducing our carbon emissions, our reduction of our emissions from our processes. Now, all of this, our carbon neutrality, what can it give you? Well, of course, certified sustainable buildings, and at the same time, it can help you get more points. I'm not sure whether you've looked at the different green building rating system now. The trend now is to concentrate more on embodied carbon. That trend from the US, that trend from Europe is going to come here. For example, the green building rating system in Singapore, Green Mark, had just issued their 2021 edition, and in that, there's one whole chapter just talking about carbon. And this is going to come, all of the other rating system will follow that. Now, our carbon neutrality claim, of course, we have some data and calculation per ISO 14040 and 14044. We have peer-reviewed PAS 2060. We have those LCAs done from using these standards. If you need some EPD, we can share these documents so that we can have the EPD certificates for this. One thing about EPD though, sometimes when you compare different EPDs, they don't look the same. It's because they have different product category rule. Just a point that we want to make. Sometimes you would compare and say, hey, how come it's different? It's because of that. But the point still remains, we have the data that you need just in case for getting those EPDs. Now, with that, we launched our first carbon neutral silicones for facades in the world. This will be for structural glazing, this will be for weather seal, and this will be for insulating glass as well. Basically, all the silicone sealants application that you will see in a facade. Now, that means that this service is actually per project. It's going to be available globally, and at the same time, this can help you get more points on your green building certifications. Now, how does that work? It works like this. There will be a specification for carbon neutrality for projects. Then after that, there will be a request for these carbon offsets to us, and that will be done through a carbon neutral sealant request form. There's going to be a fee after that once we've assessed those requests, and once the fee is given, a project-specific carbon neutrality certificate is going to be given. Now, we just want to point out that silicones, while I am talking about embodied carbon right now, silicone has always been already contributing on the reduction of the operational carbon of your buildings. How? So for example, if you look at energy efficient and material efficiency for your construction, typically you will see 2 types of facade, at least now. These are the typical ones that you see. It's either they are structurally glazed with silicone, that's SSG, silicone structural glazing, that's glass bonded to your metal frame using silicone sealants, or you will see captive systems. Captive systems are, you have your mechanical capture pressure plates on your aluminum frame that holds the glass in place together with gaskets. Now, we can talk about all the aesthetic differences between the two, but the next slide will aim to show you the benefits of using SSG and regarding material efficiency and also energy efficiency considering two basic requirements for facade, structural and also thermal. So for example, we've always known that silicone sealants, because of its unique composition, has very good climatic resistance, weatherability. UV is not a problem for silicone sealants. We know that even long exposure to UV, that sealant is not going to degrade. Very good movement capacity and also very good strength and adhesion to many different substrates. Now, what do those features give you? Airtightness. That airtightness is very important for buildings. If you have we love air conditioning, and you don't want buildings that leak your aircon out, or else your HVAC systems will work even more. Energy-saving multi-panel glazing, IGUs are possible because of silicone sealants, and we know that IGU plays a lot when it comes to the energy performance of your building. And lastly, durability. We've heard different durable products, but silicones, we have projects that are 50 plus years old. In fact, 2021, we celebrated the 50th anniversary of the first four-sided structural glazing project that we have in the world. And that project has never been reglazed. We have never replaced the silicone sealant, and it's still going strong. Now, if we look at energy efficient construction and the way that we quantify it, we've done some studies wherein we look at commercially available facade systems, both the SSG system and the captive facade system as well. We look at representative facade system. Obviously, there's going to be like 1,000 systems out there, but we look at typical representative facade systems with very similar dimension, very similar thermal performance, and we subjected it to the same loading, to the same climatic conditions, and at the same time, just using the same glass. We just want to see the effect of the frame system, the framing system, because that's where SG and the captive system actually differs. As you can see from these two systems here, one has captive systems here, okay? This one to hold the glass in place together with the gasket, and this one is just structural glazing sealant over here. What you can see from here is that your U values can be improved based on this studies that we've done here to around 10 to 25%, talking about the thermal U value of your overall curtain wall system. Next is we look at material efficient construction. Using less is more. If you have lesser material to use, that means lesser embodied carbon on your buildings as well. So we've done a study on checking on the aluminum weight reduction for SSG system and captive facade systems as well. So what we've learned from that study is that using an SSG system can give you the potential to save 15% less on the weight of the aluminum that you will use for your projects. That's one is cost savings, but based on what we're talking here, even more important, on the target of net zero, that's lesser embodied carbon footprint for your buildings. Aside from that, in the life cycle of a facade, let's say an SSG system versus a captive system that use gaskets, gaskets typically will have a life cycle or a lifetime life service of 16 to 17 years. That means after 16, 17 years, your gaskets, you already have to replace them. But that's not a problem with SSG or silicone sealants. You don't have to replace your silicone sealants every 10 years, 20 years, 30 years. 50 years is what we have right now as an evidence, actual evidence on the life service of our silicone materials. 50 years already corresponds to the life service of most buildings that we actually construct today. Aside from that, of course, gaskets, as they age, it has the potential to leak air. Maybe not water, but air can be a problem for you. And that, of course, will lead to even further operational carbon emissions inefficiency, and at the same time, the potential to, again, replace it because they are degrading over the years. Now, let's look at that carbon neutral silicones. So how much CO2 emissions can you actually basically neutralize in a typical curtain wall system? So if you look at this, in a system like this, around 1.3 by 3 meters, for example, this is as much carbon CO2 equivalent per square meter, you are going to be consuming 20 kilograms. That doesn't look big on itself if you look at the curtain wall unit. But if you look at your overall project, let's say at around 30,000 square meter, that will be equivalent to around 600 ton CO2 that you will be having as an embodied carbon in your building if you're not using carbon neutral silicone sealants. Now that's the sealant. I mentioned about the indirect effect on the aluminum itself. So let's just say you have a project 1.3 by 3 meters. Some projects will be bigger than this for sure in terms of the unit size, 1.5 by 4 meters. But I'm just going to use here a 1.3 by 3 meter unit system. So we have your captive facades. We have SSG facade system as well. So how much aluminum are you going to use per unit? If you look at aluminum at the captive facade system, around 12 to 14 kilogram per square meter of facade. And if you look at SSG systems, around 10 to 11 kilogram per square meter of facade. That's the amount of aluminum that you're going to use. Now, how much CO2 emission does that equate to? So for your captive facade, your 12 to 14 kilogram per square meter is 240 kilograms per square meter of CO2. Your SSG system, that 10 to 11 kilogram of aluminum weight, will equate to 190 kilograms CO2 equivalent per square meter. So what's the benefit of using SSG systems? That will equate to around 1,000 ton of CO2 for a 30,000 square meter facade. Again, an indirect effect of using SSG systems for your curtain wall units. There's going to be topic regarding reuse and recycle for sure, because this is always going to be a part of the life cycle of any product. Most of the time, just because of how small that silicone sealant is in your curtain wall units, typically they're not the target of recycling. Typically, you want to make sure you can at least recycle the glass. You can recycle the aluminum as well. The good thing about using SSG systems is that they are very durable. They can last very long, but then you can also just easily cut them if you want to. Easily cutting that silicone sealants that bonds your glass to the frame allows you to recycle your frame and also to recycle or reuse your glass. With that being said, I want to summarize what I've just shared with you guys. Our carbon neutral silicone service is available for structural glazing, available for insulated glazing, available for weather seals as well, and this is a global service. It's available for your projects globally. We want to make sure that this is a credible service that we're going to give you. That's why we have PAS 2060. And the contribution to achieving regional and global targets will continue to be something that we pursue as a company, and hopefully we could all collaborate with you. This will support additional green building points on rating systems. It will enhance the carbon balance, and we're talking about around 20 times with long-term durable facades. And lastly, the potential to design with less embodied carbon, especially in aluminum, up to around 15%. With that, I thank you all. I do hope that we can get the chance to collaborate with you towards our road to 2050 of net zero carbon. Thank you very much.
Thank you very much, Mr. Bautista. ขอขอบคุณ Jayrold มากนะคะ Our next presentation before the upcoming networking break will be presented by Mr. Malvinder Singh Rooprai, Senior Technical Program Manager, APAC Brouwer. สำหรับสปีกเกอร์ท่านถัดไปนะคะก็คือคุณ Malvinder Singh Rooprai ค่ะเดี๋ยวขอเชิญชม presentation นะคะอีกสักครู่ค่ะ
Thank you very much, B, for the nice introduction. Yeah, it's this one. Yeah. Good afternoon, Bangkok. I think this room needs some energy. Good afternoon, Bangkok. That's enough. So sorry, Bangkok, I'm the last hurdle that you have to cross before you get your tea or coffee. So, but I will try to make this session as interesting as possible. So my name is Malvinder, and I'm here to talk about the different interlayers that we have for various applications of laminated glass. For those who don't know about Curare, so Curare is the leading manufacturer of different types of interlayers that are used for a variety of applications of laminated glass. I'm sorry, I think the timer is not correctly set. I'm sorry for that. So glass, as we know, is a very fantastic material. The choice of the architects for any modern building that is coming up. I mean, it's hard to imagine any building which is not making use of glass these days. So it's very, very important that glass that is being selected for any application that is selected very carefully. If that doesn't happen, let's see how the things can go wrong. So I have a very small video which I often like to play in these kind of sessions. So toughened or tempered glass is considered to be a safety glass as defined by many of the country standards all over the world. But I think this video very clearly illustrates that why toughened glass or tempered glass is not really a safety glass when used in such applications. Because if you see the falling debris of the glass, they carry tremendous amount of potential energy that is sufficient enough to injure the people, standing underneath. So just imagine yourself walking along that street, and if glass debris are raining down on your head, things can really go very bad. So when we talk about the safety of the glass, we often relate it to the breakage pattern of the glass. So if we can improve the breakage pattern, we can improve the safety levels. So very simple slide. I mean, on the left-hand side, you have the annealed glass, which is the most, unsafe glass, we can say. It breaks into big shards, which can be very dangerous. Then we have a tempered glass, which has relatively small fragments, but it is still very dangerous if it is used at a certain height, as we saw in the previous video. And laminated glass, this is considered to be the most safest type of glass. But let me tell you that not all laminated glass are the same. So what goes inside the two layers of the glass, that really defines the behavior of laminated glass in a certain application. So I'm here today to talk about the various applications of laminated glass and why for each application you have to select a specific interlayer that is best suited for that particular application. So we will talk about structural, acoustic, and bird-friendly glazing, which is like the most recent addition in our product portfolio. And then security is like also one of the topic which is of interest in the market today. Okay, let's take one by one. First, we start with safety. So safety is coming into picture whenever there is a threat of potential injuries because of the breakage of the glass. So this is an extract from the Indian standard IS 16231. So if you see the case number 4 and case number 3 and 5, and also case number 4, wherever you have an overhead application of the glass, it is mandatory to use laminated glass. So there you can't use a single layer of glass. And also for the glass railings, very recently this has become mandatory to use laminated glass for such applications. Yeah. And some country standards beyond a certain height of the building, it is mandatory to use of laminated glass. So there you can use the standard PVB, which is our Trocifol clear, or the ultra clear PVB that we have. Okay, moving on to structural applications. What are those? These are the applications where the glass is minimally supported. And it's very clear from these pictures that glass has got the minimum amount of support. The glass can be either like supported on two edges, or there can be just point supported, So there glass is acting as a structural element of this application. Yeah. So I have this video which tells how the performance of the two types of laminate is governed by the type of interlayer that you have. So on the left hand side, I have a a piece of glass, which is, you can call it a skylight application. And also it's important to note that this piece of glass is making use of a standard PVB, which will be impacted by a 100 kg load, we can say like accidentally dropping onto the glass surface. And also it's important to note the temperature, which is 50 degrees centigrade temperature. So let's see how does it behave during when this test is done. So you see this red ball, red bag falling onto the glass. So the moment impact happens, the PVB interlayer tears off and there is no safety. We call this as fall-through resistance. So just imagine somebody standing underneath such a canopy or a skylight. I mean, it can be really dangerous. And then let's see what happens when we have a different type of laminate with a structural interlayer called sentry glass. So we repeat the same test on sentry glass laminate. So of course, a sentry glass can't prevent the breakage of the glass, but it can really control the post-breakage behavior of the glass. So this we call as post-breakage retention, which is very, very important for such applications. Yeah. And when we talk about these structural applications, we saw the glass edges, they are minimally supported, which means the glass edges, they can be exposed to the environment. And when the edges are exposed to the environment, it's very important to check whether the interlayer, whether the laminate has got a high edge stability, and it shouldn't get delaminated because of the exposure to the moisture and the UV radiations. So we have done all sort of weathering tests, like the Florida exposure for going on for more than 20 years now. And also these weathering conditions can be simulated in the lab. So we have done thermal cycling, coffin tests. All those tests have been done on the different types of laminates. I think this slide is very, very important, especially from the point of view of edge stability. So the graph that you see here, this talks about the edge stability number of the laminate. So the lower the number, the more durable is your product. You can see this red line at the bottom. This is for the edge stability number of sentry glass. You can see this ESN number for sentry glass remains 0 after exposure to the natural climate conditions for more than 20 years. Whereas the blue line, this is for the stiff PVB, which is another type of structural interlayer available in the market. And then the yellow curve is for the standard PVB. So clearly we can see the edge stability number for sentry glass is 0. So for an application where the edges are exposed to the environment, I will not recommend my client to go with a product that has got a ESN number of more than 0. Yeah. And how ESN number is calculated, you can see this formula over there. It is basically like a higher weightage number is given to any kind of defect which is found near the edges of the laminate. Yeah. Here we have a comparison of the standard PVB, the structural PVB, and the sentry glass. And it's very clear from this comparison that sentry glass is the best product when it comes to comparison in terms of post-breakage performance, structural properties, sealant compatibility, etc. Yeah. Okay, then we talk about another application, which is security glazings. These days, I mean, because of different reasons, security is becoming a big topic in many countries. There is a standard called EN 356 standard, which talks about like doing the ball drop test for the lower threat levels like P1 to P5A, and for higher threat levels, the test is done by using a mechanized X and a hammer, like P6B to P8B. Yeah. So you can see this illustrative image. This is a 4 kg steel ball which is dropped onto the glass laminate. Yeah. And it's also important to not only check the glass, but the framing system as well. So on your right-hand side, you can see the glass and the framing system is tested as per these standards that are mentioned over there. So I would like to play one interesting video over here, which is for coming from US. This testing is basically based on the test method provisions which have been developed by security consultants in the US. So let me give you just background of that, because these days security has become a big concern in the US because of the rising gun culture over there. I don't know what's wrong really with teenagers in the US, but if you see, this glass was impacted with 5 bullet shots when the video starts. And now this man is trying to barge into the glazing with using different types of weapons, you know. The intent here is to increase the effort and time the person will take to get through the glazing. Yeah.
You can flip, use the claw side.
So in the interest of time, I'm just cutting this video short so that we can move ahead. Those who are really interested in this video, they can come to our booth. We have a booth outside, and you can have a you can watch the video longer. Yeah. Okay. Then we move on to the bullet-resistant glazings, which is also one of the interesting topic to talk about. So this is a cross-sectional view of the BRG constructions that are made with the conventional materials like polycarbonate, polyurethane. So these materials have been in use in the industry for quite some time, but they have some limitations. Like the yellow line that you see over there that represents polyurethane, and that is the weakest link in the BRG construction. And also polycarbonate as a material has a tendency to get delaminated when it is exposed to the environment. Yeah. So we worked on improving the BRG constructions by making use of some advanced materials. Again, the advanced material is our Sentry Glass interlayer and the Spall Shield CPET on the extreme right-hand side that you see. So with the use of these advanced materials, it is possible to down gauge the glass thickness, which helps in reducing the weight of the glass construction. And these materials have a proven durability. I mean, these can withstand very high temperatures. Like the standard test for the laminates is like exposing the laminates for 16 hours for 100 degrees centigrade. This is a test which is done on a standard laminate construction. So BRG constructions made with polycarbonate and polyurethane, they can't withstand this this kind of test. Yeah. So what is this Spall Shield or CPET, which I mentioned about? So I have a video to demonstrate what exactly is Spall Shield. So this is a PET film which is applied on one side of one surface of the glass, which we call as protection side. So this is the attack side where the bullet is hitting the glass, and this is the protected side, and there is no splinter formation on this protected side. So you can see this glass was shot 3 times, and the protected side had no debris formation, no splinter formation at all. This is the second bullet, and view from the protection side. Yeah. Yeah, so you can see even after the third bullet, there is no splinter formation. Yeah, this is because of Spall Shield CPET. Okay, then we move on to acoustic PVB interlayers. We have a comparison of the acoustic performance of a single glass, which is 8 mm thick, that gives 32 dB reduction. And then we have laminated glass with standard PVB interlayer that gives you 34 dB reduction. So there is an improvement of 2 decibels here. And then on the right hand side we have, we change the PVB interlayer to acoustic PVB interlayer. So then the acoustic performance increases by another 3 dB, 37 dB. So we have 2 types of acoustic PVB interlayers. Monolayer, which is best suited for architectural applications because of its high adhesion. And the multilayer, which is more suited towards the annealed glass applications because I mean, it has got a medium level of adhesion. Yeah. So I have a comparison for the acoustic performances here. So this is a video from a hotel project that we did. So you see the noise coming from the train when the window is open. So a lot of noise, right? Now let's close the window. So clearly there is a perceptible difference in the noise that we hear inside the room. This is because of the acoustic PVB, the monolayer that we have used for this hotel window project here. Okay, moving on to colors. This is the overview of the colors that we have in our product portfolio. We have some standard colors, the tints, and 2 very unique products, Trocifol Diamond White and Trocifol Brilliant Black. So why they are unique? Because the light transmission for these products is absolutely zero. So you don't see anything on the other side. Even if you have a very strong source of light put behind these colors, the light transmission remains zero. Then we move on to the bird-friendly glazings, which is a new addition in our product portfolio. I believe this may not be a topic of concern for the AP region, but good to know for those architects and facade consultants who maybe are working for European or US markets, because the statistics are in front of you. Almost 1 billion birds, they get collide with the US alone, in the US. I think these figures are really, I think that's telling the sad side of the story. So what is the solution for that? The conventional solutions are making use of this kind of dot matrix printer pattern on the glass surface, so that the glass becomes more visible for the birds. So how this is done, this is very clear in front of you. So the downside of this conventional solution is that you have to do some kind of heat treatment onto the glass surface. You either have to do the screen printing on the glass or ceramic printing on the glass. So which is a compromise with the optical quality of the glass because you get some distortions. So what we have done is we have introduced this dot matrix pattern onto the interlayer itself, so that you don't have to compromise with the optical quality of the glass. And this is possible on Sentry glass and this standard PVB interlayer as well. I think this is my last slide. It's very important to talk about our product Sentry glass, which is also very commonly known as SGP. People love to call it as SGP because once the product was invented by DuPont, our former company, it was called as Sentry Glass Plus, but the official trade name of this product is only Sentry Glass. So it's a humble request to the architects and facade consultants working on different projects. If you really want to get and make sure that your client gets what he is paying for, that you should write in your specifications only Sentry Glass, not SGP. Otherwise, what will happen, you may get a fake product by the name of SGP coming from China. Yeah. So please remember, The correct product name is only Sentry Glass. Yeah. That's all. Thank you. Thank you very much. Yeah.
Thank you very much, Mr. Rooprai. ขอบคุณคุณ Rooprai ค่ะ May I invite all the speakers from this session to stand by the stage to receive the mementos, once again given by Oliver. Okay, we're about to welcome our last solo speaker of today before the panel discussion. So ladies and gentlemen, please put our hands together to welcome onto the stage Mr. Chanin Kulsurakit, Senior Sustainable Designer, Energy and Environmental Analyst, Magnolia Quality Development Corporation.
Okay, good evening everyone and welcome to my presentation. Today, my topic for today is the breathable facade innovation for well-being. Okay, I will start with why we need the ventilation for facade design, and then I will move on to the second part, how to make a good building environment from facade design, and finally, I will go on to talk about the next generation of ventilation facade design. Okay, let's start with the first topic. In general, problem of the ventilation facade design is the lack of ventilation that can cause of the space with high temperature and moisture accumulation in indoor space. And both of the environmental problem that can affect to the occupant in two ways. First is the damage on building components, and next is the effect on the health and well-being. And here is the effect of the damage on building occupant, on the building components. Okay, the wall cracking and sealant failure. A high temperature in indoor space can damage some building materials like plaster or mortar, and sign of cracking will occur. And the viscosity of the sealant that we use to join the glass with framing will also vary with ambient temperature. And the hot air makes it sag, and cool air makes it stick to tool properly. Wall cracking and sealant failure can affect to the building air leakage, like hot air leak from outside at daytime and cool air leak from inside at night when we use the air condition. That affect to increase the whole building energy consumption, especially in space cooling. Okay. Another problem is the effect on health and well-being. The space, the lack of ventilation in indoor space can cause of the collector space collect too much temperature and humidity that affect to a sign of mold and fungus on the furniture and furnishing. And you probably noticed by fuzzy black, white or green patch on the wall and ceiling. And the most harmful condition is the mold and fungus grow in the blind area that you can see the sign of them. That is can harmful to your health silently. Okay. As a consequence of the space collect too much damp and moisture, it can produce an allergenic compound like the mold spore or dust mite that go well in damp place. And when the mold growing on surface, the spore can be released to the air where they can be easily to inhale. And if you have mold allergy or asthma, the symptoms will trigger by exposure to a large number of mold spore. Okay. The furniture and many products we use in household are exposed to the VOC during the manufacturing process, and it will release them to the air by the process called off-gassing. And if we expose to the high level of VOC in indoor space, it can be have an irritation or allergy reaction with severe health problem after prolonged exposure. As you see on chart is the correlation of the indoor VOC emission and temperature. The VOC emission will reach peak at the summer when the temperature is at the highest point of the year. The next problem is the carbon dioxide concentration. Is the carbon dioxide concentration is the suitable for living indoor space is 10,000 ppm. Okay. In the first topic, I will talk about the effect on the lack of ventilation. In this topic, I will show you how to make a good building environment from building facade design. Nowadays, there are three major factors for sustainable facade design. First is design for visual quality, and next is design for the building energy consumption, and the last is the design for using the benefit of daylight. And another one that we need to focus is the health and well-being. We have two residential projects near the Chao Phraya River, the Magnolia Waterfront Residence and the residences at the Mandarin Oriental. They come with a large balcony and bay window to take the river view. That we need to concern about the visual quality and the energy consumption. So the building come with the vertical shading device on east and west direction and horizontal shading device on the south direction to protect the direction. From the case study, you can see they come with the facade design to serve the visual and energy concept. But another one that we need to focus more than the visual and energy is the health and well-being factor that relate to the human comfort and the good environment, including with the ventilation or the fresh air intake. Okay. Most of the problem that we found in the high-rise residential building is the single-side opening that can cause of the high pressure in the room that affect to the outside air cannot flow to the depth of the room. Let's have an innovation product to improve the, ventilation performance along with the health and well-being. As you see on the slide, we have ventilation door, we have single-side ventilation window and DOS AC. I will start with the first product, the ventilation door. Ventilation door is aimed to reduce the room pressure and improve the ventilation performance by taking the outside air flow to the room to the corridor space to reduce the room temperature and humidity. The first prototype comes with ventilation unit installed with the HEPA filter and carbon filter to protect the air pollution. In the next version, we try to improve sound quality by reduce the ventilation unit in a small size, and we use the CFD simulation to prove the ventilation performance at the same. The latest version, we combine the emergency damper, connect with the fire alarm system, and it will close automatically when fire alarm is noticed to protect the fire and smoke in case of fires. Here is an on-site installation. And the next product is the single-side ventilation window. As I say, too much pressure in the room can cause of inadequate ventilation in the depth of the room. We try to improve both visual quality and ventilation performance from single-side ventilation window. And we use the CFD simulation to study many types of openings and find a suitable design for improve both visual quality and ventilation performance. And the latest design, we separate the opening above and below to improve the air circulation performance to reduce the room temperature. And here is the on-site installation of our product. And in the last topic, I will talk about the next generation of ventilation facade design. In my opinion, the next generation of ventilation facade design is not only to use the natural ventilation, but also including with the mechanical ventilation, work together to improve the ventilation performance completely. Because nowadays there are many pollution in the air, surely the natural ventilation is a good choice to improve air quality in indoor space. But if we deeply focus on health and well-being factor that I mentioned earlier, the ventilation that we need is the real fresh air. The real fresh air is the air that we can control the uncontrollable factor like the humidity, the air temperature, or the particle dust like PM 2.5, and we can dedicate the fresh air to indoor space in any weather condition. Okay. From the intent to protect the air pollution while taking the fresh air to indoor space, we have to develop the innovation product to dedicate the fresh air to indoor space, combining with the building facade design. The DOS AC is a combination of the well-being concept that we use in our project. First is the central utility pan. We use the central utility pan to dedicate the cool water to the air conditioning system, and we use the natural ventilation to improve the air quality in indoor space along with the low energy fresh air intake. The system can work in two modes. The cooling mode, it can dedicate the fresh air with cool air to indoor space, and non-cooling mode, they dedicate only the fresh air without cooling and work together with the ventilation door to let the air flow to the room. We have the short duct design for supply and return air to protect the dust or the green stick on inner surface of air duct. That is the cause of many diseases and bacteria. And we combine all ventilation system in single unit and install it outside the room at the balcony to reduce the installation area. That is the pain point to obstruct the aesthetic design of interior decoration. And we try to mix the return air with the supply air to reduce the air temperature before take it to indoor space. And the system combining with the two components. The first is the cooling coil unit installed at the balcony and the chiller pan to dedicate the cool water to chilling. And indoor space, we have the IAQ sensor to detect many air pollution like the VOC, the CO2 concentration, or the PM 2.5. Another idea that I need to focus on the next generation of ventilation facade is the breathable facade. An engineering element in the MEP system is not a bad thing that we don't need to conceal it outside, but we can combine it with the architectural design to improve the surrounding air quality before take the fresh air to indoor space. Normally, the chill water pipe is installed in the building to dedicate the cool water to air conditioning system, but we think different. We try to improve by combining it with outdoor facade design to improve the outdoor air quality around the building. Just like we can reduce the cooling, we can cool the ambient air temperature, or they can work like the double skin facade to protect the solar radiation. And here is the interesting facade technology at the Sony Osaki building at Tokyo. They use the rainwater to circulate the air on building facade to protect the heat reflection. That's the main cause of the urban heat island effect. As you see on the left side is the chiller facade prototype diagram. That we have the plate heat exchanger to exchange the water temperature between the water from chiller and water from the tank before circulated in the facade. And here is the latest version of chiller facade design. We combine aluminum pipe with aluminum covering and apply them to many building components like the louver or the railing at the balcony. And from the innovation, all of the innovation that I mentioned earlier, all of them can combine it in the single system we call cup comfort system. And we can combine it with the building facade design to work together to improve the ventilation performance, also the health and well-being factor completely. Thank you.
Thank you very much คุณชนิน Thank you ขอบคุณคุณชนินมากนะคะสำหรับ presentation ค่ะ All right, ladies and gentlemen, I hope that today's conference has been very fruitful. The panel discussion is about to start, but we hope that Today you've obtained a lot of very useful information. We have featured over 20 speakers from around the world who have shared with us very valuable experiences, information about their projects, their expertise and their insights about very different areas. So I hope that that can be very beneficial for you and your company in the future สำหรับวันนี้นะคะเราก็กำลังจะเข้าสู่ช่วงสุดท้ายของการประชุมแล้วนะคะก็คือช่วงการสนทนา panel discussion ค่ะวันนี้ทั้งวันนะคะทางเราก็ได้นำเสนอสปีกเกอร์นะคะกว่า20คนนะคะจากหลายๆประเทศทั่วโลกที่มาร่วมแชร์ประสบการณ์ข้อมูลต่างๆเกี่ยวกับโปรเจกต์นะคะที่ได้ทำมาแล้วก็ความเชี่ยวชาญทางหลายๆด้านเลยนะคะก็หวังว่าหลายท่านก็คงจะได้รับข้อมูลที่เป็นประโยชน์เป็นอย่างมากกลับบ้านไปวันนี้นะคะแล้วก็หลังจากนี้นะคะก็อย่าเพิ่งรีบกลับนะคะก็จะมีอาหารนะคะให้รับประทานกันอีกนะคะแล้วเป็นช่วงเน็ตเวิร์กช่วงสุดท้ายค่ะ And after this panel discussion, please don't rush home yet because we do have another networking reception for you all. And of course, there will be food and beverages provided for everyone as well. So please enjoy this next session. All right, I think right now we are almost ready for the panel discussion. So I would like to hand over the stage to our moderator for the session สำหรับตอนนี้นะคะคิดว่าทางทีมงานก็พร้อมแล้วนะคะสำหรับการเข้าสู่ช่วงของ panel discussion นะคะถ้าอย่างนั้นดิฉันขอส่งต่อเวทีนี้ให้กับผู้ดำเนินรายการ panel discussion ของเราต่อไปเลยนะคะ Ladies and gentlemen, on this occasion I would like to invite to the stage our panel moderator, Managing Director, V2 Design Studios, Mr. Wisut Sukapong ค่ะค่ะขอเรียนเชิญค่ะ
สวัสดีครับไม่น่าเชื่อนะครับวันหนึ่งผ่านไปอย่างรวดเร็วเราผ่านมา18โปรแกรมนะตั้งแต่เช้าจนถึงวันนี้นะครับก็เป็นอีกหนึ่งวันที่เข้มข้นไปด้วยเนื้อหาที่หลากหลายนะครับผมส่วนตัวแล้วมีโอกาสได้จอยกับทางแซกฟาซาดเนี่ยน่าจะครั้งที่3ครั้งที่4แล้วนะครับครั้งนี้เนี่ยแชร์อย่างนี้กันครับว่าเป็นกลุ่มเนื้อหาที่ค่อนข้างจะหลากหลายและน่าสนใจมากๆนะครับ Good evening everybody after a long solid day for me this is like a journey of facade approach in various consultant, designer, technical. Allow me to wrap up today's activity with the panel discussion. My name is Wisu Sukpong. Today, we're going to host this panel discussion. Let me introduce our first specialist guest. He is the architect, designer, both architecture and landscape. I have a long experience, very solid experience for the hotel and resort, many interesting projects, and now he's senior architect of SODA or Stephen Architects. Please welcome on stage, Brian Gillett. The next one, another long, solid experience. He's now holding the managing partner of Stephen Lees, Junior and Associate. Have a long experience with the high-rise building. You may notice the Singh Tower, also AA Tower in Sathorn. Please be welcome on stage, Mr. Donel Dippi. The next one, he's an engineering background from Switzerland, and now he's in Bangkok. We take care of the company who be a leading of the curtain wall solution for low rise and high rise. Please welcome Mr. Oliver Brunadis, Chief Representative, Chugo, Thailand. อีกท่านนะครับเป็นวิศวกรนะครับ He is an engineer with more than 25 years experience in construction management and project management. Take care of many retail large-scale projects. Example of the Siam Paragon. Now he's the managing director of Project Alliance. คุณณัฐพล แสงสรสิทธิ์ครับ เชิญครับ We have a long day with many technical approach. We have many various facade approach from many consultants, architects, supplier, manufacturer. We run through the engineering challenging from poetic timeless beauty from A49, technology cutting edge for the material, even down to the energy and sustainability. For me, it's also important to implement this type of things, and we want to share the solid experience as you practice. My question starts firstly about the process of working. We noticed that the facade design take more and more significant role to increase the project value. And to achieve that level of quality, we need a proper process. I would like you to share the experience from each of your approach, how you can get the optimum process of work, and how that process can increase the project value. I would like to start this question from Brian.
Yeah. Oh, it's loud. I think in terms of process, one thing that can't be overlooked is we use Revit in our office for all of our projects. That's a BIM software, Building Information Modeling. And that is an indispensable tool, in my view, for collaborating between all the different disciplines, contractors, fabricators, and down to suppliers. I also think we try to, as best we can in our projects, employ an integrative design approach, where collaboration between all parties, all stakeholders, all design disciplines begins as early or in the beginning of the project as much as possible. And I believe an even more efficient approach is the design-build project delivery method, where the contractor is engaged very early on or in the beginning of the project, and the contractor participates throughout the design process. I think this yields a very efficient design and construction process with higher levels of building performance, individual and team performance, innovation, creativity, and reduces overall project costs. The question about optimization of the design, I think when I think of optimization of the facade design, I consider two metrics really, being the performance of the facade and the functionality of the facade. And I think what's important is I work on projects of vastly different scales, from big infrastructure projects down to a single residence. And so I think what's important is the facade design. You need to approach it at a very project-specific manner. We would treat a single-family residence, we would treat the facade design very differently. There's than say a high-rise hotel or an office building. So.
Totally agree. Facade designs requires many coordination among the consultants, and this would help us a lot to let it work on the same page. Also communicate to the client and the team as well.
Yeah, and I think as early as possible in the design process is the important thing.
Interesting. Thanks, Brian. How's about your idea, Donel?
Thank you. Can everybody hear me?
No.
No. Can everybody hear me?
Oh.
Can I borrow your microphone? Good. Thank you. Look, I know it's been a long day for everybody.
And a lot of what Brian said I would absolutely endorse as well. The one thing I would say, and the clients you're designing for, I'm not sure what the profile of the people out here are, but if we're designing for clients who've got a long-term vested value in the project, and for example, AIA Saturn, the clue is in the name. The client's name is in the name. And so they've got a long-term vested value in how that project performs and how it looks over its life cycle, not just to the day they transferred. If we work for a developer who's selling residential real estate, the day they've sold it is the day they're finished with it. And so their interests are very different. And as the designers and as the architects, we're always trying to find a balance between the project's interests, the end user's interests, and our client's interests. But on top of that, we're also trying to add and stamp it with an aesthetic identity. And I've seen today and I've heard today suppliers and manufacturers talk about the technical performance of the facade and the life cycle of the facade. And architects bring one other element to that equation, which is the aesthetic value of that facade. And it has something. Everybody here will have a preferred building around the city. We may all disagree on what that building is, but we'll have a preferred building. And so in the process, the one thing I would say is that you can never start the technical discussion of the facade's performance too soon. You can never have the discussion with suppliers and with manufacturers too early on, because as much as architects and engineers think we know, we are permanently learning. And manufacturers will have preferred ways of doing things, and we can never have those discussions too soon. And the one thing I've learned in all of the buildings, from the smallest, from residential to very large, is that we should be open to learning new things, and we should be opening to manufacturers and suppliers' approach to the problem, because they will have an approach that is more technically correct than our interests. And so we should be open to those technical preferences, because they will stand by their product long after the developer, long after the architect, long after the project is finished. And so usually their interests are ultimately in the project's interests as well. Maybe that's enough of my time.
Oh, thanks a lot. That's very, very useful. I think the right moment, that is the key for this, the right moment.
Yes.
How about from your opinion, Oliver?
Yeah. As a system supplier, we of course don't want to be the last to be involved in the project, right? So as you said, Donald, and also as my colleague in Singapore said, we should be involved as a system supplier actually in the design stage, so that we can give you the most innovative products we have. We give you access to the specification, to the sections. We can also support in doing customization, value engineering at a very early stage, yeah, to optimize the cost and give you insights about our systems or futures we have, yeah, like ventilation or sound absorbing materials and so on. There's actually an endless variety of choices which we can offer, yeah, and therefore it's really, really important not to call us, after the award, like 8 years ago, maybe it was like this, that fabricators call us when they have been in the tender stage. That is actually really late. It doesn't allow us to give full potential of all these abilities we have, yeah, to optimize cost, optimize design, optimize the performance, and all these kinds of aspects for, yeah, delivering a very good facade at the end. Yeah.
Yes, totally agree. I think the expectation from the client and the professional practice also more and more complicated. So this is quite important to be engaged at the right time. How about from the from Natapon point of view in terms of construction management and project management?
For me, I'm the one who like a driver, as Kun Brian and Kun Donald said, and Kun Oliver, it's the end of the product, but you both at the beginning of the product, right? But I'm the one who like a driver who drive this kind of thing until it finish. As a driver, I see many kind of these kind of things, seen at the original to the end. There are 3 stages that are important for for make your dream come true. One is the design. Second one is the procurement. And the last one is the construction. This is I'm talking about from the overall project development, that what is my role involved as a project management or project manager. So what is the important thing for these three stages to make our best quality of the facade? Okay. I'm starting with the design. But of course, as you both said, that we as a PM, apart from the designer, we have to understand the real requirement and expectation of the owner, truly understand, because we are the chairperson who leading all the design management, design program. We control the time and a proper thing that make sure that the owner get a real thing as the designer want. And the designer decide that he want to be like this, as per the designer want on time. So one of the important thing is we have to understand what the owner want at the design stage. Another thing is, I would say, I talk this kind of thing to many people, is about the cost control. I met many owners, and I suggest him to do it, we call the cost plan. Cost plan is mean the total budget of the project that you are developed during the design development on each stage, from the preliminary, from the schematic, concept schematic, design development until the for bidding. These stages of the design should have cost to control it. Okay? And in order to determine the quality of the product, you have to put into this cost at the beginning. Right. Because if you have put a wrong unit price to the cost plan, so the owner will set this one is like a total budget. So you did at the beginning, at the procurement stage, because you don't have enough budget. So the cost control at design stage is very important. So that's why as a project manager, I will try to control that. I suggest. Of course, when the design finished, we as a project manager have to check that we have a proper specification as per that we want. All the VE should be done at this stage, not waiting until the end. Make sure that the cost is, we agree on the cost. This is the design. Second one is the procurement. This is the important stage as well. There are many can happen during the procurement. I mean, when you find the contractor to do the facade, especially when you put the facade package into the main contractor. This is from my experience, because many offer or many choice can happen, and the facade quality will be the first list of the work that you can reduce the cost. Of course, when you reduce the cost, the quality will reduce too. So as a PM, you have to make sure that what is the quality of each work. Because facades work for me is like a work. It's kind of semi-design and build for the contractor. It's not like a structure that you put a concrete and reinforcement that everybody can do. But
it's more than that, yes.
You have your professional, you have to pattern that to control of each manufacturer. So the procurement is quite difficult to do it. You have to control carefully. The last one is the construction. Starting with the good combination with artwork, you have to do it carefully. And then shop drawing, you have to make sure that it's detailed enough. Otherwise, if you don't have a good combination and good combined drawing and shop drawing, it's not good. The work will not good. Okay. The construction method, how to compose or disassemble these facades and glass together with that high level is also very important in terms of construction. And the last one for the construction stage is the inspection. You have to clearly identify that what stage of work that need to be inspected before you proceed to work. This is in order to control the quality of work of the facade. That's all.
Thank you ครับคุณนพดลครับ many very useful point from your answer Could I step to the second question? It's about the problem. It's about the pitfall things. Many times when we develop the facade things along the way, it's always have the hidden problem or the pitfall, and I think it would very helpful, very useful to let you share the experience on this kind of pitfalls and how do you handle it. คุณ Oliver ครับ maybe you could share this point to us in terms of like from your approach.
Okay, as a pitfall for us could be the situation that we have been brought into a project at a very late stage. So we have to partner up with a partner who is maybe not equipped with the software, with the training, with the machines, which are necessary to produce a good quality product. And sometimes I feel like contractors have maybe sometimes a bit big eyes and the belly, is not matching, somehow. And that is a big challenge. Also that, for example, when the teams are not there, like the design, production, proper management, project management, site coordination and installation teams, if this is not there because the contractor is not experienced in doing such kind of other type of job, then this can be a very, very high risk. I hear sometimes from developer, I choose them because they have been the cheapest. Yeah, but the cheapest contractor may not have the capacity, not have the experience and knowledge and everything to do a good job. Yeah, and then even when you involve Schüco as an experienced partner, it's very difficult for us to keep the quality level continuously on a highest level, right? But especially also with COVID, for example, we can say we have experienced that the teams change, during the project a couple times. So this is for us like a reset, and you go back and train and train and train all over again. So this is really a situation which we would not want to be in again.
So how do you handle this situation?
The best is, as I said, if we get involved at a very early stage, we have a wide partner network, right? So we can bring in the right partner with the right capacity and the right experience into the bidding process, or introduce them, or invite the developer to go and visit the factory, to bring the right people together to deliver good quality until the end of the project. Yeah.
Yes. Do you have?
I would say.
Yeah.
Please. I think it's working. I think they figured it out. I would say as well that for all developers, being able to define and be honest and realistic about their expectations, both in terms of budget and in terms of performance. It's very, very hard to get that information honestly on the table early on, but it's infinitely valuable because it allows everybody around the table at a design level and at a project and product delivery level to be able to tune their product to suit that expectation. Getting an honest budget on the table early on and knowing what that is an infinitely more effective way of designing a solution than getting an aspiration that then has to get value engineered and value engineered and value engineered too late in the game, so that what you end up with is something that is the cheapest contractor because it's the only one that meets the budget, because the budget has been wrong. And that's not a criticism, it's just trying to get everybody to be honest around the table early on so you can get the right input and you can get the right product and you can get the right solution. And I think without a single exception, in the next week, 99.9% of residential windows will fail in this city, not because they're necessarily wrong, but because the weather and the climate environmental conditions are changing. Every building is going to fail in this city as climate change takes its real grip of, the world we live in.
Yeah.
And that's, if that's a pitfall that designers and product manufacturers and developers have to face up to. And it's out of our control, but it's going to keep changing until something way beyond our control steps in. But we're going to see facade failure after facade failure. More so in residential because the standards are build it, sell it, walk away. Where you're doing hotels and where you're doing office buildings, their life cycle and their involvement of the owners is much longer. But, this global warming is going to take such a toll on buildings. As I say, I guarantee in this week alone, 99% of all the windows or all the buildings will have window failures in one form or another as the wind patterns change, as the driven rain patterns change. And we're going to get water egress, we're going to get ingress, we're going to get water coming in and consequential failures. And if I had to give one piece of advice for developers, residential or office or hotel, is using a branded product where you've got the name of the manufacturer as your guarantee. It's the cheapest insurance you will ever get because anything else will be less than perfect.
Thanks, Donald. Any comment, Brian, on this?
Yeah, I think maybe to build off of what's been said and to maybe also slightly shift gears is I see all too often, facade design is driven by developers' spreadsheets and cost plans and or aesthetics, or sometimes the facade is just literally a resultant of an internal area, an internal floor plan. And I would argue that to build off of the global warming and sustainability issues and building performance related to these conditions is, I think that facade design should be intentional, and we, in order to maximize internal comfort and building performance, we need to address climate and environmental and site conditions first as the primary objective of the facade. I mean, the facade is our physical barrier between an internal environment and the natural external world. So it is something that we interact with every day, almost nearly every minute or every hour of every day. It's an immensely critical moment in architecture that needs to be considered very holistically.
It's always being a challenging to communicate this awareness. The client, especially the one who take care of the spreadsheet and bottom line, and many times they just look at the figures just to determine the quality.
And as Donald said, I think, if that is presented up front at the beginning, it's transparent, it's clear, we all know what the objective and the expectations are, that's okay, at least we're aware.
Yeah. Maybe I ask more, I have a short discussion before, during the COVID, and someone mentions about the logistic or another like a shortage of the supplies or some kind of material that could affect our construction process. This is effect on your approach or on your practice, Olivers or Kun Natapon. What is your opinion on this one?
So what Shiko is doing is start after agreeing with the budget, we consider how we do splitting up the material. So we have lots where we supply big amounts of materials over a period of time. So we call this order schedule, but actually we consider all other things also in this planning, which means the material comes from Europe, comes with the ship here, right? We also include maybe a little bit spare time in case the ship missed the transit or there's storm or there's Suez. Okay, Suez Canal, that was a bit special case, but something can happen, right? And we include this time in our schedule, and we discuss this with our partner. We discuss this also with the main contractor, with the project management, that we have a lead time of this. We have also production time, and so on. So we consider every phase, every stage of the project, and have a good timeline in. And yes, of course, COVID, honestly, when COVID outbreak in 2020 came, I was really, really afraid that we cannot supply. Yeah, I was worried that, you know, factories get shut down, our warehouse will be empty in a couple of weeks, and we cannot supply to those projects we have secured. So, but thanks to our company and a lot of people who worked very, very hard, almost 24 hours, they make it happen that we could supply. We had maybe delays of 1 or 2 weeks max, yeah, but we could supply. And also, as I said, because of a good planning, we always communicate very clearly with the customer, look, it will take that much time. You also need to have time for production, and so we have to be honest and consider also a little bit time in case something goes not so round, right? So this can be discussed, this can be planned, and yeah, we have not produced any delay from our side. Yeah.
Superb. Any comments or point from your CMPM point of view in terms of pitfall, Kun Nathapol?
I can think about many pitfalls because what of my involvement is very long period. But I just raised one sample. This is about one of the procurement thing, about the bidding thing. What is the pitfall? And actually, it's not just only the facade work. I think it's maybe the whole quality of the construction. It's beginning, as I said, since the budget and the design. I mean, if the design, they have one value, but it's not as the budget. And we start bidding. Since we know that the design is more than the budget, but the owner or the client or the team have no time, and they just don't believe in cost span or whatever, and they just want to test the market by start bidding. Once you test or you start bidding, because we don't know, I mean the contractor, there are many kind of contractor. I mean, they may need work right now, or they have enough work. So once you start bidding, you will get a strength offer. Okay. One that a real sample happened to me is on the final negotiation round, and one contractor come with the figure that's still higher, maybe almost 10% higher than the budget. Okay? And the client tried to negotiate for this 10%, so which is impossible to do as a profit. They cannot reduce their profit for 10%. So the last conclusion is, okay, I can discount 10% with condition. This word of with condition is a big pitfall. Once you agree on that condition, with what happened to me is they haven't clarified that condition clearly at the meeting. They just talk to the owner directly, and then the owner who be the biggest of the client said, okay, I agree with you, I award you right now. And the whole team didn't know what they agree. One of the things that they agree is the specification of the external wall. Because they know this is, I mean, I saw from the specification, the standard is this high, right?
Yeah.
But
so they down spec.
They downgrade. But they just appear this item when they work for maybe 6 months, or they start working, they already signed the contract. And then this is the condition that they make with the owner that they want to do. They call value engineering or whatever, but the quality of the facade is to be the different one. So nobody can do, I mean.
So I must also say, in terms of specification, either they are far too high, yeah, and blow the budget up, or they are not sufficient. And non-sufficient specification lead to that a developer can get, all kind of quotations and with, like we always say, bananas and kiwis. If they are not clear with what they expect to have in terms of performance, yeah, and more, then you cannot compare quotations, right? So we need to be very clear in the specification actually what we are looking for. What are the expectations? Otherwise we get a result of 10 different quotations and nothing is clearly stated, which allows everybody to supply whatever, low-grade sealants or whatever. It's just a mix of quotations which cannot be compared. And in the end, they just look at the number, yeah, and take the cheapest. But they don't know actually what they get in the end, right? So being clear with the specification, also maybe understand that if it's too high, then let's downsize this in the beginning and not at the last week of a tender process, right?
That's also classic for me too.
I think the work that's similar to the facades work, because facade, I think we know that the quality is, the element of the quality of the facade is frame, right? The glass and also all the fixing equipment, fixing component. There are also other package very similar. For example, one is kind of AV work. This is very easy to understand. The AV it means audio and video. For example, on this room, right? You cannot design that because the speaker itself, the AV equipment, you cannot compose it, you cannot build it by contractor, but you have to buy it from the supplier. So they have brand, they have standard, they have very various quality, right? But if the designer as an AV have to identify the brand of the speaker, which is not good. So this is similar. I mean, when you try to compare and select this kind of work, the IT, the AV, and also the lighting fixture. The lighting fixture is also very various quality of work. So that's why I would say the facades is also similar, that when you doing the process of procurement or purchasing, you have really carefully and very closely coordinate with the design consultant, make sure that the quality is still maintained. Otherwise, they are in the market. There are many other brands, other things that lower quality with a lower cost will come anytime. So we need to focus on this when you do the procurement.
That's why we need proper PMCM like you to get involved for this project. May I lead to the third question I prepare? I'm not sure. It seems like you answer me already or not. Don't know. But from your point of view, designer point of view, architecture point of view, do you see any factor, trend, or concern that gonna affect the way we develop the facade designs in near future?
Look, I think the beauty about architecture and the beauty about buildings and the challenge about architecture and buildings is that they're not proprietary. They're not something that you buy off the shelf like a car or a speaker or a radio or a TV or a refrigerator or anything else. They're the result of a huge collaborative process, and on top of that, you then have the main contractor and all his labor. And so there are so many variables and so many unknowns that go to the production of a building that it's an enormously challenging process. It's a challenging process for everybody, for the developer, for the manufacturer. It's challenging for the architect, it's challenging for the project manager. If there is an opportunity or if there's a direction that will take some of those challenges and risks away, it is the process of prefabricating, and the more we can shift the product that we are trying to deliver into a more prefabricated factory environment. Anything we can do in a factory has got better quality control, has got better standards control. And so the
Absolutely
more we can
right.
shift it in that process, and that's not to take away the luxury of design, it's not to take away the opportunity for designers to be bespoke and unique, but it's to take away some of the risk. At the end of the day, the biggest thing that we have to face is the risk that what we design does not perform the way we expect it to perform. And as I say, there are so many variables in the process of delivering that product. The risks are enormous. The anxiety is enormous. You know, every time we face a bid, you know, one of the first things we're looking at is, well, what's your professional liability insurance? And we just hope we're not the highest insurance, because when it fails, we're the guys that will get sued because we've got the highest professional indemnity. But that's a huge opportunity to shift not just the risk, but to shift the quality of the product, raise the quality as we prefabricate and as facades and everything else in the building gets prefabricated, bathrooms, everything that can be manufactured in a factory and prefabricated and delivered as a complete product into the building is reducing the developer's risk, is reducing the designer's risk, is reducing the product risk. And that's a good thing.
Totally agree. Any ideas on this, Brian?
Yeah, green building and sustainability are by no means upcoming trends. I think they're deep-seated and very worrisome realities of our profession. You know, I'm an architect and a landscape architect, so I'm kind of always looking for new technologies and new sort of living ecological systems that may be fixed to or serve as part of the facades, you know, whether these are living walls like green walls and vine structures or unstructured planting. But we just had a presentation about air quality, you know, and I think something like 2 million people die every year due to poor air quality. And one of the magnificent benefits of plants is they actually help purify the air. They remove, you know, pollutants such as VOCs and particulate matters and sulfur dioxide, nitrogen dioxide. They absorb carbon, you know, they absorb carbon and give us oxygen, which is a pretty good deal. So I think, you know, integrating vegetated systems and ecological systems into the facade and into the building envelope as a means of helping to do many things, not just improving air quality. I think is something that I'm always looking for new advancements, and I think it's an exciting part of the facade conversation, and it will continue to develop.
Thank you, Brian. Any ideas on?
So we have an air purifying device in our booth, which you can have a look. It is exchanging the air.
Through plants?
In a facade, for example, if you don't have windows inside, you can exchange the air. It measures the CO2 level, the PM 2.5 levels. So this is also one of the things we have, which can be integrated in the facade, also to improve the well-being of the people working or living in a building, right? So there are endless solutions we have actually. Just contact us in an early stage and we are happy to help you.
We have some couple of minutes left, so maybe I should take this opportunity to open for the question.
Yes, please.
From the audience, just in case anyone want to ask anything to anyone, you could raise your hand.
Any question, please?
Everyone's tired.
Yeah.
Everyone tired.
It's a long day.
Looking for the dinner. Okay. I would like to thank you, all of you, for your experience and vision and comments. I think that's very useful for us all to bring this to adapt and apply to our each of professional approach dealing with facade design. So thank you and have a good day. May I hand over this back to the team? So Thanks a lot. Thanks a lot.
Thank you very much for your
very much.
patience and
Thank you, everybody,
interest.
for listening.
Thank you for
Cut the
coming.
mic up.
Okay, thank you very much. That was a very fruitful panel discussion, and please remain seated on the stage, please. And next, to give an official closing to today's conference, I would like to hand over to Mr. Ahmed once again. Mr. Ahmed, please.
Thanks, B. So thank you all for being present here. Really appreciate you coming out here in person, especially with the challenging weather conditions. So as I mentioned in the morning, we've recorded this event. We'll share a YouTube link of today's event. We won't be sharing the presentations, but we'll share the YouTube link which has everything recorded. I'd like to thank our event partners for being patient with this event. Originally planned in March 2020, went through a lot since March until now. So finally, the monkey's off the back. I'd like to thank our speakers for today, our panelists for today. I hope the content and the discussions they've had today was of useful knowledge for you, which you can then use in designing your facades. So thank you all for being present. We'll take a photo session now with the speakers. But we have a networking cocktail session sponsored by Shuko outside, which they would like to invite all of you for the same. So you could go for the session. We'll finish the photo session with the speakers and join you there. One last thing before I leave, I'd like you to give a round of applause for our host for today, B. She did a fabulous job. So a round of applause for B. She was excellent today. And thank you, B, for your excellent convening of the event. So thank you all. Hope to see you next time, maybe in March 24, when we return to Thailand with the next edition of Zak World of Façades. Thank you.